Hey guys, welcome to this live session by Intellipaat. In this live session, we're going to teach you everything about Python, from the basics to the most advanced levels. So before moving on with this session, please subscribe to our channel so that you don't miss our upcoming videos. And also leave a like to this video or all the videos you have watched from our channel and enjoyed it. So now, let's look at the agenda before moving on with this session. First, we'll start off by understanding why to learn Python and understand the career options for a Python programmer. After that, we'll show you how to install Python on Windows. Once that is completed, we'll start learning the basics of Python. We'll start from Python variables, tokens, conditional statements, looping statements, and also we'll be looking into operators and linked lists. Once that is done, we'll move on to more advanced concepts like Lambda functions, classes and objects, NumPy and Matplotalib, and also file handling. Once that is done, we'll extensively understand exception handling. After that, we'll learn how to use Pycharm. Once that is done, we'll be looking into some important concepts like text mining using Python. After that, we'll be looking into Twitter sentimental analysis using Python. Once we understand all of these concepts and do some practicals with it, we'll move on to the Python projects for beginners. So some of the projects are building a REST API using Python. Then we'll be understanding how to create a game using Pygame. After that, we'll be understanding basically creating a COVID-19 global prediction using Python. And finally, we'll be looking into credit card fraud detection. Once all of this is completed, we'll be getting into the interview questions for Python, which you can start learning if you have to basically crack an interview. So that would be the end of this live session, guys. So I hope you enjoy it. Now let's begin with this session.
What is Python? Well, ladies and gentlemen, you need to understand that Python is, a very nice programming language to work with at the basic level. And if you're thinking, okay, so what is it used for? Well, what is Python exactly? And all of these questions flooding your mind right now, well, let me answer that. Python is basically an object-oriented language where, all the data is considered to be individual objects and worked with it. So that is what object-oriented basically means. And it's a high-level programming language where, we don't use very complex syntax to work with. It is easily understandable and provides, very high readability as well. So by high readability, what do we mean? Well, high readability makes sure that even a non-programmer or a beginner can basically understand a lot of code when looking through a Python code. Well, it's as simple as that. And Python is primarily used for web development, application development, and much more. We know how much you guys are excited for web development. We know how much you guys are excited for understanding data science, understanding artificial intelligence, deep learning, machine learning, everything. And you guys might already know that Python is used for all of these applications, right? And that there's a reason for that. Basically, Python is known to be the world's #1 programming language. In fact, Java actually had this bragging right of being called the world's #1 programming language, and then Python came in, and pretty much from then on it has remained on the top spot since then. So the next question you might have is Python a new language? Is it an old language? Because if we do have very experienced developers among us who've been working with Java all their life, C++, C# or anything, you might wonder, is Python a new language? Well, not exactly, because Python has been in existence since the 1980s. It's pretty much close to 40 years now. Python is almost a 40-year-old language, ladies and gentlemen. And the most important thing you need to understand is that it gained a lot of momentum. It gained huge popularity in the beginning of the 21st century, and basically since then, as I just mentioned in the previous slide, it has been rising and rising. And here's the person who created Python. His name is Guido van Rossum, and he's an amazing developer. You can check out more about him after the session, of course. And then coming to some quick Python facts that you might know or not know. Well, guys, do let me know if you know any of these. Let's consider Firefox. Firefox has over 230,000 lines of code, which basically calls to the working of Firefox, and it's all written in Python. How amazing is that? 230,000 lines of code of Python for Firefox, ladies and gentlemen. And then coming to Microsoft, of course, they have their own IDE. They call it as the Visual Studio Code, and this is basically used to promote worldwide Python development as well. And you can get pretty much free versions of this, and Python is open source if you've been wondering. So Python has been used by the community developed by the community and implemented very well by the community as well. And then coming to Netflix, did you know that Netflix actually makes a lot of use of Python, especially in the field of data science? Well, everything from automatic image recognition, it might be a recommendation for all the TV shows and the movies we can watch on Netflix, and much more. But do understand that Netflix uses a lot of Python. And then coming to Uber, I'm pretty sure everyone knows about it, and they actually make use of Jupyter notebooks and they make use of IPython to basically share and store all of the data with respect to the driver client interaction and all the ratings and all of that, and much more. As you can see on your screen, some beautiful usage of Python right here. Well, on that note, let's come to the topic of why one should learn Python. Well, the first point that I would actually tell you guys of why you should consider learning Python is how simple it is and how beautiful the readability is. So what do I mean? Well, here's a simple Java code which basically prints the statement hello world. You know, we've all been in our first stages of programming where the first piece of code we might have printed very well might be the hello world program, right? So here is how you would do it in Java. Okay, so how do we do it in Python? Well, look at how elegant, how beautiful, and how simple it looks, ladies and gentlemen. And I'm pretty sure if you had to write code and if you had to start out with, if you're a beginner, you would prefer Python for this. You know, there are no semicolons, it is very much readable, and even if you do not know a programming language, you can understand that print hello world pretty much, you know, probably equivalent to putting out an output which gives out hello world. You know, you can at least take a guess and understand. But then as soon as you look at the Java code, you might be taken aback. You might be like, whoa, what's happening, right? And this is one of the most beautiful reasons why I personally prefer Python, and why we have thousands and thousands of developers who actually prefer Python as well. Coming to the next point, I believe it's convenience. Because again, of course, this point applies to multiple programming language out there, but the specialty of Python is that, you know, since it's basically platform independent, you can run it on Windows, you can run it on a Mac OS platform, you know, basically Apple's operating system, and you can use any of your favorite operating systems. You know, in fact, if you want to run Python on a PlayStation, well, you can do that as well, ladies and gentlemen. Yes, on your PlayStation, Windows, Mac OS, PlayStation, and many other operating systems for that note as well. So this, you know, makes it very convenient for the developers, for the people who prefer Windows, and of course for the population who prefer Mac OS to everything else. So understanding this point is very vital at this stage. And next is pretty much cross-language operations. Well, what do I mean by cross-language operations? Coming to cross-language dynamics, you need to understand that Python can talk and work well with all of the languages that already exist. See, for example, there are languages, from C, Java, C++, we have JavaScript, we have languages such as Rust, we have .NET, and we have all of these languages, platforms, firmware, libraries, whatever you want to call it. And basically, Python brings all of this together. And if you are an expert in JavaScript and, you know, you're trying to implement JavaScript using Python, yes, you can do that. Can you run some Java code using Python? Of course. And can you go on to use .NET alongside Python? Of course. Well, as you can see where this trend is heading, well, it is the #1 language of choice for a reason, and I believe this is one of those reasons. So what do you guys think? Head to the comment section and let me know. And of course, coming to artificial intelligence. Well, ladies and gentlemen, I know you guys might be waiting for this at this point of time. Hey, what about data science? What about artificial intelligence? And much more. Well, here it is. You know, you must learn Python today because Python is one of the most preferred language in today's world to help achieve artificial intelligence, you know. So where is artificial intelligence implemented? Well, look around you, look at your smartphone, everything from Siri, Alexa, all the way to Google Maps, Amazon. I can go on naming thousands of applications of artificial intelligence, which has been so subtly integrated into your life. You know, you have to even understand and contemplate to see if something's AI or not anymore. That's how well it's all been implemented. So on that note, you know, there is a 44% enhancement when you put artificial intelligence and help with the current products which are already existing. And AI will of course optimize all of the internal operations in an organization by up to 42%. AI will help make better decisions, and of course AI will help pretty much optimize all of the external operations which take place. And this is a very important point because you can see a 31% increase there. And of course workers will be free enough to make sure that, you know, they spend their time, their efficiency, and much more to actually be creative instead of doing some redundant tasks. Well, now where does Python come in? Well, you need to understand that Python gives you a very efficient way to work with data. And when you're working with artificial intelligence, it is of course in no doubt that you'll be working with a lot of data. To ensure that you can handle all of this data with ease, Python has got us covered. And then let's talk about the library ecosystem of Python. You know, Python has an extensively huge library system, and pretty much we're going to discuss about the libraries as well. But then at this point of time, you need to understand that all these libraries which are pretty much given to the developers, the frameworks or whatever it is, all of this is helping us get closer to making artificial intelligence more intelligent, if you know what I mean. And of course, it gives us beautiful visualization tools. And compared to any other programming language, there are languages like R as well, of course, which are on the boom right now. Python is again another standard when it comes to using visualization tools. And again, this in my opinion forms a very important reason for you guys to jump on this, because as a learner, as a developer, as a person solving a problem in your company, you will require an efficient way to process the data. You will require a large ecosystem. You will require very good visualization tools. And at the end of it, there is something even more important, is community support. Since Python is an open source language, it is the number one programming language. Again, thousands of people pretty much start out with Python and learn Python on a daily basis, help each other solve the problems as well. In fact, we have the Intellipaat community where we actually cover Python as well. We cover all of the IT related concepts in depth in the community section, where we have people from across the world coming in to help each other's problems out. So make sure you check out Intellipaat's community after the session, ladies and gentlemen. And coming to the next point, Python has another strong footing in today's world. As you can see from the title, it is web development. Python provides us with so many nice frameworks to work with. Everything from Django, we have Flasks, we have Pylons, and we have Web2Py. Basically, all of these are tools to ensure that Python as a programming language can help in web development. The introduction I gave you to Python said Python is used for web development and app development. Well, you can see all of the beautiful libraries that Python provides us for web development on your screen right now. Django is amazing to work with. Flask, again, if learned, you can create very beautiful applications using that. Pylons, of course, and at the end of the day, even Web2Py as well. Well, at this point of time, my goal is not to overwhelm you guys telling you all about what Python is and what Python is offering us. Well, I'm trying to tell you the potential of Python, ladies and gentlemen, and I know that it is amazing as well. Coming to big data, of course, the entire world is a big data problem. Look around you. There is terabytes worth of data being generated every single second. We upload a picture to Facebook, we upload a picture to Instagram, we might sing and put something out on SoundCloud or whatever it is. You're putting in a lot of data out there on the internet, and it's just not you, it's the entire world population, a majority of the population who make use of all of these apps. So when you're looking at that, pretty much there is a lot of data being generated. And how does Python help? Well, as I mentioned, Python is amazingly easy to work with. It is all because of the libraries and all the support it gets. See, for example, from Apache Foundation, we have Apache Spark, and we have tools such as Dask and PyDo, which basically help in giving Python the access to basically go on to make use of parallel computing. With parallel computing, you can solve big data problems by breaking down a problem into simple sub pieces, assign it across multiple computers, and have these multiple machines, multiple nodes as we call it, solve the problem for you, and do it in such a way that there is no strain on one single machine doing it, of course. And that's not the only reason. If you're dividing the load among hundreds of computers across a server, 1,000 computers for example, you have that much of power, 1,000 times of power, 100 times of power, whatever it is, to give it to you in the most simple terms, ladies and gentlemen. So handling big data with Python is a breeze, and companies are looking out for all of these, and they want you as a big data expert there. So if you want to become a big data expert, you need to understand all of these concepts, and to understand all of these concepts, you need to first set across a programming language through which you're going to work, and use all of these frameworks that come with it and go on to make use of it, right? So basically that is exactly what I'm trying to tell you guys here. When you hone in on a particular language such as Python, you have all of these beautiful frameworks to work with at the same time. Then coming to data science, of course, I've put in a fire emoji out there to tell you that data science has been on fire all of 21st century. Data science is pretty much booming right now. And in fact, guys, if you do not know, data science is being actively used right now to fight the outbreak of the coronavirus, which is spread across the world. And, we have an entirely in-depth session covering basically on how machine learning and other technologies can actually be used to help fight the coronavirus, or COVID-19 as it's called as well. So make sure you check it out after this session. And of course, coming to why you should learn Python in terms of the data science aspect, well, again, it provides amazing libraries to work with here as well. For numerical computation, we have these two beautiful libraries. It's Pandas and NumPy. Both help in amazing numerical computation. And when you're working with a lot of numbers, when you're working with data frames, data sets, whatever it is, these will ensure that the same level of readability is met, and that of course you can efficiently handle all the data with ease. And then coming to data visualization, ladies and gentlemen, we have Seaborn and Matplotalib. These two are very famous tools which are basically used to perform data visualization when we're talking about data science, when you're talking about Python, and when we're talking about solving most of the data cases of today as well. Well, as I mentioned it before, let me strengthen it again. Python is the #1 programming language out there as of now for data science, and if you are capable of handling numerical computation, and if you can understand and produce very good data visualization methodologies, of course you are preferred by all of the top hiring companies out there. And this brings us to all the skills that is actually needed when you're working with Python, when you have to begin working with Python, or even general aspects of a programming language such as Python. So the first skill that you will require is object relational mapping, or ORM as it's called in short. Basically, ORM is used to create virtual databases where there is a data which cannot be converted into another type, or if you want to perform some analysis on a data which is present amongst huge amounts of data, well, ORM is the tool to go to. When you're working with Python, there is SQL Alchemy and there is Django ORM, which will basically help you achieve this goal. And it's as simple as that. Coming to skill number 2. Skill number 2 is basically all the front-end technologies that you might be working on in case if you're looking at the web development aspect of Python. It is a must-have that you understand certain tools like HTML5. It can be, pretty much JavaScript. It can be CSS3, cascading style sheets, of course. And there are many other things which you might have and need in your arsenal to go on to become a very good web developer if you're working with Python as well. But then do understand that it is not always the tools which come into the picture. You, at the end of the day, if you're working with front-end technologies by making use of Python at the same time, you will be creating a very good user experience the person who's going to be watching your website. And at the end of the day, to keep it very structured, you will have a program manager who will overlook all of these, and it is going to be a very structured process of how you'll be going through the same as well. And of course, you will have a scrum master at the end of the day to bring all of these together to ensure that when you're working with a website or a web application, that everything goes smoothly and as the way that it's initially planned as well. So if you're working with front-end technologies and you want to go on to become a web developer using Python, make sure to keep all of this in mind. And of course, coming to the third skill, it's basically all the Python libraries that you have to know which exist. Everything from requests, beautiful soup, we have Pygame, we have Scrappy. So basically from web scraping all the way till building your own games using Python has it all. But the most important aspect of Python, as we've been talking for a while now, is Python for the use in machine learning, Python for the use in data science, and Python to achieve artificial intelligence at the end of the day. So there are some amazing libraries and frameworks here. There's TensorFlow, Keras, there's Spark, again NumPy, PyTorch, MXNet, Pandas, Scikit-learn, and many other Python libraries which will basically help you to pick up one which you like and what you would work with, and at the end of the day, what problem are you trying to solve. So Python will give you a choice of 250 plus libraries where you can pick up one, become a master in it, and pretty much go on to have a successful career as a Python developer at the end of the day. Because there are experts who are wanted for Keras, there are experts who are wanted for TensorFlow, there are experts who are wanted for as Django developers, Pygame for game developers, and there is much more. So you need to understand that all of these are trending. All these are among the top libraries for any programming language in the world right now, and that is how much Python's libraries have all blown up. So make sure you jump on this and make the best use out of it. The skill number 4 that you need to know, you need to understand, is basically version control systems. So basically Git is among the world's most famous version control system out there, and pretty much this will help you not just as a Python developer but as a programmer in general, because when you're working with Git, there is a lot of structured process which basically happens. It ensures that there is no confusion when multiple people are working on the file, and for example, a file which is already committed and deployed, So basically, when a file has been deployed and committed in a separate branch, well, let's say call it the development branch or call it the branch where the data is actually the data which is live on the website or whatever it is. Well, this data you're not messing up for testing purposes, or you're not working on it actively, which might actually cause real-time changes to your website. So making use of Git will not only help you with Python, it will help you with all the other programming languages, by helping you stage your content, by helping you track your commits, and to ensure that, if there is modifications needed and modifications done, who has done the modifications to what branch at what point of time, and you can even leave comments to the modifications done as well. So this will keep the entire concept of programming and bring it into a world of structure and give it some foundation where, there is no confusions, there is no anomalies, and basically no mix up when there is more than one developer working on something at the same time. So this brings us to skill number 5. Skill number 5 is very important. It's artificial intelligence and machine learning. Why do we keep mentioning so much? Again, as I mentioned, it is the preferred language for AI and ML. It gives you multiple libraries out there. Everything from working with neural networks, working with machine learning, working with deep learning, and as I've mentioned, all the things that follow in these concepts as well. For example, in neural networks, you have convolutional neural networks, you have recurrent neural networks, you have concepts such as autoencoders, you can perform time series analysis. So all these fancy terms and concepts, they might sound fancy and they might sound convoluted at this point of time, but they are the foundation of what makes Python a beautiful language to work with. And basically, they're so easy to learn. All you need is a structured process. All you need is the right hands-on, the right instructors, and pretty much, the right content to help you master a language such as Python. And of course, this brings us to the 6th skill, which is communication. This is the most important skill if you're looking to build a very serious career in Python. Well, why do I say that? Because, ladies and gentlemen, let us be very honest here. If you're working for an organization as a Python developer, there are chances that you will be working in a team and you will not be doing everything solo. If that is the case, you need to work amongst your team, you need to work among multiple other teams. See, for example, if you're a web developer or a data scientist for that matter, you'll be working with the data ingestion team in the morning, you can be performing analysis, writing neural network models in the afternoon, and at the end of the day, you might be creating very good visualization by using multiple tools out there, Matplotalib or whatever it is, and you can be presenting all this information to a non-technical audience. You as a programmer will understand all of these concepts because probably you've been working on it, you're trained on it, you're certified on it, and whatnot. When you're explaining all of this to a person who might not know it, there lies a small challenge. So communication plays a very important key, not just when you're becoming a developer in Python, but then when you're becoming a developer in general, ladies and gentlemen. So on that note, what are some of the key takeaways that you can pretty much notice at this point of time? The first thing that I can tell you is if you are willing to take up Python seriously, or if you want to understand why you should pick up Python, first check if you have the problem solving skills, if you have an interest towards solving problems, because Python at the end of the day can of course be used for recreational programming. It can be used even for competitive programming as well, and most of the time it is basically used when the problem statement comes up and how you can use a programming language to solve that problem. So make sure you ask yourself if you have the intent, if you have the interest to solve problems. And then programming, of course, since Python is a programming language, one of the top in the world, you need to make sure that your game is up when you're working with programming, and when you're working with a language such as Python, this is very important, ladies and gentlemen. The next point is communication. As I mentioned, communication is very important, it is key, and when you have to check out how much there is to learn, pretty much I hope you guys were not overwhelmed with all that was shown on your screen, because again, 250 plus libraries, as I mentioned, is a lot, and you might be wondering, do I need to learn all the libraries? Well, no, you just need to start by being eager, by being curious, by checking out what Python offers, what do you like with respect to the language, what do you like to do, and how can Python help you get to your goal. It is as simple as this. Ask yourself these 4 questions, and pretty much this will help you to the maximum. So on that note, let us quickly check out a demo. I'll be showing you how elegant it is to work with Python by picking up a problem and solving it using machine learning as well. So guys, the point of this demo is to ensure that you guys get to understand how easy it is to work with Python. Of course, we can work on a very complex data set, we can work on a very complex demo basically, and the point is to not overwhelm you. The point here is to ensure that you get a clear understanding with with respect to Python, with respect to its usage, and well, all of us basically like less code to achieve maximum efficiency and to solve the problem, right? So nobody wants to write 10,000 lines of code if it can be done in say 2,000 lines of code, and that exactly is your takeaway after going through the demo session, ladies and gentlemen. So basically, we're going to try to predict to see if a person has diabetes or not, or check the onset of diabetes basically by making use of machine learning with Python. Even before we begin, as I mentioned, Python and machine learning has been amazing. You have multiple libraries here. You have one amazing library to work with machine learning, and that's scikit-learn. Scikit-learn is pretty much used 99% of the time when you're working with machine learning, or you have a requirement where there's a problem and you have to solve it. So let's go on to understand and check how we can basically make use of machine learning to solve the problem for us. So basically, let us go on to check what is the accuracy of detecting the presence of diabetes. Diabetes is again a rising concern in my opinion. Be it a country like India, be it a country like USA, or let's say anywhere across the world, diabetes is a very deadly disease, right? Pretty much it is the condition where your body cannot maintain the blood sugar, and this will cause a lot of havoc if you're not diagnosed and if you're not prepared for it, or if you've been ignoring it for a while. So at the end of the day, it is basically your job to ensure to see how you can bring the world of computing and medicine together. See, medicine is a field where it's thriving on its own, and pretty much, it can do really, really well with or without the help of computing. Let's be honest. That is how it was for the last 100 years or so. The field of medicine has been grown exponentially. Coming to today's world, medicine alongside data science, medicine alongside the power of computing, it has stepped up the game of medicines to another level. And I'm sure over 70% of the doctors are going to agree to this, because again, to give you another case, in 2019, pretty much data science helped the doctors figure out the onset of early breast cancer in all the patients, and it sort of gave away a probability of 55 or 56% of detection. Ladies and gentlemen, we're talking about cancer where 1 or 2% can be can add a lot of things to your life, and it can take away your life as well. When you're thinking of numbers at that scale, you need to understand a 55% of probability to a patient saying that, hey, you have malignant cells in your system which might hurt you, or you have benign cells, they are not cancerous, they'll not hurt you, and all of this, giving this hope to a patient and then proving it with respect to validation. That, in my opinion, is very, very important usage of computers with the field of medicine, ladies and gentlemen. So without further ado, let's quickly jump in to understand how we can go on to predict diabetes with the help of machine learning. And the step one of any programming language, the step one of any problem statement is to understand the problem statement. And as the problem statement that I have mentioned, we need to go on to see how we can make the computer understand that, right? That's the point. Well, let's begin. Well, step one is to basically, import all of the libraries that you'll actually be using. So it is a common programming practice to all the beginners who might be watching this session that you import all the packages that you think you will require at the starting part of it, so you don't have to keep doing it at every point of time. So the step one is pretty much very important, where we're importing all the packages such as pandas and NumPy for data handling and numerical computation. As I mentioned at the start of the session, we'll be using Seaborn and Matplotalib as well to show you some very good visualizations. Scikit-learn, which is a very important part of machine learning, as it poses to be one of the top libraries, as I mentioned. And of course, there is one single line, since we're using Google Colab out here. Google Colab is basically a Python Jupyter notebook, basically hosted on the cloud. So we have another thing, we're importing basically files which will help us upload files and help Google Colab talk to our dataset as well. So after importing all of the Python libraries, we need to go on to actually load the dataset. So loading the dataset is basically the operation of inputting our files which we'll be using. In our case, we're going to be using a diabetes prediction dataset. So let me quickly go on to import it. So basically using files.upload, it'll give us a very, very easy way to go on to upload these files. And as you can see, the file has been uploaded, and our dataset is there. So your question will be, what does the dataset look like? Well, can you talk to us a little bit about the dataset? Well, of course, ladies and gentlemen, you have multiple aspects of this dataset. And as I mentioned at the start of this project, basically this dataset is a very simple dataset. It does not require a lot of cleaning. Data cleaning forms a very important aspect of working with machine learning, working with Python, and this dataset is pretty much a simple one. So quickly going through all of the features that we have the pregnancies column, which basically describes if a person has had a pregnancy and if the person has been pregnant before, and the number basically indicates how many times the person actually became pregnant. And glucose will basically give you the glucose level on what was tested at that point of time. time. Blood pressure, again, as we call it as BP, is basically the diastolic blood pressure, which was measured at that point of time. And again, we have the skin thickness, which is very important to understand the levels of fat. Again, the levels of insulin is basically generated by the human body, and it helps regulate sugar levels, and it can be picked up from a serum test as well. Coming to BMI is basically body mass index, and an average of 25 BMI is considered to be a healthy person. Anything less than that, you might be undernourished, and anything above that, you might be considered obese as well. And then we have the diabetes pedigree function, which will basically tell you if there was an onset of diabetes in your family, because diabetes is something which is hereditary, as you might have read on the internet by now. So this basically will give us an understanding to see if it ran in your history, to see if it ran in the family history before. And then coming to age of course gives the age of the person, and the outcome. The outcome is to basically check if the person is basically predicted to either have diabetes or not. 1 indicates the person is predicted to have diabetes, and 0 is the outcome where we detect that the person has not had diabetes in their life before. And then of course, coming to description of the data set, let us actually go on to use some concepts of descriptive statistics here. So descriptive statistics is very simple. We're going to be analyzing data using statistics. Everything from the count of occurrence of that, what is the mean of all the values in the columns, what is the standard deviation, what is the minimum value of occurrence, what is the maximum value of occurrence, and of course you can go on to check the 25%, 50% and the 75%. It's called as the IQR, interquartile ranges of all the data as well. See, some data might not make sense. Let me point out something really quick. Insulin will never be 0 in the body. BMI can never be 0 in the body, and you can see that there are minimum values here. And as I mentioned, you can go on to perform complex analysis to remove all of these values to pretty much ensure that they won't hurt your data later. Well, why do I say this? Because data cleaning is probably the most vital step for a data scientist out there, and data cleaning is very, very important when it comes to basically telling your model to give out accurate results, and basically it'll help your model learn better as well. And this of course brings us to step number 3. Step number 3 is where you'll be splitting your dataset into 2. We call it the testing dataset and we call it the training dataset. Why do we do this? Well, we need to train the model based on some data and later verify it to see if it has learned something or how accurate that it has learned, right? So basically here we make sure that we split the data into a training data set, we basically split the data into a testing data set, and we can go on to perform analysis further. And the most important thing is that you need to go on to distribute it, and not just basically pick up the data. Hey, first 10 columns and the first 10 rows of these columns, let's split it into the training, remaining let's go to the testing data set. Well, no, we can actually go on to randomize all of this and distribute it with respect to the testing data set and the training data set. Well, this is basically done to ensure we can add some sort of randomness to our testing and our training data sets at the end of the day. And ladies and gentlemen, welcome to step number 4. Step number 4 is where all the magic is happening. Here is where machine learning is coming into the picture. So basically we're using something called as GSCV for performing evaluation to see if a model can learn something and understand something. What is GSCV, you might be asking? GSCV is basically one of the amazing techniques. It's called as grid search cross validation, and this technique is used to understand what parameter can be used best, and how you can go on to evaluate what parameter will give you the best results at the end of the day. So you might be wondering, can I use just body mass index to check if a person is diabetic? Can I just check out using blood pressure to see if this person has diabetes or not? Well, with respect to grid search cross validation, your data, since it's being split into the test case and the training case, you can basically go on to tell your model to effectively use this validation case, which is basically the test case, against your training case to make sure that your model has learned well. You can go on to use multiple other things as well. There's something called as k-fold validation as well. With respect to k-fold, your testing data set is broken down into small chunks, and basically it is n folds times which is run across the training data set. What I mean by that, k is the number of times you want to run your testing data sets across the training data set. Well, again, not getting into all the details to basically overwhelm you again. To keep it simple here, we'll be using cross validation, and by making use of the gradient boosting classifier, we can ensure to find and evaluate what are the best parameters and how we can go on to use them to accurately detect the onset of diabetes. So let me quickly run this, and ladies and gentlemen, as you might know, this is the process where the machine is actually learning, and it's performing analysis by going through all of the data. And this is very important to know that this might take a small amount of time. I am thinking in my case this might take about 2 or 3 minutes, so we'll be back as soon as we get the results. So as you can see, that took about 3 to 5 minutes, I would say, and pretty much you can see by making use of grid search, we can get to a number where we can understand the accuracy of learning. But then we can go on to improve all of these. There are concepts such as hyperparameter tuning and everything, which I will not explain in detail. Again, we have in-depth videos just to understand hyperparameter tuning. We have in-depth blogs as well. So pretty much, you can go on to learn. And if most of you are beginners, or if you're looking as enthusiasts or learners of an intermediate level, you might not go on to understand it completely as well. So at the end of the day, we have a prediction here, and the first step you need to do when you have a prediction is basically store the prediction. We can put it in a variable and store it, and after pretty much storing the prediction, what you have to do is you need to see it. Just seeing it as numbers will not make sense. So let's go on to use graphs, and let's pretty much plot the frequencies against the predicted probabilities, and pretty much as you can see on the screen, the predicted probabilities versus the direct frequency of occurrence, and pretty much can help you with the presence of diabetes or not easily as well. And hey guys, there's a quick fact pretty much that says that the human brain can comprehend images 3000 times faster than numbers, and pretty much I do believe in that concept as well, because when I see graphs, basically I understand it better. And coming to step number 6 is basically now using different variety of classifiers to understand what gives you the best result, what gives you the most accurate results as well. So by making use of gradient boosting classifier, we've got an 85.2% accuracy. What about the concepts such as a random forest classifier? Again, these are different methodologies which again come from scikit-learn, and pretty much which will help you understand it. Well, as you can see on your screen, with respect to random forest classification, we have a 78% of accuracy in detection. What about XGBoost? With respect to XGBoost, we have almost 80%, 79.6% of accuracy in detection. This might put up a thought in your mind saying, hey, why are we looking at multiple classifiers? Why can't we use the best one to be done with it? Well, ladies and gentlemen, with respect to machine learning, that is not the case. One classifier might not be the best for all the use cases out there. So what we try to do is we put in the other classifiers out there. We make use of 5 or 6, in fact more than that, 7 or 8, to basically understand what will give out the best results and what will basically help the machine understand the concept better and give out more accurate results. Because at the end of the day, we're looking out for the most accurate results we can get our hands on, and that is one of the reasons why we go on to use multiple classifiers as well. So you might be wondering, what can we do any further with this project? Can it be built better? Well, of course, you can perform a lot of data cleaning for that matter, and pretty much you can go on to use many other classifiers as well. You can use k-nearest neighbors algorithm, which is basically KNN. You can use concepts of perceptron. You can make use of the concepts of decision trees and many other methodologies to check their performances, see what gives you the better performance. And in my opinion, gradient boosting, random forest, and XGBoost pretty much gave us high numbers of accuracy for this particular case, and I thought it was fitting enough to show you guys this. Well, as you can see, it is pretty much very easy to go on to work with machine learning with respect to Python. On that note, let us come to the question. So you pretty much decided Python is your career goal, and so on that note, pretty much you have come to the point where you need to become a Python developer, and you need to understand what is the demand. It's all about demand and supply in any business, and it is the same with respect to Python developers as well. Well, here I want you guys to be overwhelmed, because look at the people hiring on your screen right now. I've filled the screen through and through with all the people who are hiring for Python developers, data scientists, web development using Python, whatever it is. These guys want people who know Python. Everyone from the major social media sites, Instagram, Facebook, Evernote, Android, LinkedIn, people. And of course, we have the giants like Unisys and analytics companies like Mu Sigma, and we have IBM, we have Fractal Analytics, we have Ernst & Young, we have Edgewove. Edgewove is basically an Infosys company. We have Ola, which is again the competitor of Uber in India, and we have Oracle, we have Siemens, and many others who need Python developers for all of their problems. And of course, there is more. Fortune 500 companies, there's Skype, there's BBC, there's Adobe, Best Buy, Walmart Labs, Apple, Google, you name it. As I've mentioned, everyone, I would like to say 90% of the companies in today's world will require a programming developer at one point or the other. And in those 90%, well, let's say 60% of them need Python developers compulsorily. Well, that is an incredible number. That is thousands of openings pretty much every single day as well. And on that note, you might be curious of saying, hey, what do Python developers earn if there is this huge of a demand? Well, let me tell you the average salary of a Python developer. It's somewhere around 123,000 American dollars. Of course, in the USA, it's about 15 lakhs per annum in India, and it's around 71,000 pounds in the United Kingdom as well. So, ladies and gentlemen, this job not only gives you the bragging right of being a programmer in the top programming language of the world, and but it is very lucrative at the same time. You can look at the numbers on your screen. These numbers are very much achievable. You just have to prove to the people that you're going to be hired with that you're capable of doing it. You have the right training, you have the right hands-on experience, and at the end of the day, that should be more than enough to guarantee you an employment with one of these top companies that I just showed you.
First, let's take a look at an overview of the career options. So since Python is quite a versatile language, you can have a few career options in Python. So if you know Python, then there are many fields that you can go into. Some of these are the ones that we're discussing here. It's not that these are the only fields that you can go into. There are many other fields as well, but these are the fields that are the most prominent ones. First is the automation engineer field. Second is web development. Third is ethical hacking. Fourth is game development. And then there's data scientist. Data scientist, machine learning engineer, they're both closely related. So we've shoved them all into one single field. All right, let's take a look at automation testing. So we'll first have an introduction. So what is automation testing engineer? So automation testing is done when a person writes Python scripts that can be used to check whether or not computer software is behaving the way it's expected to. For instance, if you have a computer software and you wish to check whether or not it's working correctly, or whether or not things that have been used to make to build it are using correctly, the components are working correctly, such as the database interaction, the network layer interaction, so on and so forth, you can write Python scripts that can automate this process. Although there are people out there who do it manually, automation is really taken off, and nowadays people prefer having an automated test orientation. Now let's take a look at some of the tools. These are just some of the things that you might need to know in order to become an automation tester. The first thing is Selenium. Although automation testing requires a lot of tools and there are a lot of tools out there, Selenium is by far one of the most popular ones. It's an automation testing tool that allows you to automate a browser, most notably Chrome, and using that you can just instruct it to find elements, click elements, fill in some text fields, so on and so forth. And the browser will follow all the instructions that you have written and will follow an entire use case scenario. In case something fails, it will notify you immediately. So instead of you having to do it all manually, the browser will take a look at all of that and then will notify you whether or not a server is not working or it's getting an incorrect response. This is all done through the user experience though. So this browser will act as a user. It will be automated by Python scripts. So how a user will interact with the product is how the product is going to be automated using Python, and then the browser will make the interactions happen, and if something goes wrong, then we will be notified. But what about from the development perspective? This is where testing comes into play. So you can take a look at PyTest. PyTest is one of the most popular frameworks for testing in Python. It allows you to write tests, it allows you to create mocks, it allows you to create stubs. It allows you to basically take a look at the code and then test the code itself instead of taking a look at the output or the end product and then using the Python code to automate that end product's interaction. So here you'll take a look at the code. This is more like white box testing. So here you'll take a look at the code, you will write test for the code to check whether or not it's working correctly or not, and then later on those tests could be part of the test suite, which then will help us understand how you can go about doing this. Then there's PyUnit. It's another testing tool, but it's focused mainly on testing the code and testing individual components or individual units of code. Other parts of the code could be isolated, so your application doesn't need to know much about it, and you just need to know PyUnit or the unit testing tools that you have available. PyUnit is quite popular in both the development and testing communities. So Selenium, PyTest, and PyUnit are three of the things that you might need to know in order to become an automation tester. Now we'll take a look at web developer and we'll understand what is involved in creating web applications. Now, in case you are wondering how you can get the skills that I'm describing, how you can learn to use these tools in order to further your career in Python, do stick with us to the end and we'll guide you through some of the resources that you can use in order to get better at these tools and easily pick up these skills so that you can get it done. Right? All right. So a web developer that uses Python can build the backend of a web application. Python is used to build the backend. Now the backend can either serve the entire web application, so it could be all the markup is templatized, and then you can get data from the database and then hydrate the markup and then send it to the user. So this is how PHP would work. So you can use that way, or you can create a web API. Basically, what web APIs allow you to do is allow you to systematically and programmatically expose some data that you have in your database. So in case you wish to expose all the lists of users available in your database, just their username and the date of birth, you can do that, and then the front end of the application will take a look at the data that is sent back and then build the entire web page on the client side. So either way is useful, and Python supports both the ways, so it's quite versatile as we have already discussed, and you can do it that way.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Now let's take a look at some of the tools that you might need in order to become a web developer, the kinds of technologies that you need to know. So web development involves the use of many tools and technologies. Some of these are, the first one is Django. Django is by far the most popular one. It's currently in its third version. It's really a really good framework, very easy to get started with. It's got batteries included, so anything that you might need to do in order to create a web application, such as database interaction, authentication, authorization, serialization, deserialization, response parsing. There are so many things that are needed, and Django makes it all easy for you. It allows you to break up your entire web application or the backend of your web application into smaller applications, which can then be used to create separate functionalities or separate features. So in order to create an authentication system, you can create separate applications for authentication, and that way you can just plug and play your applications, which is quite easy to use. Then there's Flask. In order to get a higher level of access and control on the code that you write, you can use Flask. Flask is a micro framework. It only takes care of a few subsets of the thing, and the rest of the things are left on you for you to figure out. Flask works well with other tools as well. In case you wish to introduce your own database access technologies, such as an object or object relational mapper, or you just want to do it the traditional way by getting the data from the database and converting each row into a domain object, you can do that with Flask as well. And then comes Web2Py. Web2Py isn't that popular, but it's quite useful in some scenarios, especially if you have a really small application or you want to build applications for quick prototyping purposes. Web2Py is a very easy to learn tool. Web2Py is also quite good for you to use on your personal projects and so on, and they can help you out with a lot of things as well. So Django, Flask, and Web2Py are three of the most popular tools that are written in Python and are used in web development. Let's take a look at ethical hacking. So what is ethical hacking? An ethical hacker tries to break into a system in order to find out security loopholes that need to be fixed. It is to be understood that ethical hackers are employed by the company in whose system the hacker tries to break into. So you get onboarded into a company on a contract basis. They ask you to have 3 months full access to the systems that they want to check whether or not are hackable or not. You can then take a look at their networking schemes. You can take a look as pretending as a malicious user. You then need to figure out ways through which you can break into their system. If you find a way, it's your duty to report back to the people who have employed you, and those people can then fix those things, and you could even help them out into fixing these problems. So that would be really useful, and that's why ethical hacking is all about. That's what ethical hacking is all about. Let's take a look at some of the tools. Now, the tools for ethical hacking are not just based in Python, but Python is quite popular in this field because it's very easy to learn, and ethical hacking is mostly about networking. But if you know programming, then that could be really helpful. The first one is Scapy. Now, Scapy is a tool that allows people to sniff network packages. So packages that are coming in or out of a router or coming in and out of a network, Scapy can be used to take a look at those packages. And if it's interacting with an unsafe network, such as you are on a you are in a cafe and a person is logged onto the same router in the cafe as you, and they are interacting with a non-HTTPS website, which means it's not secure, and anything that is being sent over the network could be easily intercepted and then taken into account. So a person who can take a look at the username and password that you're sending over the network could easily hack into your system. So that's what Scapy does. Then there's FlowGrep. What FlowGrep does is that it takes a look at the request and response coming in and out of a network, and it matches the response body with a particular pattern that you're sending it. So if you want to get all the requests that have username or password in the request body, then you can take a look at that. Or if you want all the network requests that are going to a specific domain, then you can take a look at that as well. FlowGrep allows you to narrow down the request that you're taking a look at. Then there's subroot. It allows you to take a look at all the subdomains available for a particular domain. So if you are working on an example.com and you want to take a look at all the domains that you can explore, instead of finding out yourself, you can use subroot and it'll tell you whether or not mail.example.com or sample.example.com or database.example.com, lms.example.com are these domain names available for a normal user, and if they are, then how can we use them? That's where ethical hacking tools come into play. These are some of the subset of the tools. The tools are really large in number, and there are a lot of tools available. And again, we'll take a look at different methodologies, and we'll help you navigate these tools in order to understand how you can learn them. So stick with us till the end. But till then, let's just take a look at what else we have. Game development using Python. So game development is quite a vast field. Many people get into programming to learning how to build games of their own. Now, game developer uses Python to build games which can be played on a variety of platforms such as computers, mobile, and so on and so forth. There are many ways that you can build games on using Python, and we'll take a look at some of them now. So let's take a look at the tools. The first one is Pygame. Pygame is one of the most easy to use Python gaming frameworks. It allows you to build games using some of the most common technologies that you come to use, such as sprite sheets and collision detection, and it does all of these things for you. Many of the gaming engines that we will discuss will take care of the physics for you. So in case you throw something in the air in a 3D game, how does it then get back onto the surface that we have created, and what the interaction will be like? All of that is taken care of many of the game engines. Pygame does have extensions that allow you to do that, so you can take a look at those as well. And it makes it really easy for us to understand how to use these gaming tools. And these gaming tools are quite easy to use by themselves as well. Then comes PyOpenGL. So OpenGL is a graphics library that has been created and is being used by a lot of people to create a lot of different things. The PyOpenGL is the Python extension, and it allows you to write Python code in order to create OpenGL scene graphs, objects, and monitor their interaction with each other. OpenGL allows us to efficiently render complicated objects on the scene graph or on the screen that we have available. And in those screens, many games use OpenGL extensively. So in order to create stellar visuals and great graphics, you need to understand how to use OpenGL. And for Python users, you can use PyOpenGL for that. PyOpenGL also allows you to write your own OpenGL scene graphs and interpret some of the OpenGL objects that have been created by other people. So it's quite easy for us to use as well. So do understand how to use that and try and use that as well. Then comes Kiwi. So in case Pygame didn't work out for you, you found it to be too complicated or confusing, then Kiwi is an alternative to that. Kiwi also does many of the same things that Pycharm does, but it's very easy to understand. It's very easy to use. It also allows you to create applications or create games that can be used in either of the mobile applications or the desktop applications or many other places. So you can take a look at Kiwi as well if Pygame seems to be a little too daunting for you. But I would recommend that you check out all of these tools, get a feel for which one serves your needs the best, and then use that. And now let's take a look at data scientists. So data science, and a data scientist takes a lot of data and gets useful and useful insights out of the data, or what they do is they take the data and train a model which can make predictions by learning from the data. So data science has elements of machine learning as well. Data science is part of machine learning and a part of broader range of artificial intelligence, which takes a look at the data and figures out what we can extract out of it in order to get better predictions. Take a look at some of the tools that are available for us as data scientists. We have data scientists. As data scientists, we have many tools available. These are a few subsets of them. The first one is Pandas. Pandas is a tool that if you have worked with data science for any number of time, it's a tool that allows you to take a look at structured data. So if you have data saved in a CSV file, in an Excel file, in an Excel worksheet, if you have data stored in a database file, you can get it into your Python program using Python or using Pandas, and then you can visualize the data. You can perform data wrangling tasks. You can group the data, sort the data, drop some of the columns, get some of the data, clean the data. There's a lot you can do with this. Especially the cleaning part and the cleaning the data, dropping columns, all of this is done ridiculously fast in Pandas. It is very performance optimized, so it's very useful in that regard as well. Then comes NumPy. NumPy is by far one of the most popular languages out there. So NumPy is NumPy is one of the most popular libraries out there. NumPy is used for numerical manipulation. So if you are someone who's getting into the crux of data science and you're trying to come up with algorithms and you're creating a lot of simple equations, but you want them to run as fast as possible, in Python using NumPy is quite a good thing. Because in Python, the normal data types that we use store a lot of unnecessary information that are not that useful for generic computation. NumPy strips them out and allows you to perform these computations quite easily. It has a lot of convenience functions as well that allows you to just lean over the initial complexities and then figure out how to apply these functions on the data that you have. It has it has functions to calculate the sine and cosine values and do matrix multiplications, transformations, Fourier transforms, so on and so forth. So any data complicated task, a numerically complicated task, NumPy can perform really easily. Then there's scikit-learn. Scikit-learn is by far one of the most easy to learn libraries, and what it does is that it takes care of the initial hurdles of learning how to create a machine learning model or a data science model by learning the algorithms. So instead of having you implement all the algorithms, scikit-learn takes care of that. It contains a lot of generic algorithms that have been developed by people who are working as data scientists for a long time. So what they do is that they take the data, they convert it, and then they send it back to the users. So in case you wish to become a data scientist and you want to take a look at scikit-learn, you can take a look at that as well. In scikit-learn, you take a lot of packages that scikit-learn provides, and in those there are packages for accuracy testing, training testing, and splitting the data, cleaning the data, or if you want to build a model, you can just import a generic class that can take in the data, take in the data, train the model, and then allows you to make the predictions. And those could be saved to be used or exposed later on as well. So these are the three libraries that are incredibly useful in data science with Python. There are others available as well, but these are the ones that are the most useful ones.
Let us quickly walk you through the procedure of how you can install Python on Windows, guys. It's a very simple and a straightforward process. Now, I've broken it down to a couple of steps and let's go with it together, right? So step 1 is go to python.org and head to the downloads page, and let's do that side by side, guys. So let me head to the Python website. So it's python.org for the people who are wondering. I'll just go to download here. You can directly click on the link there as well. Since we're looking for Windows, Python pretty much detects that it's for Windows, so we already are at the page where we hit the download. So this pretty much forms our second step as well. So let me quickly save it in the desktop. It's about 25 MB if I think. Yeah, it's about 25.2 megabytes. This will take a couple of seconds to download, and in the meantime, let's quickly check out what are the next steps in our PowerPoint slide, guys. So step 2 is again click on the download, which we just did. And guys, as of this video being made, Python 3.8.0 is the latest stable version out there. So that brings us to step 3, guys. Step 3 will pretty much be opening the installer, and we should be presented with this screen. So let's quickly wait for the download to complete, and then we're going to open up the installation box. Hey guys, that took about a minute to install, and we're presented with this screen, which is the installation screen. Just before you hit install now, you can pretty much choose to customize the installation and install it at a place of your desire. Make sure you just click this button which says add Python 3.8 to path. Well, what it basically does is it sets your environment variables and it sets the path variable to Python. So as soon as you hit Python in your command line, you can just start using Python directly, guys. So that's what it does, and it would be recommended that you do this. Even if you would not do this, there would be no problem. There are other ways to launch Python and to use it. But if you are a beginner, if you just want to hit Python and then start out with coding, you can pretty much hit Python to path, guys. And you just hit install now, and this will ask me for my admin password because we have to install it as an administrator. So let me quickly type in my administrator password and we can work with it, guys. And I just entered my password. So pretty much it should take about I say around 2 or 3 minutes to get the entire setup process done. So in the meantime, let's check out what's step 4. Again, step 4 is check the last option to add it to the path and install, and step 5 is the important step, guys. So we need to verify that our installation has been successful. So for that to occur, we need to make sure our setup completes. So let's just wait a minute and then we can go ahead with the setup, guys. So guys, now the setup is successful. Let me quickly open up command prompt to verify that it has been installed correctly, guys. So if I go ahead and type in Python there, then pretty much Python console is ready for us. So let's type in a sample code, hello world. And as soon as I go ahead and run this, we have the output, guys. So pretty much, well, as of this moment, Python 3.8.0 is the official stable release of Python, and that's what we've been using, guys. So we can check out another code snippet as well, guys. So let me do a equal to 1, b equal to 2, c equal to 3, and so much more, right? So let us create a new variable d and then probably add a and b to it. So let me just quickly do this. We can print d. Well, d is 3. Let's multiply, let's create another variable, call it e, multiply d and c. Let us print e. Guys, I'm just doing this to just show you that everything is working fine. So 3 multiplied with 3 is 3, and so much more. To just get out of the console, you will have to type quit followed by parentheses, and you're out of there, guys. So this is as simple as installing Python on your Windows, guys. And we just verified it using a simple piece of code as well, guys. But Python has another thing called as idle, guys. So idle is this pretty much interactive Python console that you can go about using. And the shell is actually ready. So we can go about typing again, hello learners, and done. So the Python 3.8.0 works perfectly on the idle shell as well. So this is another way to just verify the installation, guys. So coming back to the presentation, step 7 is again an optional step, but you will get there very soon in case even if you're a beginner or an advanced learner, guys. So install the libraries that you pretty much want. There are many libraries that Python supports, and the most popular ones are TensorFlow, NumPy, SciPy, Scikit-learn, Pandas, Matplotalib, Keras, PyTorch, LightGBM, and so much more. Well, these are machine learning, deep learning oriented libraries that are present on your screen. But then the next step of installing Python is to pretty much install all of the packages and libraries that you want to go work with further on, guys.
Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly. And click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me, and once you're done with this, press enter, and as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the parentheses there? We'll discuss all of that in a future video, but note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console, but here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, the data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. Press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter, and if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now the main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it b plus c. So what do you think will happen in this scenario? If you want to take a guess, pause the video for a moment, think what's going to happen and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took b and added the next string to it. I could even make it a little bigger. B. Let me just do it this way. BSDA and CSS, and as you can see that it added it to the it added those two strings together. Now, if this was not string, and if I were to use a number, again, what do you think will happen? We get an error. So this is where we use it, because adding a string and a number, let's say that you were giving an exam and they say add a plus 15, that would make no sense, and the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. if I have a string called ABCD, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes or 4 bytes depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that, but let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable. So I'm assigning 25 to age. If I were to type name, comma, age n equals 25, this is going to show me an error because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there, so you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start it with anything other than underscore, let's say $name, or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name $, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far. And we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is A equals to B equals to C equals to 10. That means set all the variables on the left hand side, which is A, B and C to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go A equals B equals C equals 15, and if I were to print A, it's 15, B is 15, C is 15. Now if I were to change it, I want to assign 10, 15 and 20 to all of them. Instead of doing the equal sign, what I do is I use commas and I tell it, okay, A comma B comma C. Now I want 10 assigned to A, comma 15 assigned to B and 20 assigned to C. I press enter. A, B, C. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use A, B and C, if I were to use B, C and A, then B will be assigned 10, C will be assigned 15 and A will be assigned 20. So make sure that the order matches with the values that you're providing it. Now let's take a look at Python tokens. Alright, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python, there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic, then there's assignment operator, there's comparison operator, logical operator, bitwise operator, identity operators, and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. things like addition, subtraction, multiplication, division, modulus, and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1, because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators, and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable. So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add it will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. The x is equals to 10 statement was executed, and x contained the value 10. After I run this code, what will happen is will take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form and the user enters the registration name, the registration number, then they enter their password, and just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assigned the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use AND. It will return true if both the statements are true. Similarly, there's an OR statement. OR statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16, so what I can do is I can just check s is equal to 15, it returns true, y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter. and it returns false because one of those conditions is false. So that is the problem, because y is equal to 16. Now if I hit this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to, let's say, 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use, instead of AND, I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is, if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand, so let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented, or any value is represented using binary. So binary is basically just some combination of zeros and 1. So when you hear something like integers can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions. To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits, number formed by 4 binary digits. So I will have, this will be 0 since all the 4 numbers are 0. Now what we're doing is, I want to check, if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4 and also so there. So 4, 8, 4, 2, 1. So what happens is, if each position, let's say, so these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If, let's say, this was 1 and this was 1. If this was the binary number that we had, which was 0, 1, 0, 1. So the way we do this is, we take a look at it and we go 2 raised to the power of 4, and you multiply it by the binary digit that's there, which is 0. And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3, and the number at the 3rd digit position is 1. Then 2 raised to the power of 2, and the number should be 0, and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and 1st position. So all we have to do is just go 1, 3, 2, 1 and 0. That will work. So this should be 3, this should be 2, should be 1, this should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1, so we multiply it here by 1. Then at the 1st position is 0, 2nd position it's 1, and the 3rd position is 0. So what ends up happening is, we end up creating the sequence in which we go 2 to the power of 3 is 8 multiplied by 0, plus 2 to the power of 2, which is 4 multiplied by 1 is 1. Then we go 2 to the power of 1, which is 2 multiplied by 0, and we go 2 to the power of 0, which is 1 multiplied by 1. and this ends up giving us 0 plus 4 plus 0 plus 1, and we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you look at what it means. Now, because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can represent numbers in binary format ranging from 0 to 16. Anything above that, we have run out of space, we can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configuration like 1, 0, 0, 0 could also represent some number between 0 and 16. Now we come to bitwise operators.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So what they do is they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, 0 and 1 will return 0. 1 and 0 will return 0. And 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have 2 operands because it's a binary operator. And we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be 0. These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is, it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I have given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1, we have come to 4. Right? So that's how this works. So this is what the operator, left shift operator, does. It takes the binary format and shifts it by 2. Now, on the other hand, we also have right shift operators, and it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0001 because it will shift these two to the left. There are nothing there, so it's removed, and add two zeros at the beginning, and we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right, and at the very end, let me show you what the not operator does, because this is very something that's not shown very accurately. Not operators turn the number from turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0001, and if I were to use the not operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python and I were to use the ID method and I were to pass it a number 1, you see this long number, this is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this, and this is this. So as you can see, both of them have 11, and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 1818752 and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check 1 is 1, since both of them have the same ID, it will return true. But if I were to check 1 is 1, it will return false. So this is what happens with this. If I were to check 1 is not string 1, then it's true. So that's how it works, and this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4 and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, and now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have. And with that, we have come to the end of operator section, and we'll move on to data types in Python. So a Python token. In Python, every logical line of code is broken down into components. These components are called tokens. So there are many types of tokens. The normal types of tokens that we discussed are keywords, identifiers, literals, and operators. So everything that you write in Python is a token of one kind or the other. Let's take a look at them one by one. So keywords, what are keywords? Well, in Python, keywords are special reserved words. They hold special meaning. So these words are something that you cannot use to define a variable. So they convey a special meaning to the compiler or the interpreter. When the compiler or the interpreter takes a look at this word, they'll understand that it has to perform certain action. It has to allocate memory, it has to create something on the call stack, it has to do something in the background instead of just treating it as a normal variable. Now, each keyword has a special meaning and a specific operation. So we'll take a look at them one by one. We'll come across many keywords. We'll take a look at them, what they mean one by one. We should never use keyword as a variable, because that's going to cause a lot of problems when we run into later code, and we'll understand what that means in a moment as well. So these are some of the keywords that Python uses. So as, and, continue, break, except, del, len, from, import, pass, lambda. There are many others, and these all hold special meaning. And as you get deeper and deeper understanding of what Python has to offer and how you can use Python to create your own applications, you'll understand where these keywords are used. The main point that you should understand is you should never use them as a variable name. So again, let me show you an example. Let's say I open the Python console. Now, if I want to type RET is equals to 7, this works just fine. But if I were to type return RETURN, that's a special keyword, and we'll take a look at what that means in a moment. But if I were to assign it to 7, I will get an invalid syntax error, mainly because return is already a keyword. If I were to type return 1, again that would work just fine. But if you try to use some keyword for this is going to cause a problem. Now that is done, let's take a look at something else. So these are the keywords, but there are other tokens as well called identifiers. So an identifier is mainly a name that is given to something in Python that we can give that allows us to identify it later on. So these could be names given to a variable, names given to a function, a class, or an object. In case you're not familiar with function or class or object, you are familiar with variables because this is what we just discussed. But functions, classes, objects, everything else will be discussed later on. So don't worry about if you don't understand it as of now. You'll get to understand it throughout the runtime of this presentation. So there are certain rules that we need to follow when we're naming an identifier. The first thing is no special character except underscore can be used as an identifier. So we can't use a special character to be an identifier, a variable name or anything. Similarly, keywords are now not something that you can use in place of an identifier. So as we already saw, we can't use return, we can't use for. There are many other keywords that you cannot use as variable names, as something that you can use as an identifier. Then Python is case sensitive. So there a variable which is named var with V capitalized and a variable named var with every characters in lowercase. These are two different identifiers. So if I were to type var with V capitalized equals to 7 and type small v small a and small r equals to 7 and if I equals to 8, and if I were to print the values of both, we will get different values. So these are two different things. In when Python interpreter takes a look at it, it will assign two different buckets for them. Then the first character of an identifier can be an alphabet or an underscore, but not a digit. So as we have already seen that we can use any alphabet as the starting character of our identifier or variable name. On the other hand, we can use underscore as well, but we cannot use a number. A digit is not something that we can use. So that's you can use it afterwards. It could be the second or the last character or anything in between, but can't be the first one. So let's take a look at them. If I were to open the Python console, we have several ways of doing it. In Python, a variable is also an identifier. So let me just show you the casing problem. So variable is 7. And if I were to name it with a capitalized V, it's a 7. And if I were to name all of them capitalized, it's 7. So let me just change it. Now it's 7, it's 71, it's 72. So if I were to print var with everything in lowercase, it's 7. If I were to print it with V capitalized, it's 71. If I were to print it all capitalized, it's 72. So all of them hold different values. And the last thing is we cannot start it with a number. So let's say 1 var equals to 7. We'll get a syntax error. But if I were to do it v1ar, this is just fine, it will work. v1ar and it works just fine. Now we come to literals. So literals are just raw data that is given to a variable. So literals can be of many types: string literals, numerical literals, Boolean literals, special literals, and we'll take a look at them one by one. So as you can see, we can have several kinds of literals. This is some code that's been written for you, and we'll take a look at string literals first. So found by enclosing a text with quotes. Both single quotes or double quotes can be used. So this is some code that you can take a look at, and you can type it in your own console. You can type it in any other kind of environment in which you can run Python code. I will expect you to run it in console because that's where you get the most immediate feedback, but it's your choice to run it in any other environment if you're comfortable with it. So let me just show you what we can do here. So I open this, and as I've already discussed, we need to enclose our text within quotes to tell the Python interpreter that it's a string. Let's try it. So if I were to give path is a variable and I want to assign a string literal to it, I can type sample path. Press enter and it works. This is sample path. If I were to type single quotes, this wouldn't make much difference. It's going to be just the same. It's going to work just fine. Now the reason why we have single and double quotes for this, it's mainly because in C and C++ and many other languages like Java, single quotes were used for handling a single character, not a string, but a single character. So a single character would be something like A. That's a single character. A string with length of 1 is something that's called a single character. Now the way it worked in Java and C was that if you were to attach multiple characters one after the other, so let's say A, B, C, D, and then you were to do it that way, then that would be a string. And for that you can't use single quotes, you have to use double quotes. I'm simplifying things a lot because there's a lot undergoing like the null pointer and all, but you don't need to worry about that. You just need to understand why there's two quotes and why there's one quote. And that's the thing I'm trying to get across. So if a person shifts from C++ or Java to Python, they will be expected to use, or they will think they'll be using a single quotation mark for a single character, and that would work. And for that to work, they have created they have allowed for us to use both single quotations and double quotations. There's also one thing that you could do. You could use three single quotes as well. So if I were to write a really long line of code instead, or a really long line of string, I could just start it with three quotes. I press enter. As you can see, the prompt, instead of it being three arrows pointing left, it's now become three dots. Now I can type anything. Let's say that I'm typing this. I press enter. It's still allowing me to type. I type this. Let's say that you're typing a paragraph or a note or an email or something like this. I can do it this way. Now let's say that this is everything that I wanted to type, including the enter character. Now if I want to end it, again I type three single quotations, press enter. I get back the prompt with three arrows pointing left. I type in the word line, press enter, and as you can see, I get everything. This \n characters is something that is used to determine a new line. So if I were to print it using the print function that we have already discussed, press line. As you can see, it starts here, enters or creates a new line, prints everything wherever the \n character comes in. Then at the end, it again starts a new line and then ends it there. So the \n character is a special character that tells you that there is a new line here. So you don't have to worry about that as of now, but just understand that that's how we do it. It's not just strings though. There are many other different kinds of literals as well. There are numeric literals as well. And numeric literals allow us to use variables that can store numbers. Now we can have positive and negative whole numbers with no fractional part as integers, as we have already discussed. We could have real numbers. Real numbers are numbers with fractional part using the float variable, and we could have long. Long is also something that could be used to store values, but the important thing is that it could store a much larger value than integer. So as you can see in the description, it says an unlimited string of integers followed by uppercase L or lowercase l, and I'll show you what that means in a moment. And then it's also something that you could do. You could store some complex numbers, so numbers with real and imaginary parts. Now if you've worked with mathematics, if you worked with real and complex numbers, that you will understand what I'm talking about. If you've not worked with it, that's totally fine. It's not something that's used very often. It's only used in special cases where you need to display complex numbers. So in our case, let's just take a look at this. We have a positive and negative numbers, so we can store that in integer as well. Let's say that I want to store negative 77. I can store it in number, or positive 77. I can store it in number, and the type of number will still be a class of integer, right? But if I were to attach capitalized L here, that would cause an error. Oh, because it's a newer version. So never mind. So if that was the case, then I could do that, but it's not. Yeah. So as you can see, it's working fine. Now, if I were to do a lot of other things like floating point numbers 1.56, and if I were to get the type of it and press enter, this would give me a class of float. So float, as we have already discussed, is something that is used to store floating point numbers or fractional numbers or real numbers, however you want to call it. So that's how we store that number. Now there are many differences between how these are stored in underneath the hood. They are stored using binary format, and we don't need to get into that. But the thing that we need to understand is that when we're using binary format underneath the hood, Python takes a look at the data type and then decides how it wants to set the binary format of that number. So that's why we do it that way. Now there are many other ways you could do it, and you could use many other tricks as well to store other kinds of numbers, convert float to integer, divide two numbers and make it convert to float or anything else. That's also doable. but it's mostly that you're supposed to do it easily. That's there. Make sure that you're choosing the easiest option. Make sure you're choosing an option that works for you. In Python, the value of an integer is not restricted by the number of bits, so it can expand to the limit of available memory, and no special arrangement is required for storing large numbers. Now, that is mainly because in Python, you don't need to, as I've already told you, it's a high level language. It's not a low level language, so you don't have to worry about changing the types or the available bit size of a number when the number becomes large. Python will do it for you automatically. It will take a look at the number, it will take a look at whether or not it's exceeding the current memory bounds, and it will assign a larger memory bound for it so that you could add more numbers to it, unless and until it reaches to a point where it's overriding the available memory. That then there's no memory to store the number and it will cause an error. And no special arrangement is required for storing large numbers. Python again does it for you, so you can just follow on working on your application instead of working with the nitty-gritty details of how things work underneath the hood. This is why I told you that you don't need to worry about the binary arrangement underneath the hood. Python will do it for you. Then comes Boolean. So Booleans evaluate to true or false. True and false are basically a human construct. So let me just show you what that means. If I want to check something, let's say that there's a user and I'm building an application and I ask him to enter a password. He says the password is ABCD. He's creating his account. He says ABCD. Then it comes to confirm password and he writes ABCD again. Now I want to check whether or not password and confirm password contain the same number. So I press password equals to confirm password. I press enter and I get a Boolean value of true. So this is what allows me to understand how to move forward. If it returns true, then I can basically move ahead and tell the user, okay, everything worked perfectly. I'm going to store it in the database and do whatever I want with it. On the other hand, if it had returned false, let's say the confirmed password was ABCD1, the user mistyped it, and now I check whether or not they are equal, I get false. So this is what Boolean values are. You can assign them yourself. So let's say BOL equals to true. Make sure that you understand that the first letter is capitalized. So smaller letter TRUE will not work since Python is case sensitive. So if I were to type Perl, that's true. And I can also assign false to it. Press enter and this works as well. So this is how that works. Now that Boolean is understood, let's move ahead and see what other things that we have for us. So we have special literals. These special literals are something that we can use for ourselves. So these special literals in Python are called none, which means that the variable is yet to be initialized. So if you're coming from other languages, there's a concept called null, N-U-L-L. So that's basically what Python uses, but instead of null, we use none. So let me give you an example. Again, let's say that the user is entering something, the confirm password, and the confirm password field has been left blank. So instead of writing something inside it, he chose to write nothing and they submitted. I will get a none value here. That means absence of a value, that the user has not provided a value. So that basically means that if I print confirm password now, I will get nothing because nothing is there. It contains no value. It's empty. Think of it as a box that contains nothing as of now. And when the user does enter something, that box will contain that value. So that's what none is used for. It's used to define absence of value, not an empty string, not any other kind of string, not zero, not anything else, but an absence of value. And the type of none is none type, in case you were wondering. And now we have operators. So let's take a look at some data types in Python. So data types in Python could be divided into two parts, immutable and mutable. So immutable data types are data types that cannot change. On the other hand, mutable are data types that could have their values changed. So for instance, string, numbers and tuples will have some value assigned to them, and then when we want to change them, instead of adding something to it, it will create a new data type for that. It will create a new value for that variable to hold. On the other hand, in mutable we have lists, dictionaries, sets, and in lists we have several types as generic list or tuples and all. We'll take a look at them one by one. So let's take a look at them. So we have numbers. So a number is basically, as we've already discussed, data types such as integer, float, and complex data types. They come in numbers. So as you can see, a whole number with no decimal point is integer. A fractional number, a number that has one or more numbers after the decimal point, is floating point number. And a complex number is a number with real and imaginary parts. So again, complex numbers are not that prevalent. Mostly we use integers and floats. Complex number have some use case, but not a lot. Then comes strings. So a string is basically a lot of characters that are enclosed within either a single or double quotes, and they are used to store text. So a string literal could look like this, as we've already seen. So there are some operations that are being performed on string, and we'll take a look at them now. So if I were to open my Python prompt, let me just define a string. So string equals to, hopefully you can see this, and if I type A, B, C, D, E, F, G, H, press enter, this is a string. Now if I want to take a look at the length of the string, how many characters are there in this enclosed within the double quotes, I will type length string, and I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Now let's say that I want only the first 4 characters. This is what is known as slicing. This could be done with a string or with any other character as well. Firstly, let me show you what happens if I do this. I get A. This is what is known as indexing into a string. Basically what I'm doing is I'm saying in the string variable, whatever data it holds, I want the data that is stored within the first position. And in string, everything starts with the position starts from 0. So 0 is the first position, 1 is the second position, and by that logic, since there are 8 variables, 7 will be the last position. I press 7 and I get H. If I try to go outside these bounds, let's say I press 9, I get index out of range. Basically, there is nothing after the position 7. Everything outside that is not accessible by Python. We have not assigned any memory to it. So that's illegal for us to do, and that's why we get an index error, as you can see here. Index error mainly because we are using this, and this is what is known as an index, something that is enclosed after a variable named enclosed within 2 brackets. So now that we know how to access a single variable, a single character in a string, let's say that I want the first 4 characters. First 4 as in A, B, C, D. So I start from 0 and I want everything before the fourth character. Why? Well, because 0, 1, 2, and 3 are the first 4 characters, because it starts from 0. So we have 0, 1, 2, 3, which are first 4 characters. So how do I get all of them at once? Let's say there are 15 and I want 0 to 14. So what I can do is I can type 0. After that I type a colon and I type 4. This means get me everything from the beginning of the string and right before the fourth character. So the fourth character is E and before that is D. I want everything from A till D. Press enter and I get a substring of it, which is A, B, C, D. So this is what slicing a string looks like. This is what's known as a slice operator. Now you can do it every other way as well. It's not necessarily that you start with 0. You can start with 3 to 4, which will give you, I think, just one character, which is D. Now another thing, if I were to leave this off, what do you think will happen? Pause the video and try to think about it. But if I were to do it now, it starts from 0. So it defaults to 0. If I were to start it with a number that's this, it will give me an empty string because it makes no sense. So that's how you do that. And finally, if I were to leave 4 off, since we know what happens here, I think we can probably guess what's going to happen here. I'm going to press enter and you can see what happens. What happens is we take everything from 5 till the end. So we have the fifth character, or the sixth character in this, which is on the fifth index, is let me just print the string again because it's gone out of character. So it's this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. I want everything from the fifth character till the last character. So this is what that means. And finally, I can use negative indexing here as well. So I want everything from the beginning till the last, removing the last one character. If I were to remove the last two characters, I can do this. And this works just fine as well. So that's how slicing works. Another operation we can perform is replace something in this. So let's say string dot replace. If I were to show you the example here, as you can see, it says replace ed with e, and it will do that here. But let me just show you. Replace f with g. I press enter, it returns another string to me, which is a, b, c, d, e, g, g, h. Now if I were to take a look at the string variable that contained our value, it has the same data. So when we perform this replace operation, what we're actually doing is we're saying give me another string in which you have replaced all the f's with g's. This is especially useful if you're trying to remove some content out of a long line of text. So let's say that you have 17 lines of text in which you want to remove all the, let's say you want to remove all the vowels for some reason. You could just run this and see if there is any A, E, I, O or U and just remove that. That will work just fine as well. So now that we're done with string, now we're done with data type in string, let's move ahead. Now comes tuples. Tuples are a sequence of immutable Python objects. So what does that mean? Well, let's say that you want to store the number of or the name of weeks or in string format in a variable. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days in a week, and all of them need to be stored in a single variable. Now there are many ways to do it. One important thing that you need to notice here is that this data is not going to change ever. There is no time in future are you going to go that we need to add another day to the week. That doesn't seem very feasible. So because it's not going to change, we are going to use an immutable data structure or an immutable type, which means adding something to it is going to be it's not going to be something that's allowed. So let's say that I want weeks. Now I want to store everything in one. I could certainly create variables that say sun, which will contain Sunday, and similarly Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's certainly doable, but again it runs into the same problem. Let's say that we had 14 things that we needed to store. Let's say that we had 100 things that we needed to store, and we needed to access them using one variable. That would be very difficult to remember the variable names of 100 different kind of variables. It would be better if you could store them just in one variable and then access them using the position syntax that we had discussed earlier in string, like this one. So this is where tuples come into play. So let's say weeks, and I enclose it in brackets, but that's not really necessary. But I would do that here. Now let me just type in Sunday, and you could type it with me, Monday, Tuesday, Wednesday, Thursday. Make sure that you're separating them with commas. I'm typing a space after commas to make it more readable. That's not really necessary. Friday, and finally Saturday. Press enter. I press weeks, and this is what we get. If I were to take a look at the type of this, type, it's tuple. So now I said I used commas here, and that's not really necessary. If I were to use this would also work. The way Python identifies that this is a tuple that we want to add something to the data is by taking a look at this comma. So it takes a look at this line. It says, okay, weeks need to be assigned some value. It takes a look at Sunday. It says, okay, one string and this comma. That means other values are also going to be assigned, and this is a tuple. Even if I had not put the parentheses before and after, opening parentheses and closing parentheses to enclose this list, it would work just fine. Now, one thing that I would like to show you is if I were to go weeks 0, I get Sunday. Weeks 6 should give me Saturday, right? But if I were to assign some other value to it, let's say any gibberish value, I press enter and it gives me another. Tuple object does not support item assignment. Now this is one of the major advantages of using immutable object. It does not let anything in the data that you have already entered to be manipulated. So if you have entered a list of something that you know is not going to ever change, then tuples are the best option for you. So this is why we use tuples. So now let's take a look at something else. We have lists, dictionaries, and sets. So lists are very much same to tuples. One major difference is that you can make changes in a list. So if you have dynamic data that changes rapidly, then you can use a list for that instead of creating new tuples for every change that has occurred. Let me show you an example. Let's say that instead of weeks, I wanted to store, let's say that I wanted to store salaries of people, right? I can store salaries of 3 people. Let's say that it's stored in thousands. So 10 means 10,000, 15,000, 20,000. Press enter. And now if I were to take a look at salaries, press enter, I have 3 salaries. If I were to take a look at the type of salaries, I would get list. It's not a tuple, it's a list. That means that if I want to change the salary of a person, because it does happen that a person gets promoted, they get an increment or whatever happens, they say that the person at the index 0 is now going to get a salary of 18,000. And now it does not throw any error because I am using a list and I can store any kind of data. It's still a list. And if I were to print it, now it's 18. Another cool trick that I can show you is that instead of this doing it like this, let me just assign 10 to it. And let's say that the thing that I want to do is I want to, instead of assigning a new salary, I want to add 8,000 to the guy's to the person's current salary. Now there are many ways to do it. First way to do it would be salaries of 0 equals to salaries of 0 plus 10. So what happens here is I take a look at this. I want to assign the value at index 0 to be the current salary of the person and add 10 more to it. Let's add 8 more to it to add consistency. So as you can see, this is what it looks like. And now if I were to look at it, it works just like that. But as you can see, the typing this is quite long. It's a bit repetitive. So you get, if you've already taken a look at the operators slide that we have taken, that we have gone through, one operator there was plus 8. Now what will happen is it will add 8 to the already existing salary of the person at index 0, which is 18. So 18 plus 8 would give you 26, and that's what we've got. So you can do it this way. You can add, remove, you can add data to it as well. So I could go salaries dot append. Append will allow me to add a new salary for a person. So let's say that it's 28. I press enter. Now instead of 3, it contains 4 salaries. Append is not something that you could do on a tuple. So that's how you do it. And another thing is that instead of storing all everything as an integer value, you can store data of any type. Let's say that I want to store 1 a and I want to store a floating point value as well. This is also doable. So I can type mixed equals to this. This is one of the advantages of using Python. Many languages don't allow for this kind of intermixing of data when just trying to store it in an array or in a list. So you can take a look at that. Now if I were to type mixed, I get this. I can store any other kind of data. I can even store another list inside a list. So if I wanted to store another list, 155 comma b. I'm just adding some gibberish value just to show you this is doable. I can add another tuple to it. This time I need to put this parenthesis, so to describe I'm adding a tuple 88 77 and it's done. Now if I take a look at mixed, I have this. If I want to take a look at mixed of 4, right, it's tuple, and I can take a look at the type of the tuple, so to see if it's a tuple or not, and it's a tuple. And if I were to take a look at the type of something at index 3, it would be a list. So you can nest any kind of thing, but just don't go too crazy with it. That could cause a problem. You will not be able to comprehend the data that you have if you go extremely benign on it. Then we have dictionaries. In other languages, they are called hash maps or hash tables. So a major advantage of using a dictionary over a list is, firstly, it allows you to create a key value pair. So again, let me just show you. So if I want to associate a person's name to the person's salary, instead of doing a list which could only be accessed using a numeric index like 0, 1, 2, 3, what I can do is I can create again salaries equal to, and I can create a dictionary like this. Add two curly braces. Inside it, add the key, which would be the person's name, let's say John, and end the quotation. And now the person whose name is John gets 15,000. Let's say that there's another woman who's named Jane. She gets 14,000. Let's say that there's another woman named, another man that's named Johnny, and he gets 5,000. Press enter, and now if I were to print salaries, it will display the key value pairs. If I were to take a look at the type, it will give me a class of dictionary. So that's all good, but one thing that it allows me to do now is I can access it using the person's name. So let's say that I have salaries. I want to get the salary of Jane. Press enter, I get 14. That means Jane earns 14,000. Let's say that instead of Jane, I want John. As you can see, John gets 15,000. And if I were to use a name that doesn't exist, I'm going to get an error. This is called a key error. This key does not exist. Now, a way to come across this or come over this is, instead of indexing directly, you can use get. So I want salary of John, but if it's not available, give me 15. So I'm getting 15 because that's the salary of John. And if, let's say that I were to use some other key that is non-existent, the person named John ASD is not available in our dictionary. So if I press enter, I'll get 18, which is the default value. I could set it to anything. I could even set it to 0. So now if I try to access a person whose name is not available in our dictionary, I'm going to get 0. So that's one of the major advantages. Another is really fast. So even if you have like 10,000 records, the way hash table works or the dictionaries work underneath the hood is, instead of it going through all the 10,000 names and finding the name that you want it to find, it does some clever tricks and makes it really, really fast. This is why if you are doing something that requires really fast access to some data, and you can give some unique key for that data to be accessed, then definitely use dictionaries instead of using lists, because in lists you could in lists do something like this. Store a list of list in which the first thing is the person's name, second thing is the person's salary. I could do it here as well. The first thing is the person's name, Jane, and the salary of Jane is, let's say, 80. Okay. Now, if I wanted to, I could define a function that could find this or do a lot of things. But the important thing to understand is, if it was, let's say, 10,000 records, and I wanted to find a person's name let's say that a person's name was not John or Jane. I wanted to find a person whose name is at the end of this list. Let's say I don't know where the name is. Let's say that the person's name is Andy. So we go through the entire list searching for the first element and checking if that first element is Andy. And if it is handy, then we print the salary. If not, then we print 0. Now, for that, we have to take a look at all the 10,000 elements. In dictionary, what we do is we can just give the name, and dictionaries will do some clever tricks behind the scene that you don't need to worry about, and it will instantly find it for you. So always use a dictionary when you have large sets of data and you want to constantly find things in it. If you want to just store some data and you know you can access it using numerical indexes, and the data keeps changing, then use lists, because in tuples you can't change the data. So if I have some, let's say I have 0, and I want the person with the employee ID of 0 to have salary or something, then I could press 0. Here it's not going to work because I've reassigned it to a dictionary, so I'm getting a key error. But you can understand my point. On the other hand, let's say that I have a data set which does not change and I want to access it using numerical indexes. Then tuples come into play and you used to use tuples. And finally, we get to sets.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Sets are by far one of the most underused data sets, and you need to understand why we use sets. So sets are again unordered collection of immutable data which has no duplicate elements. So what does that mean? Let me show you. I can create a set. By the way I'm showing you how to create dictionaries and all, that's not really necessary. Let's say that I want to create my sample dictionary. I can just use the keyword dict function and it will work just fine. Now it's an empty dictionary and I can add data to it. Another thing, you can add data using dictionary and typing in the name and then assigning a value. This will work just fine. Now the thing you need to understand is similarly you could use instead of this you could use tuple. This will create a tuple, and L list will create a list. Now I want to create a set. So let's say that I name it S. Now I can do it this way, but I won't be able to add anything because this will be taken a look at as a dictionary. So the best way to do it is use the keyword set or the function set. And now if I take a look at S, it's a set. So what is a set? Set, if you have worked with mathematics and you have worked with Venn diagrams and everything like that, you are quite understandable of what set is already. A set is basically something that contains a lot of values, but it does not contain any duplicate values, and it allows you to check whether or not something it contains a value or not in constant time. So let me give an example. I think s dot add 1 would work. Now if I take a look at s, it has 1. If I were to add 2, it contains 2. Now if I were to add 2 again, it instead of containing 2 elements named 2, it contains 1 element which is 2 with the value of 2. Now if I want to check whether or not something exists in a set, let's say 1 in s, and it will show you true. This is the in operator or the membership operator that we have already taken a look at. And if I were to take a look at whether let's say I want to check whether 5 exists or 3 exists, it's going to be false. So why are we doing this? Well, one thing that you can take a look at here is that it again, since we are using set, it is extremely fast for us to perform this operation. Let's say that there were a million records in this and I wanted to check whether something exists in it or not. the first intuition that comes into our mind is to take a look at everything that is inside the set, all the 1 million things, and compare it with the data that we want to find. If it's not there, then we return false. If it is there, if it's found in while we're taking a look at all the 1 million data points, then we return true. Now again, that is fine, but if it's 1 million records, then it takes a lot of time. And let's say that you had to do it constantly. Let's say that you had to check whether or not something exists in those 1 million records 10,000 times, 20,000 times. That's a lot of computation. So again, sets do some really complicated mathematical things underneath the hood to basically just check whether or not something exists inside it in real time. That's why it doesn't contain any duplicate values in this as well. And so I can do one in S as well. If I were to assign a list of 1, 2 to it, and then instead of 1 in S, I can type 1 in L, and that will return true as well. The difference here is that it takes a look at all the elements, 1, 2, and whatever, and finds if something exists in it or not. Whereas in set, it's extremely fast. So if you have some data that you want to keep track of and want to check whether or not another value exists, or you want to deduplicate the data, you can do that as well. So use set when you want to check memberships really fast. You can perform the union, intersection, and all that, and that's very easy to do with sets as well. So now let's take a look at how to deal with sets and how to deal with different data types. I'll show you some hands-ons to further strengthen your knowledge of data types. So let's take a look at the setup that we're working with. So we'll be taking a look at data types. We'll be taking a look at lists, sets, dictionaries, and tuples, the things that we have already discussed. But instead of typing into the Python console that we had done earlier, let me show you how. This was the console that we had typed code into. Now for typing out single lines and executing them, this console is actually very good. But let me just exit out of it. When you want to type in a lot of code and you want to open a code file and do execute it and run all that, I would recommend that you use Visual Studio Code. So let me show you what it is. Let me just open a new window, and here type in VS Code, press enter, and open this. Once you've done that, you can download it for Windows or for any other operating system that you have. After you've downloaded it, you can install it like any other software that you install. But after doing that, just right click on a folder that you want to open it into, type and press the open with code function. It will open with this code folder. So it's done. And as you can see, there are no files as of now in this folder. The folder's name is hands-on, in which we'll be performing the hands-on. Let me create a file called app.py. Py is the extension, the Python extension. Press enter. Now, just to make it clear, you don't have to use VS Code if you don't want to. You can use Notepad for this as well. Just go to the folder, create a file named app.py, and right and click on edit. It will open it in Notepad, and you can make the changes there as well. There's virtually no difference. Now what we need to do is I open this, and let me just make some changes. I'll increase the font size so that you can see a little better. So it's loading some extensions, and while it's doing that, open the command prompt. To do that, just go onto the address bar, delete everything, type cmd, press enter. The reason why we do it this way is because we want to open this command window in this folder, so that the files that we create, the app.py file, I want to run it using the Python command. If you've installed Python, then it's already available for you. So you can do it this way. Now if I open this, as you can see, I can type in a lot of things. So let me just increase the font size. I think it's now I'm going to type some Python code. Hopefully it's visible to you all. So in Visual Studio Code, you can write code, and the reason why I'm choosing this is because it shows you some syntax highlighting. It shows you if you've written something wrong. It auto formats the code for you. It does a lot of things for you right out of the gate. So to perform this, what I'll do is the first thing we'll have to do is we have to use lists. So let's say that I create a list named nums equal to, and the numbers that I want to insert in it are 1, 2, 3, 4. So the first task I want to do is I want to print it. So I print nums, save the file. When you save it, this icon changes from a filled circle to closing to an X. Now that is done, open the command prompt and type python Python and the name of the file, which is app.py. Again, I press enter and it's there. Let me just increase the font size here as well, so that it's easier for you to see. Let's say it's 28. That's easier to see. Right. Yeah. So again, Python space and the name of the file, which is app.py in our case. And one thing that you should notice is that app.py is in the folder in which the command prompt is open. So it's C user, my username, desktop, and in the desktop we have a hands-on folder inside which we have created the app.py file. This is why this is working. Another thing you can do is you can press this command, but it would work sometimes and sometimes it won't work. So I don't like doing it that way, and it gives you this line of code as well, which is fine. But we're doing the same thing. We're typing Python and the name of the file. So you can do it either way that you want. Now that is done, let me just add a comment. So a comment is basically something that you add in a code so that you can explain your code better. Now if I type anything here, this code will not be executed by interpreter. It's just for the reader of the code. So any person who's reading the code can take a look at the comment and understand. So I'll type declare array and print. Declare list and print. Right? If I run this again, it's not going to make any difference because it's a comment. Now that is done, let me show you how you can add something to the list. So you get the append method. In the append method, I can type in a number. It could be of anything. It doesn't need to be a number. It could be a string. It could be an object as well. I'll type in a number though. Let's say that I want to add 5 to it. I save it. I print it again. Run it. And I think I've run into an error. Yeah, I want to print nums. Sorry. And as you can see, now nums has 5 in it. I can do a lot of things in it as well. Instead of that, I could use the pop method. Pop method removes the last element if I don't pass in an index. So if I were to store the value, what it does is that it removes the value and returns it so that I can also take a look at what was removed. And now if I print nums, run this. This is the number. I added 5 to it. It's this. Remove the element at the end, which was 5, and now I print it. It's 4 again. But a cool thing that we can do is instead of not specifying the index, we can actually specify what is the index of the element that you want to return. So if I want to remove something at the beginning of the list, I type in 0. This would remove 1 from it. So if I run this again, instead of 5, we'll see 1 removed. So 1 is removed, and now it's 2, 3, 4, 5. So again, you can do a lot of things with it. One of the things was this. Now let me show you something that's really interesting. So if I want to print all of them, what I do is I use the for loop, and we'll discuss this in a later slide, but just to give you an example of where looping is useful. If I have 10,000 elements, instead of accessing them one by one and writing things like print num0, and then I keep going on like print num1, num2, num3, so I print all the 4 numbers. What I can do is I can just print a loop and tell it that I want to print everything inside the list. So everything in this list, I want to do something with it, and what I want to do will be indented here. Do you notice that I put a tab after this, or Visual Studio Code does it for me? This is what's called indentation. This is what tells Python what is the code that I want to execute in a particular block. So if I type print x, and if I do this, as you can see, it's printed 2, 3, 4, all of them in a new line for me. So this is what the loop looks like. Now, if I had not done it this way, if I had done it this way, then Python would have no idea whether or not I want to include this line in the loop, whether this should be executed in the loop or not. Or to give you another example, now I want to print done. Done will be printed at the end of the file. So if I run this, it's printing done after each execution. But if I unindent it, if I push it to the left side, I run it again, and now it's printing done afterwards. So Python looks at it, goes, okay, everything that's underneath this for loop that's indented 1 point to the right is going to be something that needs to be executed within this loop. And this is how Python reads your file and understands what is the code that I need to perform and how. So make sure that you understand the indentation. Now that we have looped over this as well, let me show you something about tuples. So instead of 1, 2, 3, 4, 5, if I remove the parentheses, what do you think will happen? Press enter. So it prints everything, but it immediately gives me an error that there's no way to add something to a tuple. If you remember, we have already discussed that tuples are not something that you can add something to, they are immutable. So that's why we do this. So instead of appending, I don't think we can remove things as well. I press enter and pop is also not available. But you can print them, you can loop over them just as we did earlier. As you can see, 1, 2, 3, 4, 1, 2, 3, 4 done. It's completely doable. Now let's move on to dictionaries. Let me type this dictionary, dictionary, or let's say I'll call it cell. I'll define a dictionary the way I did previously. Jane 15, John 20. I need to add it as a string. Now that that is done, if I print it, let me just remove this. It's this. I want to add something to the list or to the dictionary. I can just do it this way. I want to add Andy to the list, and he earns 25k. Now if I were to print this, let me just, yeah, now we're getting Andy here as well. As you can see, Jane, John, Andy. So this is working. If I want to delete something from the list, let's say that Andy, I don't want to print, I don't want Andy in this list anymore. I use the del keyword. Inside, I just type in sal of Andy. I run this again, and Andy is removed. So that is fine. That's how you remove an element from a list or a dictionary. Other operations we have already performed. One thing that we haven't performed is looping over this. So let me just show you. For item in, and here things get a bit complicated. So instead of just sal, I have to type items. If I just want to loop over the keys, I can type sal.keys. And if I print item, what do you think will be printed? So pause the video if you want to think about it and then answer. But what will be printed are the keys. So the keys are Jane and John. Remember, a dictionary is a key value pair. These are the keys, these are the values. So Jane earns 15, John earns 20. So we type it, we print in the keys. Now if you don't want to print the keys, let's say we want to print the values. I do that, now I can only print the values. But let's say that I want both of them, items, and I want key as well as val. Now I can print key, comma, val. And as you can see, I'm printing Jane space 15, which is the key, comma, value. So we're getting the data that we want. Now, another thing that we can do is we can print Jane in cell. Print it and we get true. It's the same operation, it's a membership operation, but if I were to type in DSF, I'm going to get false. So again, this is what it means. And now let's take a look at a set. So let's say S, create a set. Another thing you can do is you can use this symbol, but instead of typing a key value pair, you just type in the keys. So if I print the type of S and I run this, it's a set now. So if I were to keep it empty, then it would become a dictionary, because this is what the default Python behavior is. So this is what it looks like. We have a set for us. Now if I want to add something to the set, I just use the add method. I want to add 1, and I want to add 2, I want to add 3. And now if I were to print s, it's 1, 2, 3. So this works fine. But if I were to loop over it for x in s, let me just print x, as you can see we get all the numbers in it. And if I were to print the same thing that we did earlier, 1 in s, I'll get true. And if I were to print 4 in s, I get false. So this is what this looks like. This is what our code looks like. This is how it works. So hopefully that was informative. Now let's move ahead and see what else can we learn about Python. So now let's take a look at comprehensions. Comprehensions are quite an interesting feature in Python. They're very easy to use. They're very informative, and they are quite fun to work with. So let's see what they mean. As of now, we know how to create a list. I asked you to create a list, and let's say that I tell you that, hey, I want you to create a list, and in that list, I want you to enter number from 1 to 5. What are you going to do then? And let's say not 1 from 5. Let's say that I say, I want you to enter in a list. I want you to create a list and add a number from, let's say, 1 to 10. Or it could be anything. It doesn't even have to be 1 to 10. It could be any arbitrary number. So how do you go about doing that? Well, we know we can do it using loops, and that's how many languages ask you to do it. So I'll create a list which is empty, and for let me show you how to loop to a certain extent. I want to loop for x in range, which is a function that allows us to loop over a particular range. I want to loop from 0 to 10. So it will loop from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. Not 10 because the end is exclusive. So always remember that. And now if I do L dot append x, and finally we can print x, not xl. So if I were to clear the screen and type in this, as you can see, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is fine, but a major problem that you can see with this is the fact that we have to write a lot of code. Wouldn't it be nice if we could just compress this all into a single, compress all of this into a single line of code, because we are just instructing the computer to add something to a list, right? So this is possible using comprehensions. I define an empty list. I tell it add x to the list. Now Python is waiting for me to define what x is. So I'll go for x in range 0 to 9, and that's it. Now this is something that many other languages don't provide you to do. Python is quite easy to use, so you can do that. Here we only get 0 to 8, mainly because it has to be 10, like we did earlier, and this works. Now this is just list comprehension, but I can perform many other kinds of comprehensions. So list is this. Let's say that I want to perform a tuple comprehension. So for this I have to use parentheses. And let's say that I want to perform a set comprehension and a dictionary comprehension. All the data types that we have discussed so far could be, all the containers that we have discussed so far for the data types could be used to perform comprehensions, as we are about to do now. Comprehensions are quite easy to understand once you get through the basics. So let's see. Let me just print all of them one by one. So we will print the tuples, then we will print the set, and then we will print the dictionary. So let me just show you. This is what tuple comprehension looks like. What will it be for set? Just changing it to parentheses will work. Now for dictionary, we need a key value pair. So let's say that we want to store key as the current number, which is the number from 0 to 9, and the value as the square of the number, which is number divided by itself. So this is what it looks like. Now for a number to be key value pair, I want to define the key, press colon, and then define the value, which is x multiplied by x. Now if I were to print it, as you can see, we get this, we get a generator object, and we get this, and we get this. So this is what it looks like. Now generator objects are quite easy to understand. You can just, let me type in comma, press enter, and so you will get into error. So don't do it this way, but you could use tuple, and now you press enter and you get a tuple out of it. So this is one of the problems when it comes to tuple comprehensions, that you can't just use it this way, right? But this is what comprehensions look like. They're quite easy for you to create once you understand how to create them, and it's very easy for you to understand how to write code like this, and it just allows you to write succinct code, or code that's easy to understand. Now that that is done, let's see what else we have to do. So now let's take a look at conditional statements. So a conditional statement is basically a statement that allows you to change the flow of execution, or the path of execution, when a provided condition evaluates to either a boolean value of true or false. So suppose that we had some way of figuring out whether or not you're sick or you're healthy. So what happens is, let's say that you want to make a decision. First thing is, we ask you, are you sick? So let's say that you are sick, then we would advise you to go to the doctor. But let's say that you are not sick. That means the condition whether you are sick or not evaluates to false. And then you can go out and play football, do whatever you want. This is where conditional statements come into play. And we encounter conditional statements every day during our lifetime. We have encountered conditional statements. I think you probably encountered conditional statements today as well. Waking up, when you're waking up, you decide whether or not to sleep for an extra 5 minutes, whether or not you are late for a meeting, whether or not to take a cab or a taxi or walk to the place that you work, whether or not to eat at one place. These are the kind of situations that allow us to think of conditional statements in a more rational way. So this is what it looks like. We have many ways of doing this. One is the if-else statements. So the statement looks like this. We have the if keyword. Inside that keyword, that's a condition. If that condition evaluates to true, then statements 1 and everything before the else statement gets executed. But if, say, the condition is false, then everything underneath the else statement will get executed. We'll look into it in more details when we are performing the hands-on, but right now just understand, if the condition is true, then statements 1 is going to execute, and if condition is false, we'll execute the else statement, which is the statements 2. Now, there are many ways you can construct an if statement depending on the logic that you're trying to build. You can construct a nested if else statement, you can construct if else and else if statements, you can construct a lot of different kinds of if else statements. So you're not limited to just use if and then else and then your conditional statement ends. You can use if this not true, then if this is true, then if this is true, then if this is true. Then you can take a look at a lot of conditions that way, or you can nest them one inside the other. That would work just fine as well. So now let's take a look at some conditional statements. Again, we have the same setup. We have an app.py file. Py is the extension for the Python executables or the Python scripts that we write. So to write it, let's first take a look at conditional statements. So there are a few keywords that we use in conditional statements. Keywords like if, else, and elif, which is short for else if. So let's take a look at this. So let me define a number named x and it's equal to 20. Now if I check if x is less than 20, then I will print x is less than 20. Else, and now else print x is not less, or you could say x is greater than 20. So now this is a statement, but it's a little incorrect. I mean, it's not incorrect in the way the syntax is structured. So if I write this, it says x is greater than 20. And we know that's not true because x is not greater than 20, it's actually equal to 20. This is where the else if statement comes in. So we can add multiple conditions and attach code to it that will execute when one of the conditions satisfied. So if I type elif, x is equal to 20, and remember to put two equals, mainly because we're not assigning a value, we're trying to check whether or not a condition is correct. Print x is equal to 20. Run this again, it's correct. So this is where if, elif, and else come into play. If for condition, and a conditional statement will always start with if, not with elif, and neither will it start with an else. Then we'll check, okay, if this is not true, else, if this is true, then do this, and if this is true, then do this. Make sure that you understand that only one of these statements will get executed. So in no condition will it happen that this will also get executed and this will also get executed. So if I were to do x is less than, and if I run this, it's still going to execute the first statement, which is x is less than 20, even though the second statement is also true. So make sure that you understand that. And now let's take a look at nested else if. So this is what it looks like. Again, I could have made the same mistake. I could have just put equal and that would have caused an issue. Now, nested else if basically means an if statement, and I want to check if x, let's say x is less than 20 and is less than 15 as well. And I put it 10. So I will print something out there as well. X is less than 15, and I can type in else. Again, write some code. X is greater than 15, and finally else. X is greater than 20. So if I run this, x is less than 10, 20, and x is less than 15, which is true. Now if I were to give it a value something between 15 and 20, x is less than 20 but is greater than 15. So what's going on here? Let's take a look at the path of execution. We assign a value of 17 to x. We check this condition. We check if x is less than 20. It is less than 20. We go down. We print x is less than 20. We go down. We check x is if it's less than 15. It's also true. So we go down and we print this. We skip over these statements because one of the conditions has evaluated to true. We go down here, and since that condition has also evaluated to true, it's fine. But now if I type x is equal to 21, what do you think will happen? Just one statement gets printed because it comes here, sees if x is less than 20. Well, x is not less than 20, so it just skips over everything inside if and moves to else and prints that, and it's done. So this is where nested if statements and else if statements come into play. You can nest it really deeply, but your code becomes really difficult to read. If you can you can do it like this as well. If x is greater than 15 or something like this, and then again underneath that you can type another if, but it makes your code really difficult to read. So make sure that you understand the trade-offs when you're using if and else if statements. Now let's take a look at looping statements. So a loop is a process in which we have a list of statements that execute repeatedly until it satisfies a condition. So let's say that I want to print something 50 times. Instead of me having to write it one time and then copy and paste it 50 times, what I can do is I can instruct my Python program to repeat something or repeat printing something 50 times, and that way when the condition that is satisfied is that it has this statement been printed 50 times. If it has, then we print that. If not, if it hasn't been satisfied, then we keep on looping and keep performing the task that is inside the loop. And if we have satisfied the condition, then we exit out of the loop and move on to the next statements. So there are many kinds of looping constructs. The first thing is we have a for loop. So a for loop basically allows us to write code in which we can basically iterate over a lot of things. So this is what the flowchart looks like. We take a look at the variable, and we check is there a variable in the list, and if it does not have any variable that are remained to be performed the task on, then we perform the rest of the code. Else we perform the statements, we move on. We perform the statements, we move on, and we keep doing that over and over and over again. This is where the looping statement comes into play. So then we'll have an example of this when we're performing the hands-on, so don't worry if you don't understand it as of now. Then comes the while statement. So the while condition is something that is also used in loops, but the fundamental difference is while loop is used to loop over a bunch of statements in which what we're trying to see if a particular condition is true or not. Instead of looping over a particular list of things, we can just use a while loop and loop over some things until a specific condition is true. So here what we're doing is we're setting a variable a to 1, then we're checking whether a is less than 5. So 1 is less than 5, we print 1. We add 2 to a, so a is 1 and 1 plus 2 equals 3. So now a is equals to 3. Is 3 less than 5? No, it's not. So the condition evaluates to false and we print it. So we print 3, we add 2 to it, 3 plus 5, 3 plus 2 is equals to 5. So a is now containing the value 5. We check whether 5 is less than 5. That's obviously not true. A is equals to 5. So we end the loop, and since there are no other statements left to be executed, we exit the program. Now when we're looping, there are certain keywords that help us in the loop. These are break and continue. So what do they mean? Well, the break keyword allows us to end the loop prematurely. So let's say that I have a list of names. Let's say that I have a list of names from a list that contains alphabets from A to Z. What I want to do is I want to print everything in the list, but if anything, if the character in the list is D, then I want to stop the loop. I want it to not continue any further. I want to just exit out of the loop. Anything after that is not going to be printed. So this is where the break statement comes in, and it's coupled with an if statement. And we'll take a look at this in an example when we're performing the hands-on. But now just understand that if you have a condition in which you want to exit a loop abruptly or prematurely before the loop has actually ended, then you can use the break statement. The continue statement, on the other hand, does something quite similar. So you can take a look at the break flowchart as well if you are unfamiliar with what it's doing. Basically, we check a condition and we check the break condition. If the break condition is true, then we break it and exit the loop. If the break condition is not true, then we continue with the loop as long as possible. Again, this is a bit esoteric, so I'll explain it in the hands-on when we're performing it with the code. Then comes what we'll try to do, which is looping and using continue. So continue does something similar to break, but instead of breaking the entire loop, what we do is we skip over that loop. So let's say that I'm again doing the same thing, a list containing all the alphabets from A to Z. I want to print it. They are ordered in any way that you like. What we're doing is we're taking a look at the alphabets and we're printing it on the screen. But if the alphabet is D, then we don't want to print it. We don't want to perform anything that's being done to other alphabets. So what we do is we take a look at it. We see, okay, if the current character is D, then we use the continue keyword and we skip over the rest of the statements that are used to execute the loop, and we just move over to the next character. So that's what continue does. And now we'll take a look at a hands-on in which we'll be performing tasks using all the keywords that we have discussed as of now. Let's take a look at some loops. So again, we are in our app.py file, and I'll write some code for you to run to understand loops. So we'll take a look at for loop and while loop. The first thing I'd like you to see is we're going to be printing a number from 1 to 10. So let me just show you. So this is a classic example of loop for x in range. Range is a pretty common function used in Python. If you've never used it, I would suggest getting comfortable with it. It basically means, I'll explain the code in a moment. So what we're doing here is we're instructing Python that, hey, I want to loop over something. Every time the loop iterates, I want the value to be stored in x. And what I want is the range to be going from 0 to 10 minus 1, which is 9. Always remember, range is exclusive of the end. So if I were to type 11, that will go from 0 to 10. So that is done. Now what happens is when I print x, what it will do is it will start ranging from 0. So it takes a look at 0, prints 0, goes 1, increments it by 1, goes to 1, prints 1, 2, 3, 4, 5, 6, 7, 8, and it goes to 9, prints 9, and then it is out of range, so it stops abruptly. So let's see. If I were to run this, as you can see, it's printing, but let me show you a trick. When you're printing something, type the end equals comma, right? So end space. So now if I print this, instead of each thing being printed on its own line, what's happening is it's going to print it with a comma and a space between the next element. As you can see, that's the reason why there's a comma and there's space here as well. So that is done. And so this is how you loop over a range. But let's say I don't want to loop over a range. Let's say that I want to loop over a list of numbers. So again, nums equals 1, 2, 3, 4, 5, right? Or if you remember with comprehensions, x for x in range 0 to 10. Now we have all the numbers that we had earlier, and this is what it looks like. I run this again. Okay, for x in range, and now it's doing the same thing. So we have numbers here, and for each number we are looping over that. Now that that is done, one thing I can show you is after looping we can take a look at some of the statements that we had learned earlier. So break and continue. So let's say that I only want to print till 4. Let's say that this is a shuffled list, and I want to break the loop and not print 4. So if x is equals to 4, then break, else will print x. So I do this 0, 1, 2, 3, it encounters 4, and since the condition is satisfied, executes the break statement, gets out of it, and the program is not ended yet. If I want to type something below it, I can type like this, done, and it prints it there. What's happening here is I have just, as soon as I encounter the number 4, I just quit the loop. So everything that's after 4, it's not being executed in the loop. If I change break to continue, notice what happens. So we have 0, 1, 2, 3, 4 is skipped, then we have 5, 6, 7, 8, 9. So what happens, it takes a look at the number, it's 4, and we continue. We say we don't want to print 4, we move ahead. So this is something that can be helpful. Let's say that you're trying to print something out of a list, and you don't want to print the name of people whose salary is less than, let's say, 40k. So what you can do, if person, let's say that for each x0 index is the x dot salary is less than 40, then continue. So this would have the same effect as it did earlier. This is what it means. So this is where we move on to the while loop. So let me just define a number, a is equals to 10, and instead of 4 we'll use a while loop. While a is not equal to 0, print a, and then a minus equals 1. So if I run this, it prints numbers from 10 to 1 in reverse order. So what do you think is happening here? So basically I have defined a variable named a, and I'm checking whether or not it's equal to 0. If it's not equal to 0, then perform this task. One thing that you need to make sure is if you're trying to check whether something is equal to something, and if it's not, then you need to manipulate it inside the loop. If I don't do this, then this will run forever. As you can see, it's going to keep printing on 10. I've interrupted it using Control C. I don't want it to run forever. So if I do this, then it understands how to do this. It'll take a look at the number. It's 10, print 10, and in decrement 1, it becomes 9. 9 is not equal to 0, print 9, go ahead, remove 1. 8, not equal to 0, print 8. 7, and this is how we go till 0. We print 1, then we in decrement 1 which becomes 0, and we take a look at this. So we go, okay, is 1 equal to, is 0 equals to 0? That is true. So this statement evaluates to false, which is not equal to 0. So what happening is we are printing the things until this statement becomes true. And when a becomes 0, this statement becomes false, and we move out. So as long as this evaluates to true, our loop is going to continue. Another way of reading is, while this is true, keep executing whatever we are executing. So that's a while loop. Now, why use while loop over for loop? There can be many scenarios where you want to use for loops. I like using for loops mainly when, as you can see, if I can travel back in time. Yeah. So mainly I like using for loops when I have a list of values, something that I can easily access in a loop like this. Doing this with while loop would be a little difficult. Let me show you how. So I would need to have an index, start it with 0, and check while index is not equal to the length of nums minus 1. That is one way to do it. Or you can check if while index is less than nums value minus 1. I will print nums, the value is at index, and I will index plus equals 1. If I run this again, it will do the same thing, but I had to write a lot more code, and I have to keep track of this index variable. Similarly, Python's for loop does all of this behind the scenes for us, so we don't have to manage these external variables and all that for us. There's advantages to this, but if you want to if you want to have access to the index variable, then you can use a while loop, or you can use a clever for loop as well. But for most scenarios, when you have a list of values that you can iterate over, using for loop is better. And when you have working with a specific condition, then using a while loop is better. So it's completely up to you. It's your choice. Whatever feels the right tool for you, you can use that. But I would certainly recommend using for loops for iterable statements.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry, and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Right, now let's take a look at functions in Python. So functions are one of the most fundamental things that you need to understand when you're learning any programming language. They allow you to encapsulate code and then reuse it in many other parts. We'll take a look at what that means and how you can accomplish things with functions. But the first thing that you need to understand is that it's a very, very, very important topic, and you need to get a really good grasp of how functions work before you can move ahead and discuss other things and learn other things in Python. So make sure that you pay attention and understand it thoroughly. So a function is a block of code that is organized in such a way that it's a reusable set of instructions and can be used to perform some related set of actions. So it's used to organize a reusable set of instructions that are used to perform some related actions. So we'll take a look at what that means. Basically, it means that we wrap up some piece of code that is entirely used to perform one thing, and that is then used, that wrapped up piece of code is then given a name, which is the name of the function, and then we use that name instead of copying and pasting the entire code. Again, we'll take a look at what that means and how to accomplish this. If you don't understand it as of now, don't worry. So there are two kinds of functions in Python. The first is a user-defined function, which is something that we create as developers, as programmers. And then there are some functions that are built into Python. So you don't have to create their implementation yourself. Python will have already done it for you. So the user-defined functions, as I've already told you, are created by users. This is what the syntax looks like. We use the def keyword. Def is a shorthand for define. We give the function name. We accept some arguments. These arguments are basically values or things that our function will perform some actions on. And then we do some calculations or any other kind of task that we wish to perform. And finally, and this is not a necessary statement, but if you want to return something, you can do that. Returning something basically means this would be the result of the function. Now sometimes your function may not have any result to perform, and if that's the case, then you don't return anything, you just omit the return statement completely. To give an example, there's a function right beneath it that says def add is the name of the function. We pass in two parameters, a and b. We create a sum which is equals to a plus b. So anything that we have a plus b, and we return the sum. Now, to be quite honest, this is a very trivial example, but to understand how functions work, we need to move our way up from really simple to complicated examples. Now there are many built-in functions as well. These functions have already been written by the developer of the Python language, and they have created these functions for us to use. So some of them are these. We have an abs function, which is used to store the absolute value of a number. So if you have a number that is in negative, that is negative 17.4, then if you use the abs function on that, you will get 17.4. Absolute basically means it converts negative to positive. Or in other terms, you can get an absolute value where you perform some mathematical operations on it. Then you get all, and returns true if all items in an iterable object are true. So if I have a list of a list, and everything inside that list is true, then it will return true. If any one of them is false, then it returns false. Then we have any, then we have ASCII, then we have bin, which is used to take a look at the binary version. We have bool, we have many other functions, min, max, whatsoever. So you can use them if you wish to. If you are trying to perform some task, make sure that there is a instead of writing your own function, make sure that there is a function available for you. Then there's Lambda functions. Now this is a concept that gets overlooked quite often, but Lambda functions are very powerful. So Lambda functions are basically anonymous functions that have no name, and it contains a single expression. A single line of code is there in a Lambda function. So these are used to pass some task that we want to perform in a function. Let me give you an example. So this is how Lambda functions can drastically improve the readability of a code. So let's say that I want to create a function in the way that I have done as of now. So I want to create a function called multiply. So I can do it using multiply, def multiply x comma y, and then I return x multiplied by y. But since you can see it's a very simple line of code, I can simply just do r will be the variable that will be pointing to the lambda. Lambda will accept x and y as parameters and will return x multiplied by y. Now to call the lambda, all I have to do is use the r, which is the name of the lambda, and I put parentheses in outside, and inside the parentheses I pass in the two statements. If I don't put a parenthesis, then it would simply be a variable that holds something. I'm not calling the function, I'm not executing the code that's inside it. So I pass into N3 and I get 36. Now another thing that Lambda does really well is that it allows you to remember some things. So let's say that I have created a function called def my function. I pass in a number named n. This number now will be remembered by the lambda that I have created inside that function forever. So if I return a lambda in which I will accept another parameter called a, and what it will do is it will take that number and add n to it. This way I can create multiple functions that do the same task but where the value of n is different. And this is very trivial example, by the way, very mundane, but you can think how far you can take it. There are many great Python programmers who use lambdas in very clever way. to write code that's very readable, quite simple, quite easy to understand once you understand what lambdas are, and it's quite comprehensive. Take a look at a function that's so simple to understand. So take a look at that as well. Now let's take a look at some functions, and we'll implement some functions in Python. Again, we have the same setup. Here we'll define a function. So let's say that I have some task that I want to perform. Okay, and it has several steps, and all of these steps will need to be performed regardless of where I execute the task. This example will also show you the importance of functions. So let's say that I want to download file. Okay, and URL. Now I'm not going to actually download the file, but I'll just print the steps. So establish connection. Then these are the typical connection steps you need to perform when you're trying to download a file from the internet. Open the connection, download data, close connection. So now if I want to download anything, any file, let me just print the URL. Or another thing I'd like to show you is that you can add strings or concatenate strings. So this way. So if I do this, then it will print establish space connection space and then add whatever URL is right at the end of it. Open connection, and let me print the URL, download data, and close connection. Alright, so if I were to call this function download file, and let's say that the URL is ftp:// www.abc.org. Now if I were to run this, let me just run this here, it's going to perform these tasks. But the major advantage of using a function is, now if I want to perform the same task over some other place, I can copy and paste it into different files and it will do the same thing over and over again. So if I were to print this, as you can see, it's done everything for me. Let's say that I want to change the URL df and if I run this, it's downloaded it for all different purposes. But now let's say that I want to change something in this step. After downloading it, I want to log it to some place. Let's say I want to make sure that this is recorded in a database, that I had downloaded this file. So log to db, and this is the URL I downloaded it from. Now if I run this, as you can see, this change, let me just so I've added 2 lines, so this is what it looks like. Now it looks a bit clear. Let me clear the screen and run this again so that you can see, and it's downloaded it. But as you can see that this step is now added to all 3 of the files. This is the advantage of using a function. So whenever you want to make a change to some particular step, some particular well-defined process, you can just make a change in one place, and everywhere that process is being performed, those changes will be reflected there. So if I had to add something else to the download file procedure, this will be executed by all the functions or all the files that are calling the download file function that I have just described. So that's one advantage. And now let's take a look at returning some data, right? So let's say x comma y. I get in 2 data and I perform some task. Now I want to return x multiplied by y. Let me call it, again, this is a very trivial example, multiply, right? And if I want to multiply 2 numbers, multiply x and y. Now x and y are going to be numbers, so let's say 15 and make 10 comma 15. Now if I were to run this, 150 would be the expected answer. If I were to run 25, 250 would be expected answer. So we have gotten both of them. But one thing to notice is that it's a really simple function. So defining it like this is going to take a lot of time and it's really unnecessary. So one way you can change it is you can write it like this. Let me just show you the code that was earlier there. And I am just going to change it to multiply equals to a lambda that will take in x and y and return x multiplied by y. Run this again and this is performing the same tasks that we had performed earlier, and it's printing the same thing that we had printed earlier. So there's no change in functionality, but we have changed the implementation. So what is the advantage? Now this function I can send as an argument to any other function. This is where it gets a little difficult to understand. So let's say that I want to print. Let's say that I want to. Oh yeah, one thing I can do is def create multiplier, and it will give me x and y will be given to me on the time of execution. So now what I can do, I can return a lambda that will take y as a function and it will return x multiplied by y. So let me just delete this. Now this works, and now I will create multiply, create multiply 10, and now I will just pass in 15 and 25. I run this and I get the same answer. Now as I've already told you that this is a function that you can pass into another function. Let's say I create another function named execute, takes in a function and takes in an argument, and all it does is that return calling that function with that argument. So execute 15 would be the other argument, and multiply and we want to execute. If I run this again, it's doing the same thing, but it's doing it for me. Now I can make changes to it. I can basically log the calls to a console called f with and okay, I've gotten an error. Yeah, I need to convert it to a string. Now it works. So it called f with 15 and it called f with 25. So I can log this to a database to make sure that it's being executed correctly and so on. Taking a look at what are data structures. So a data structure is a particular way of organizing and storing data in a system's memory so that it can be used efficiently for some purpose. A good example of this would be and arranging data is a very important aspect of any programming language. Some kind of arrangement of data might be better suited for one purpose than other purposes. To give you a more concrete example, if I were to give you a few numbers, let's say from 1 to 10, let's say I were to give you 10 numbers of any, I were to give you 10 numbers and those 10 numbers were given on a card. All of those cards were placed face down in front of you, and you had the option of arranging them in any way possible by looking at their value. Then I would ask you to check for a particular number to be existing in one of the cards. So if I were to say, okay, check whether 10 exists in one of those cards, what you could do is, if you had arranged them all in a linear fashion in a random order, you can just take a look at each card and see whether or not it contains the number 10. So that's easier for you to do for 10 numbers, but let's say that the scale increases and now you need to do that for 100 numbers, for 1000 numbers, for million numbers, and for even billion numbers. That is going to be really time consuming. On the other hand, if you had stored it in a different way, let's say that you had stored it in a way in which when you get the data, what you do is you first take one card, see if it is what the number of the card is, place it someplace, then take the other card and see whether or not it's smaller or larger than the card you had previously taken. If it's smaller, you put it on its left hand side a little below, and if the card is larger, then you put it on the right hand side, and you keep doing it again and again and again. This forms kind of a tree like structure in which a card is at the top, all the numbers smaller than the card is on the left hand side, all the numbers larger than the number on the top is on this right hand side, and this rule is followed for all the cards. So if you have many cards, this will be followed for all of them. Then I can come along and say, for the 10 million numbers that I have given you, tell me if the number 15 is in those. What you can do is take a look at the card right at the top. If the card at the top is larger than 15, which means 15 is smaller than the card at the top, you look at the left portion of the structure that we have created. On the other hand, if it's larger, then you look at the right portion, and you keep repeating the step. Each step is going to cut down half of the tree for you, so you don't have to worry about that. So this is what's called a tree data structure in essence, and this is specifically called a binary search tree. And the technique we're using inside it is called a binary search algorithm. Basically, if you have data that is sorted in a particular order, you have the ability to look at the data that's right in the middle of the deck, figure out what the number is. If the number you are looking for is smaller than the number, then you have to discard everything that comes after that card, the middle card that you have chosen. If it's larger than the number, then discard this and everything that comes before it. And you keep doing it again and again and again, and you will eventually get to the card that you choose in a very few number of steps. In fact, the number of steps is different from linear to logarithmic scale, so it's quite different. So this is one of the ways that storing data in a particular way can help you. Similarly, you can, if you wish to grade a few papers, you can store them in a stack that's easier for you to deal with. And if you're trying to manage a few people getting through and doing things in an orderly fashion, you can store them in a queue. Similar concepts are carried over to data structures as well. Right, let's take a look at what is a linked list. So a linked list is a linear data structure. Now, a linear data structure basically means that data inside this data structure is stored in a linear fashion. Linearity basically means that there is an order. One data point comes after the next data point, and that comes after the next data point. So this is how linear data structures work. The most common and famous example of a linear data structure is an array or a list in Python. If you have used other languages such as Java and C++, then you are using arrays, and those have linear data. Those are linear data structures as well. So each element or node in a linked list, and node is a term that we use to define a particular data point in our data structure, which is linked list. So node contains two things, or two pieces of information: the value that we want it to hold and a reference or a pointer to the next element. Now that pointer could point to the next element if there is one. If there is no next element, it points to none in Python. None basically refers to an absence of value. So this piece of information comes in handy, which we will take a look at when we're implementing the linked list. So as you can see that a linked list, we use node. Now node is one way to refer to what we are describing. You can use other terminologies such as elements or any other thing, but node is what the community has settled down on. That's the keyword here, and it uses reference or pointer for the next element. Now, the reason why we're using the word reference and pointer is because depending on the language, you call them different things. In Java and in Python, you use reference, which basically means you ask for the address of an object in memory and it will be given to you by the runtime environment. On the other hand, in languages where you get to manipulate the raw internal memory of a system, such as C++ and other languages, you can use pointers. Pointers also allow you to do arithmetic on the addresses, where you can add a few things and get the next address. But that's not possible in references. In any case, you can implement these data structures in any language that you desire. Whether it's Python, whether it's Java, whether it's C++, whether it's any other language, you can use them in all of those. Right? So let's take a look at the benefits of using linked list. So a linked list, using a linked list has several benefits. The first one is that it is dynamically sized. A dynamically sized linked list basically means that it is a list in which you can add as much data as you can, or as many nodes as you want to, as long as there is space in memory for you. Now, you might be wondering that that's also the case with arrays or lists in Python, and we'll get to that in a moment. But since lists are also dynamically sized, there is one tiny bit of problem with lists that we'll discuss later on. But the important aspect is that they are dynamically sized. Now, similar concept to list in Java and C++ and other statically typed languages is arrays. Arrays are not dynamically sized. They cannot be sized dynamically. They only have one type, and you cannot add more data to it after a certain point. You have to define the capacity of an array when you're declaring it and when you're instantiating it. In C++ and Java, if you have created an array that can hold 10 memory items, you can't add 11th one. That would be considered an illegal operation, and that would cause your program to crash. Just know what the error is and how you can use linked list to solve those errors. Arrays are not bad. They are used for specific purposes, and if you want to only store 10 memories, then using a linked list is just an overkill. So understand the problem and then use it. In any case, linked list can be dynamically sized. It allows for faster insertion operations. So let's compare it to other data structures such as arrays, as that's the only one we know right now. In an array, let's say we have 1,000,000 elements, and I want to add something right at the beginning of the array. Even though it might be dynamically sized, what I would have to do is firstly grow the size of the array. So from 1,000,000, it should now be able to store 101,000,001 element. Then I have to shift all the elements one place back. So the element that was at the millionth place now needs to go to the 1,000,001st place, and that way we need to shift all the elements available. And then all I have to do is rewrite the element that is the 0th index at the beginning. Similarly, if I had to do the same thing for any other place in my array, such as the 10th index, 15th index, 17th index, I would have to do the same kind of process. Just I would have to stop at the 10th index and not go till the end. Now that's useful, but as you can see, it's quite inefficient. I just want to add one element at the beginning. That's not what I want to do. So in linked list, you can do it quite easily. Since in linked list, all you have to do is just create a pointer, point its next pointer or reference, store the next reference to the beginning of the list, and point the pointer that's pointing at the beginning of the list to the current pointer. It might sound very typical, but don't worry, we'll take a look at that in the demo. So you don't have to worry about that. But that's the way it works. So this is why insertions are much faster in linked lists. This is why linked lists are preferred in situations where we have data that is being dynamically added. So we need to figure out where we want to add it. and how we can do that. Next, let's take a look at faster deletion. So again, it's the same problem. If I wish to delete 10 elements from my array at random points and I want to shrink the array, now I have to firstly remove one element, shrink the array from the back, then do the same thing again and again and again. That is also quite inefficient. In linked list, all I have to do is just make sure that there are no dangling pointers. That means that if I'm removing an array or I'm removing a node, I just want to make sure that the node that is occurring previous to the current node and the node that is occurring next to the next node are connected to each other. That's the only thing that I need to take care of. Other than that, we just have to remove the data. The rest all will be managed by either the garbage collector, or it's something that I would have to take care of on my own. Now, again, depending on how you are implementing these structures, you can implement them in several different ways, but it generally leads to a faster deletion time. Then comes memory utilization. Now, many data structures need contiguous blocks of memory. In linked list, you don't need continuous blocks of memory. So, for instance, if I want to store 10 million data points or 10 million nodes of linked list, I just need to find 10 million small patches of memory where I can store my linked list item, and the rest I can just point to the memory address of the next element in each of the node, and it will work just fine. On the other hand, the memory utilization is not going to be great in arrays, because in arrays we have a lot of we need to have contiguous blocks of memory. This is how arrays are implemented underneath the hood. This is also why we need to define a fixed size right at the beginning, because it's more efficient that way. So when we have an array and we want 10 million data points, what we need to do is we need to firstly find out a block of memory in which I can store 10 million data points, and assign that block of memory, that block of contiguous memory, to my program, so that it can add 10 million arrays, 10 million indexes inside my arrays, inside my memory. Now, that's easier for us to do, but it causes a lot of overhead for on our memory's part, because let's say that there are few patches of memory that can store 2 million, 4 million, and 4 million again. Now, for our memory to be able to be used by arrays, our computer or our operating system would have to defragment the memory, which basically means just rearrange the memory in such a way that all the empty space is patched at the bottom, so we can easily use this again. That takes a lot of time and could hang our computer and could lead to degradation in our computer's performance and speed. So let's take a look at how we can fix something like this. So we use linked list for that. But before that, let's take a look at lists versus linked lists. So what is the difference between a list and a linked list? A list is a Python programming construct. So when we're talking about list, we're talking about the native Python implementation of a list. And a linked list is going to be something that we will be implementing in a few moments' time. So in Python, we already have a built-in data structure named list, but it is a little different than linked list. So although it might seem that the internal implementation of Python's list might be the same as linked list, mainly because we are using dynamically sized linear data structures, there's some key differences. A list is stored as a contiguous block of memory, while a linked list is stored as a bunch of nodes scattered around memory connected to each other. So if you want to store some small pieces of data, then you can use lists. But if you are going to store a large bunch of data and you need to be able to dynamically size it and want to add and remove data continuously from it, then you can use, instead of using list, you can use linked list. Linked list is much more efficient for that purpose. You can use lists for that as well, but the memory consumption is going to be high and it's going to lead a degradation of performance. So it's up to you which one you use. You just need to understand how to use, or in which situation to use which one. Both these are tools. Understanding which tool to use when is going to be really going to be the key to building good software. So now let's take a look at the types of linked list. So there are many types of linked list. Since linked list is a very versatile language, we are going to mention only 3 of the most used types of linked list, but you can use other kinds of linked list as well. The first one is singly linked list. In a singly linked list, we only share a single reference to the next one. So basically what it means is that we have a data point that contains, or a node that contains some data and reference to the next element. If I go to the next element, I can't go back to the previous element. There is no dual connection. It's just a single line of traversal. So this is what a singly linked list is. Then comes doubly linked list. In a doubly linked list, we have both pointer to go from current to the next node and from the current to the previous node. So that way we can traverse both front and back in our data structure. So these are 2 different kinds of data structures. And then there's circular linked list, in which the last element of my node is going to point to the first element, so that we have a circular linked list. Instead of storing it in a linear fashion in which we have the beginning and the end, we have, instead of having a beginning and the end, we have a circular structure. Now all of these can be used for their own purposes. In singly linked list, we use data structures to implement a single data point. These are called nodes. The main important aspect that is different from singly and doubly is the memory usage. The memory usage of the doubly linked list is going to be significantly more because it's storing 3 pieces of information, not 2. Whereas in singly linked list, you're only going to be storing the data and the reference to the next element or next node. So that's the thing. Now, another thing is that they are used in different things. So singly linked list can be used in the back and forth feature. It can be used to develop stacks, which can be used to develop the forward and backward features in web browser. So when you visit a browser, then you go forward, then you go backward, then you go to another address, then you go backward, and then you go forward. All of this is implemented by singly linked list, and it's quite easy to do it with doubly linked list. In singly linked list, it's a little difficult, but it could be done if you do it using stacks. On the other hand, in doubly linked list, you can perform many different kinds of things as well. And circular linked list can be used for developing caches, something that is called LRU, or least recently used cache. And that's one of the most important implementations of circular linked list. So you can use it that way. And you can implement circular linked list using singly and doubly linked list, which basically means using single link or double links. Double links means something that points to both the current next node and the previous node as well. So you can use it that way as well. Now let's take a look at a demo of implementing linked list in Python. So as promised, I have a Jupyter notebook, and here I'm going to implement the linked list. So you don't have to worry about how I'm going to do it. Just follow along with the code. If you have Jupyter notebook with you, you can do it quite easily. So Jupyter notebook is not really necessary in this case. You can also write the code inside a simple Python file and then run it. I'm using Jupyter notebook because it's easier for me to show how things are being implemented. Since we need a node, the first thing I'm going to do is implement a node. So just create a class, call it node. That node class needs to have a constructor. In Python, a constructor is called an initializing method. Call it self. In the self method, inside the self, after the self keyword, I need some data and the next pointer, next, should be pointing to null. As you can see in Jupyter notebook, this is highlighted as green because next is a keyword in Python. In case you don't wish to use the next keyword, you can use something else, some other keyword that makes sense. I'm going to use it here. It doesn't really make much difference here, but you can use it for something else as well. and by default it's none. So if there is no other point that is given to us, it's going to be next. So now all I have to do is just give it some data, and also I can use the data to be none as well. So it just doesn't contain any data, and now self dot data is equals to data, and self dot next is equals to next, and that is done. So that's our node class. This is what is going to contain a single data point. If I run this, I don't see any error. If I were to create a new data, let's call it n1, and I don't do anything, press n1 dot data, run it, doesn't print anything. If I press n1 dot next, doesn't print anything. On the other hand, if I were to pass in 1, and if I were to print n1 dot data, it contains 1. And if I were to pass in as the next element a new node with the value of 2, this is 1, and 1 dot next would give me the address, and I want the data here, and that's no. And I can do the same thing again and again. So here after this I can do it node 3. This is what it looks like, and I can go to the next element, and it's this. So it's quite easy to use it that way, but we want to do it in a little more efficient manner. So all I can do is I can implement it using a linked list. Now inside the linked list, I don't need to inherit it from any other class. Here I am initializing it, and all I need is self. So self, and you can call it anything. Many people call it start, I call it head. So head is going to be the element that is pointing at the beginning of our list. If head is null, which means there is no beginning, that means our list is empty. And if your head is not none, that means that there is some element at the beginning. How many elements are there, that can only be determined by going through the entire list, but we know that there is something at the beginning. That's all we want to know. So with that, we have created the initializer or the constructor function. Now comes the meat of our application. Here we have to implement the insert function, or the insert method, since it's inside a class. First parameter is self, second parameter is data. Now comes the interesting aspect. So what we do is we create the new node here. So it contains the data, and the next pointer is going to be pointing to nothing. Now it is up to you how you want to implement it. What many people do is that they create two separate functions: insert front and insert back. Now this depends on how you want to implement it. I want to keep this simple, so I'm just going to call it insert. Insert front and insert back basically mean I want to insert some data at the beginning of my list, and insert back would mean insert some data at the end of my list. Depending on how you wish to implement it, both are valid reasons. Just understand why you want to implement it at the front or at the back. Now all I want to check is if, not if self dot head is not none. Now I could simply just do this, if self dot head. That would lead to the same thing, but I want to be more explicit here. So basically means if there is some value in the head, the head is pointing to, that means our list is initialized and there are some elements already there, and I want to put it at the end. All I have to do is I have to current is equals to self dot head while current dot next is not none. So all I'm checking is, so I'm going to go to the next element till I don't reach the end. So right at the beginning of the end, which I'll show you, current is equals to current dot next. What I'm doing is, let's say that I have a list in which I have one that point to 2, that point to 3. Let me just make it a little easier to read. Now what happens is I take a look at the head. Head is going to be pointing to 1. From here I take a look at the head and I understand that there are elements here. So I assign this to current, which is here, and then I keep checking, does it have any next element? It does. So I go to the next point, which is here, current is equal to current dot next. Then I check, is there some element after it? There is. So I go there. Then I check if there's some element after it. There is not. So current is currently pointing to the end of the list, right? So after reaching there, all I want to do is current dot next is equals to new node. So let's say the new node is 4. Now current dot next is going to be equal to 4. In actuality, it's going to be pointing to none here. So I'm checking if the next element is not none, then move ahead. It is none, so I'm going to go to 4, and its next element is none. And now we're done. So this is how this is working. We have inserted an element when there is no element present inside our, when there is some element present inside our list. But what if there is no element? Well, then we can just basically do it this way. Self dot head is equals to new node, and we're done. I'll have to add an else clause here, and we're done. So we have created the insert function. Now insertion is fine, but what if you want to print the list? That is where we come here. So def print list, and I don't need any argument other than self current is equals to self dot head, and while current is not none, all I have to do is print current dot data. Okay, so this is done. Now all I have to do here is create a linked list, which I can call it anything. I'll call it list, or for simplicity's sake, I'll just call it L. Linked list. I have created an object of linked list, which means this code ran completely, this portion of it. Now I have to insert some data here. So L dot insert 1, that works. 2, that works. 3, that works as well. So as you can see, I didn't have to define a particular size. The size is being automatically generated for me. It's automatically being increased in its size. Now, if I print the list, as you can see that it is going on uninterrupted, right? That's a problem. So let me just call cell dot, and this is a problem that we're going to see in a moment. Restart and clear output is going to be the one. This is also one of the reasons why I chose Jupyter Notebook. And now let's take a look at why this failed. And the reason is quite simple, because we have not moved ahead in our list. What happened is, after we print the data, we want current is equals to current dot next. This is a mistake that many of us make many times. What's happening is printing the current data, and we're going to the next value, and we're checking, okay, now am I pointing to nothing? If not, then that means there is some data left to be displayed. So I'll just rerun it again from the start. Linked list, insert, and print. And as you can see, it's being printed correctly. Now if I want to print it entirely on one line, I can just, and now it's done. So this is what it looks like. As you can see, it's not really difficult to implement. It's basically 15 lines of code, creating, insertion, and printing. You can also delete the nodes. There's many different articles and different ways of doing it. And now I'd like to show you how you can implement a doubly linked list. So we'll implement it from scratch again so that it gets settled in your memory. To implementing a doubly linked list, you have to implement it the same way you implemented singly linked list. Firstly, you have to create a node that's going to be a little different from the singly linked list node, and I'll show you why. Hopefully you remember why, but let me just show you anyway. So we need self, then we need data, which could be none. Then we need the next pointer, which is by default none. And then finally, we need a previous pointer, which is going to be equal to none as well. And this is the crucial bit of difference. We didn't have this earlier. So now all I have to do is just self dot data is equals to data, and do the same thing here. Self dot next, and self dot previous is equals to previous. Then this is working. Now let's just check if it's working correctly before moving ahead. Node data is 1. Okay, so I print n dot data. This is what it prints. Now I want something to be before and after this, right? So I can just do it this way. Node 1, node 2 is going to be this. Or we can do it this way. We can create 3 nodes. 2 and 3. N1, N2, and N3. So N1 dot next is going to be N2. So right now what we have done is this. We have created 3 nodes. N1, which is 1, which is pointing to 1. N2, which is pointing to 2. And N3, which is pointing to 3. Now what we want to do is, we want to convert it to this. N3 plus N2 should also be pointing backwards, and N3 should also be pointing backwards. This is the whole reason why we do doubly linked list. So N1 should have a reference to the N2. N2 dot previous should have a reference to N1. So this could be done. Then N2 next should be N3, and N3 dot previous is equals to N2. If I do this, now if I were to print N1 dot data, prints 1. If I were to print N1 dot next dot data, I have an invalid syntax error here. N3. Now if I were to do it, if I want to go a step back, I can just do previous, it should print 2. And again, I try to go previous, it should print 1. That's how that looks like. Now if I were to do this, here's if I want to implement it in a doubly linked list, all I have to do is type class doubly linked list, def init, we pass in self, and that's about it what we need to pass in. The implementation is going to be quite similar. It's just going to be one piece of difference, which I will highlight. By default, it's not pointing to anything, so it is working. Def insert. To insert something, what we need is the reference to self and some data. So all we have to do, if self.head is not none, which means that there is some value in self.head, then all we have to do is, firstly we have to create a new node as we had done earlier with the data. And now if there are some values, first we have to get to the end of the data. So current is equals to self.head, while current dot next is not none, current is equals to current dot next, and we keep doing that. Once we reach till the end, we make current dot next to be equal to new node, and now comes the new bit. New node dot previous is equals to current. So what happens is, let me just visualize it for you. As we had done earlier, let me just use this. So we have the first node, which is head. It is pointing to 1, let's say, which is pointing to 2, which is also pointing backwards, right? And now we are here. The next of 2 is pointing to none thus far. We create a new element, which is 3. So we go here, we remove it with 3, and we create the previous pointer to be pointing to 2. This is what we're doing, right? So it's easy to understand, and this is, we can do it very easily. But if there is no element, then basically all we have to do is self.head equals to new node. Quite simply the same code that we had earlier. And similarly, all we have to do is call the print list function, pass in self, while, and also we can current is equals to self.head, and just check if current is not none. We print current.data, and we go to current's next pointer. Run this. We have run into an error, which is if self.head is not none. We are running into an error in line number 7. So it's here. Let's see what is the issue. Is not none, not in, not none. That is the issue. So now we have come up with the issue. Now let's create a new node. Let's call it L again, and I'll call it W linked list. Don't need to pass anything. L dot insert 1. Now we want to insert 2. Now we want to insert 3. And now all I have to do is go through the entire thing as we had done earlier. So L dot head dot data, L dot head dot next dot data, L dot head dot next dot previous. So we go one step forward and then one step backwards. Should print 1, which it does. Next dot data 3, previous dot data, and should 2. So as you can see, we have a way to move forward as well as backwards here as well. So that's what W linked list is. You can do other things as well. Deleting items here is going to be a little tricky, so just make sure that you have access to the previous and the next nodes, and that way you can take the previous node's next pointer pointed to the current element's next node, and the next element's previous node should be pointed to current element's previous node, and then you can just remove the data that you have. It's very easy to do, quite easy to do in many ways. So we're done here.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So what are these operators? Well, these are some specific characters which have a specific task to perform. And based on the function and the task, the operators are further segregated into 7 different types of operators. Arithmetic operator, assignment operator, comparison operator, logical operator, bitwise, identity, and membership operator. Fine. So let me discuss them one by one. So starting with arithmetic operator. Well, arithmetic operators are the one which is used to perform some arithmetic calculation. So what it does, it takes 2 operand to perform operation on them. For example, 2 plus 3. So here 2 and 3 are operand and the character plus over here is nothing but arithmetic operator. Alright. So there are other arithmetic operators too, like plus, minus, multiplication, division, mod. All these characters are a part of arithmetic operator. Let me just show you one more example. Like 1 plus 2. So here 1 and 2 are the operand and plus here is a arithmetic operator. 1 minus 2. Again minus is a arithmetic operator. 2 mod 1. Mod is what? Arithmetic operator. Alright, let's move ahead. Next we have is the assignment operator. Well, this assignment operator is used to assign a value to a variable. The character which comes under this operator are equal to, plus equal to, minus equal to, multiplication equal to, and etc. For example, you declare a variable as var equal 10. So this equal to is your assignment operator and is used to assign value to a variable. Let's get back to our Jupyter notebook and learn more about it. So, for example, I'm defining a variable var equal 10. So this equal to is nothing but a assignment operator. Var plus equal 10, again an assignment operator. But what does this mean? So what does this mean? Well, it means that var equal var plus 10. Alright. So if you print the value of var, what do you think the output should be? Well, you'll get the output as 20. Since the value of var is already 10, so 10 plus 10, it's 20. So the updated value of var is 20. Similarly, you can perform var minus equal to 10 and again get your value printed. So again the updated value of var would be 20 minus 10, 10. So this plus equal to or minus equal to, it is generally named as a shorthand, which means add or subtract and assign value to self. Alright. Same example is mentioned over here, like a equal 10, a multiply equal to 10. So it means that a equal 10 into 10. When you print a, you'll get the output as 100. Alright. So next we have is comparison operator. Well, it is used to compare two values and it returns true or false as the output. Alright. The operators which are a part of it are less than, greater than, less than equal to, greater than equal to, or not equal to. For example, let's see what example we have up here. A equal 10, B equal 20. A is greater than B. Obviously 10 is not greater than 20, right? So it is giving me false as the output. Alright, fine. So let's move ahead. Next is the logical operator. Well, these logical operators are used to perform some logical calculation. And the operators or the keywords which are a part of it are and, or, and not. For example, we have a equal 10 is less than 10 and 2 is greater than minus 1. Then print a. So you are getting output as false. Okay, let's jump back to our Jupyter notebook and see why we are getting the output as false. So you had a equal 10 is less than 10 and 2 is greater than minus 1. So if you see, we have two comparison operator up here. So what is the value of 10 less than 10? Since it is a comparison operator, so it will give me a false, right? 10 is not less than 10. And 2 is greater than minus 1. This is true. So you can summarize this as false and true. Alright. So since it's false and true, therefore it equals to false. Well, how? Well, do you remember the binary calculation that you have learned in your college? It's like 1.1 equal 1 or 1.0 equals 0 or 1 and 1 equal 1 or 1 and 0 is 0. So consider true as 1 and false as 0. So false and true is false. Alright, that's why you got the result as false. Now if you print the value of a, you'll get the output as false. Alright, so next we have is the bitwise operator. So this operator is used to perform the bitwise calculation. This operator includes and, or, left shift, right shift, not. Alright, so let's see their use one by one. Let's see the example what we have up here. So we have 7 or 5, the output is 7. 7 and 5, the output is 5. So how do you think we are getting this output? Let's see the calculation. So how it is calculated. So if you convert 7 into its binary form, it's 111. And if you convert 5 into its binary form, it's 101. Now if you are performing OR, so basically you are performing a binary addition on it. And if you are performing an AND, you are performing a binary multiplication on it. Alright, so let's see. So if you are performing a binary addition on it, so 1 plus 1 is 1. 1 plus 0 is again 1. And again 1 plus 1 is 1. So that's why you are getting the OR of 7 and 5 as 7. Even you can verify this using the calculator. Open a calculator. Yeah, it's a programmer calculator. So 7 or 5. So you'll get the output as 7. So it's correct. Fine. Next operator that we have got up here is tilde operator or the not operator. Well, this operator is used to perform a not operation. So what is not of 7? What is not of 7? It's minus 8, right? How it is minus 8? Let me just show you using a notepad. Let's open notepad. Okay. So 7 in its binary form with 4 bits, what it is? 0, 1, 1, 1. Alright, if you perform a not of 7, that is not of 7, what you will get? All the bits would be switched. Like 0 would be converted to 1, again 1 to 0, again 1 to 0. So you'll get 1000 and automatically a negative sign would be added at the beginning. So you'll get minus 1000 in binary form, which you convert into decimal, you'll get it as minus of 8. Alright, that's why the output of not of 7 is minus 8. Fine. Next is the left shift and right shift operator. Let's see what is the output first. For example, I'm trying for a right shift. Then 10 right shift 2. What is the output? It's 2. Let's see how we got the output as 2. Open our notepad. Let's remove this. So 10 in its binary form, what it is? It's 1010. Alright. Well, when you're performing the right shift, you're telling the interpreter that you want to shift your bits toward right. And how many bits you want to shift is basically 2, since you have mentioned 10 right shift 2. Alright. So 1 0 1 0 shifted 2 bits to the right, 0 0, and remove 1 0 from the end. Alright. So this is how you are shifting 2 bits towards the right. So you got the result as 0 0 1 0. So now if you convert this into decimal form, you'll get the output as 2. Fine. So it's like you're trying to push 2 bits from the left towards the right. Is it clear? Alright, fine. Let's move ahead. Next we have is 10 left shift 2. What is the output? It's 40. Let's see how we got that output. Again, 10 in its binary form is 1010. So when you are performing a left shift, it's like pushing the bits from right towards the left. So 10 left shift 2 is like 1010, and you are adding 2 bits in the end, since you are shifting 2 bits to the left. So you are getting 101000. So let's convert this into its decimal form. So 101000 in its decimal form is what? 40. So that is why you're getting the result as 40. So there's a shortcut trick. Well, the shortcut trick is that just add zeros equal to the number of bits that you want to shift towards the left. Alright. For example, I want to perform 10 left shift 3. So my output should be 101 000 and one more 0. Alright. Since I'm moving 3 zeros. Alright. Since I'm moving 3 zeros towards the left. So let's convert it. So it's 80. So you are getting the output as 80. Let's verify it again. Well, if you perform 10 left shift 3, you'll get the output as 80. Fine. Well, I hope the bitwise operator is clear to you guys. Well, in case you have slightest doubt, please add your doubt to the comment section below and we'll try to reply them at the earliest. For now, we can just move ahead to the identity operator. Well, these operators are used to test if two operands shares an identity. The operators which are a part of it are is and is not. These are basically two keywords. Alright? For example, what we have up here, x equal 10, x is 10, it's true. Or x equal 10, x is not 10, it's false. Alright? It is just used to test if the operand shares an identity or not. Alright? So next and the final operator in Python is the membership operator. Well, this operator is used to test whether a value is a member of a sequence or not. The sequence may be a list, it can be a string, or it can be a tuple. I know some of you guys might be thinking, what is this list or what is this tuple? And guys, I'd say that just be patient. I'll teach you about them in detail during this session. For now, you can just understand that this list is almost same as array, which you had already studied in C, C++ or Java. It's almost same as that. Alright? And this membership operator, it is used when you want to check if a certain element is present in a list or not. So let's see what are the operators which are a part of it. So well, we have in and not in keywords which are a part of this membership operator. Alright, let's see an example. So what's the example up here? So we have defined a list, or you can say we have defined an array, which consists of dog, cat and wolf. So we are checking for lion and pets. Since pet is the name of a list or an array, you can say. So we are searching for lion and pet. So since there is no lion in it, so the result is false. Next, what we are doing, we are seeing for wolf and pets. So yeah, wolf is present in pet. So we are getting output as true. Alright. So this was all about the Python token. So moving on ahead, we'll learn about data type in Python. Well, Python has majorly two data types, immutable data type and mutable data type. Immutable are the one which cannot be changed or modified, and mutables are the one which can be changed. Alright? Immutable data type consists of numbers, strings, and tuples. On the other hand, mutable data type, they consist of lists, dictionaries, and sets. Alright? So let's discuss about them one by one, starting with numbers. So under the topic of numeric literal, I have already discussed that Python has 4 different types of numeric literals: integer, long integer, floating number, and complex number. Well, I have also told you that you don't need to specify the data type of a variable while you are declaring it. Remember, Python would automatically convert a number from one type to another if it needs. Fine. Don't worry if you want to explicitly convert one data type to another. You can do it using int function, long function, float function, or complex function. Alright, you have that option available with you. For now, let's just move ahead and see how we can find the data type of a variable. Let's see. Suppose I'm declaring an integer variable a equal 10. Let's define a name. As Jill. Now what if I want to check the data type of these variables? So how can I do that? So for that we have type function. So print the type of variable A. Alright? Or print the type of variable name. Or print the type of variable salary. Fine? Execute it. Sorry, there's a typo. It's type. Alright. So you can see that variable A is of type integer, variable name is of type string, and variable salary is of type float. Fine. Alright. Let's get back to our tutorial. So this was about the numbers. Next is strings. Well, anything which is written under the single or double quotes is treated as a string. Alright, let's perform some operations on string and understand them in detail. Suppose I have first string as hello world, and my second string is Intellipaat. Alright. Now what if I want to print first character from the string 1 and the last character from string 2? So how will I do that? Let's see. So what you can do, print str1 and I need the first character. So my first character is at index number 0. I'll just mention str1 of 0. And I want the last character from string 2, right? So print str2. So if you want the last character, just specify -1. Execute it. So you got the output as capital H and small t. Since capital H is the first character from string 1 and small t is the last character from string 2. Alright. So now what if I need to extract hello from hello world? So how will I do that? What I need to do? Extract hello from hello world. So all you need to do is print from which string? String 1. Hello starting from 0 and it should end till 0, 1, 2, 3, 4. It should end till 5. Alright. And execute it. So you'll get the output as hello. Fine. This is how you can collect the substring from a string. One thing to remember is that if you check the index number of hello, so it would end at 0, 1, 2, 3, 4, 4, right? So when you want a substring, so you have to mention it as +1. So 4 + 1 is 5. So 0 till 5. It won't include the fifth position. Generally, if you are extracting a substring, the last number which you are including, that thing is not included. It means that everything which would be between 0 and less than 5 would come as the substring. Alright, let's perform some operations on it. So first we have is the find function. So what are these find function? Well, this find function returns the position of the string. Let's take an example. For example, I have a string as str equal attachment. And what I need to do, I want to find the position of the substring me from it. So str.find, and inside that just mention what you want to find. Like I want to find the position of me. Let's execute it. So you got the output as 6. Why? Since me starts from 6. 0, 1, 2, 3, 4, 5 and it's on 6th position. So that's why you got the position as 6. Next is replace. Well, this replace function is used to replace one character or string with other. Fine. It's like, what if I want to replace this me with m? So str dot replace. What I want to replace? First mention that I want to replace me with what I want to replace. It's m. Fine. Execute it. So you got the output as attachment. attachment. Fine. me is replaced with m. One more thing that you can do up here is, let me just show you. You can convert the word attachment into attach. Let's see how. Attach dot replace. So what you need to replace from here is ment. You don't want ment from here. So what should you replace it with? You can replace it with space. That's it. If you execute it, you'll get the word attach. What if I don't mention the space up here? So you'll get the output as attach. Even that work. Alright? Fine. Next we have is the split function. Well, this function is used to create split on the basis of a character. For example, I have a split string which consists of word 1, comma, word 2, comma, word 3. So all these 3 different words are separated by comma. So what I want to do, I want to split the entire string on the basis of comma. So I'll write split str dot split on the basis of comma and execute it. So as you can see, I got the output as 3 different words. Word 1, word 2 and word 3. Let's move ahead. Next is the count function. Well, count function returns the count of the character in the string. For example, let's take a string as str3 equals Intellipaat. Now I want to find the count of letter I from this particular string. So str3 dot count, I'll mention I. Let's execute it. So what do you think the output should be? INTELLIPAAT. So do you think it should be 2? Well, according to me, it will be 1. I'll tell you why. See, the output is 1 because well, remember I told you Python is case sensitive. So both the uppercase and lower cases are treated differently. So if I'm searching for small I, that small I is just appearing once. So I got the count of small I as 1. Now, what if I convert this string to uppercase? Dot upper. Let's convert it to uppercase. Okay, that's it. str3 dot upper. So it gave me Intellipaat. Let's store it in some variable like str4 equal str3 dot upper. Fine. Now if you count the number of i's in str4, you'll get the output as 2. Why? since in capital Intellipaat you have two eyes. Alright? Fine. So we discussed about the upper, which converts the character string to the uppercase. Fine. Next is the max or min function. Well, these functions are used to return the max or min ASCII values. For example, let's take a string 5 as anything. For example, exclamation mark, @ #123, capital A, small b, small a, c, capital C. Alright. So this is my string 5. Now I want to find the maximum ASCII value from it. So what I'll do, I'll just write max str5. Execute it. I must to mention this. Put it under the quotes. Execute it. So the character with maximum ASCII value is small c. Alright? Or what if I want to find the minimum ASCII value from string 5? Let's check for that. So minimum ASCII value in string 5 is of exclamation mark. Fine. So let's move ahead. So next we have is the tuple. Tuple are a group of values within the parentheses, and since they are immutable data type, so the values within the tuples cannot be changed. For example, we have defined a tuple up here as my group equal A, B, C and D. Alright. So this is the example of a tuple. So let's move ahead and perform some operations on it to understand it in detail. Let's get back to our Jupyter notebook. Let's define a tuple as my tuple equal within the parentheses. I'll mention A, then B, then C and D. Alright, so this is my tuple. So the very first function that we are going to perform on it is concatenation. So what are these concatenation? It is used to add two strings or character. Alright. Basically, concatenation is used to add two or more tuples. Alright. For example, I'll define another tuple as my tuple 1 equal E and F. So if I need to concatenate it, I'll just write my tuple plus equal my tuple 1. And let's print it. Print my tuple. Let's see the output. You got an error as invalid syntax. What is the invalid syntax up here? Something is invalid, yeah. Let's define it again. Okay, this semicolon is missing up here. Fine. Execute it. So yeah. So this concatenated me and gave me the result as A, B, C, D, E and F. So this is how concatenation is done in tuple. Concatenation. Next we have is the repetition. Repetition is used to duplicate the string or character for a given number of times. For example, what if I want to double the contents in my tuple? So I'll just write my tuple multiplied by 2. And again, that's it. My tuple multiplied by 2 and hit enter. So you'll get the output as double values of A, B, C, D, E and F. Fine. So this is how a repetition is done in a tuple. So let's move ahead. Next function that we need to perform is indexing. Indexing shows the index position of a character or a string within the group or within the tuple. For example, I want to find what character is present at the index number 1. So I'll just write my tuple of 1. So at first index, B is present over there. It's like A is present as 0th index, B at 1, C at 2, D at 3 and so on. Fine. So this is how indexing is done in tuple. Next is slicing. Slicing shows a specific set of index character or string. Fine. For example, I want a specific set of strings which lies between the index number 1 to 4. So my tuple, I want a specific set of string which lies between 1 to 4. So this is my 0th, 1, 2, 3 and 4. Fine. So I'll get the output as B, C, D and E. Let's check it. So I got the output as B, C, D and E. Fine. Alright. So let's move ahead. So next we have is the list. List is a sequence of mutable Python data type which is defined within the square brackets. And now since they are mutable, they can be easily changed. Let's move ahead and perform some operations on it and understand it in detail. So what is an example? Okay. So we define a list as A, 10, 7.12 and data. So it is consisting of mixed data type values. It even has an integer, a float and a string. Fine. Let's get back to our notebook and define a list. So this is my list. My list equal within parentheses a string, a number, a decimal, and a string with multiple character. Fine. So this is my list. Now let's see what are the operations that we need to perform on it. First is concatenation. Well, again the concatenation is same as the one which we learned in tuple. It is used to add two or more lists together. Let's define another list as my list 2. My list 2 consists of element as, let's take Python, or it consists of an integer. Now what if I want to concatenate my list with my list 2? So what I'll do, my list plus equal my list 2. Let's see what is the result. Let's print the value of my list. So you got the result as A123 3.14 John Python 20 Python 20. So you got this result 2 times because yeah, I executed it twice. It's my fault. So what you can do, you can just mylist dot remove. Hold on. I don't want to execute this entire list or statement, so I'll define it under different block. So my list dot remove remove Python. Okay, I have misspelled Python as okay. Remove this. Again, remove this. And remove 20 and again remove 20. If you again remove it, you'll get an error. Fine. So let's see what we have currently in my list. Let's print it. Okay. Let's get back up here and execute it just once. Okay. So as you can see, my list got updated with Python and 20. Fine. Next is repetition. Well, repetition is again same as tuple. It is used to duplicate your list with n number of times. Well, next is repetition. It is used to multiply your list by n number of times. For example, my list into 2 would duplicate your list with each element appearing twice in the list. Alright? Fine. Next is slicing. Again, same as tuple, if you want a specific portion of a list, we can just mention the starting index number and the ending index number plus 1, and it would return us the sliced list. Alright. For example, as you can see here on the screen, we have my list, and inside that we have A1, 3.14 and Python. And we want a sublist from 1 to 4th index number, like 1, 2, 3, 0, 1, 2, 3, plus 1. 4th won't be included, so we'll get the output as 1, 3.4 and 3.14 and Python. Alright. Next is append. Well, appending is adding any value to a list. It's almost same as the function what we did up here. Right, it's like my list dot append and add any values with which you want to append. Like I want to append with 10 and print my list. That's it. So as you can see, we got 10 in the end. Fine. So moving on ahead, next we have is extend. Well, again, extend is another function which is used to concatenate two different strings. Alright. For example, I'll define my list 3 as C and D, and I want to append my list with my list 3. Let's print and see what result do we get. So as you can see up here, C and D got added with my list. Fine. Well, next is insert. Well, using the index number, you can specify any value in between the list. For example, I want to insert a number before 3.14. So I'll write my list dot insert. I'll mention the index number. My index number is 0, 1. I want it after 1. And what value I want. For example, I want to insert a 20, 30. Alright. Let's print my list and see what is the result. You cannot use a string up here. You just have to mention the number, index number. So yeah, you got my list at first position. So what if I want to insert it before 3.14? That was my target, right? Now your updated string is this 0, 1, 2, 3. So you want to insert it at third position and you want to insert 40. So at third position, that is 0, 1, 2, 3. So after 1, 2, 3, 40 would come. So after 1, 2, 3, 40 is up here. Alright. So this is how you can insert any number at a given index number. So this was all about list. I hope you understood the difference between a list and a tuple. If not, let me just summarize it again. A tuple is immutable while a list is mutable. Open and close brackets are used when you're grouping items under it. And in the case of list, square brackets are used. Fine. So this was all about the list. So let's move ahead and discuss about dictionaries. Well, these are more flexible data type in Python. And you define a group within the curly braces. Fine. While defining the elements in a dictionary, you have two elements, key and its value. Fine. Or in other words, we can say that we define an index for each element. Let's explore various operations that we can perform using dictionary. So first one is defining an empty dictionary. Don't mention anything within the curly braces. That would be an empty dictionary. Alright. Next is integer keys. That is dictionary with integer keys. For example, 1 apple, 2 ball. So the key 1 and 2 are just integer, right? So it's a dictionary with integer keys. Next is mixed keys. Dictionary with mixed keys. That is, we have key of mixed data type. For example, name is string up here, 1 is integer, right? So this is mixed key. Next we have is pairing. That is from sequence having each item as a pair. Dictionary, 1 apple, 2 ball, all are taken as a pair element. Fine. Next is accessing dictionary. So what if I want to access a dictionary? So I can directly access using the key. Fine. For example, the word 1 is associated with key 1 and word 2 is associated with key 2. So if I want to access word 1, I can directly write my dictionary of 1 and it will give me output as word 1. Fine. Let's move ahead. Now what if I want to find the length of the dictionary? Then I can directly do it using the len function. Len of my dictionary is giving me the output as 2. Why? Since it consists of two elements, word 1 and word 2. Fine. Next is key. Now what if I want to find the key of my dictionary? So I can just use the key function. My dictionary.key. It is returning me all the keys within the dictionary. Fine. It is returning me all the key defined within the dictionary. Next is value. Well, this function is used to return all the values defined within the dictionary. For example, we have apple and ball as value within this dictionary, mydict. Alright, so that's why using value function, we got the output as apple and ball. Fine. Let's move ahead. Okay, so now that you have learned about dictionary, so let's discuss about the last data type, that is set. Sets are the unordered collection of items within the curly braces. That is, items are defined within the opening and the closing curly braces. And you don't have to define the key value in it. It is basically unordered collection of items. If you are adding elements in the set, then make sure that every element in the set is unique. For example, you can define a set as my set equal 1 to 3. Well, it's almost similar to as dictionary, right? But it does not has any key value associated to it. It's the only difference between a set and a dictionary. Alright? Let's perform some of the function using set and understand it in a better way. So the first one is creating set. You already created a set. Alright. Next is union. Well, union of two sets return the common value from both the set. For example, my set S1 equal 1, 2 and C. My set S2 consists of 1, B and C. So if I am performing a union on it, So it is returning me with 1, 2, C and B. So basically what it is doing, it is returning me the common values of both the set. Fine. Next is the intersection. Well, intersection is used to return the common result from both of them. That is AND of my set S1 and my set S2. So what are the common elements in both of them? We have 1, 2C, 1BC. So we have 1 and C common in both the set. So we got the output as 1 and C. Fine. Next is the difference. Well, this difference would omit all the common value from both the set, and it will return the only value which is a unique in first set. For example, we have 1, 2C in set 1 and 1BC in set 2. So if you subtract it, so you have 1 in both the set, so it will emit it. 2 and B, so nothing can be done about it. C and C, again it will emit it. Now since only 2 is left in set 1, so you get the output as 2. Alright? Fine.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers. We rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So this was all about the data type in Python. So now that your base is clear, let's have a quiz. So what would be the output of the following code? Test1 equal Python programming and print test1 from 2 to 6. In order to know the correct result, do post your answer in the comment section below. Alright, so let's move ahead. Next is the Python flow control. Well, these flow controls are the one which control the flow of execution of your program. So we have 6 different types of flow control in Python: if else, nested if else, for, while, break, and continue. Let's discuss them one by one, starting with if else. So what is this if else? Let's see its syntax. If the condition is true, then execute statement 1, else execute statement 2. It's as simple as that. Let's see the flow of execution. You start it, you check the condition. If the condition is true, then execute block 1. If the condition is false, then go to the else part and execute block 2. Fine. Yeah, this block 1, it comes under if part. Alright. Let's move next. Let's move ahead. Next is nested if else. Let's see the syntax. If condition 1 is true, then execute statement 1. Else, if condition 2 is true, then execute statement 2. If none of them is true, then execute statement 3. Let's check the flow control of it. Start, check for condition 1. That is, if condition 1 is true. So if condition 1 is true, then the statement executed with the if block is executed. That is, execute block 1. If first condition is false, then go and check for the second condition, that is else if condition. Now if else if condition is true, then your second block would be executed. If none of them are true, then finally the else block would be executed. That is execute block 3. And yeah, remember one thing, there is no condition associated with the else block. Else block would only execute if all the above conditions are false. Fine? Alright. Next is the for. Let's see the syntax. For iterating variable in sequence, colon execute statement. Let's check. Well, it's the example of a program. Like start, we are defining a variable as count equals 0. Then execute statement. Then increment the value of count by 1. And then check the condition if count is less than 10. Is 1 less than 10? Yeah, the condition is true. So again repeat it and again execute the statement. Again increment the value of count by 1. That is count become 2. And again check if 2 is less than 3. And so on, continue this till 10 is less than 10. And when this thing arrives that 10 is less than 10, your condition become false and you exit the loop. So this is how a for loop works. Let's understand this in a better way with an example. So this is our code. Alright, we have defined a list fruits as apple, banana and cherry. For x in fruits, x in fruit of 0 is apple. Then print x. X is what? Apple. So apple would be printed as the output. Now again, what we'll do? We'll again go back and check for x in fruits. Now x of 1 is banana. Then print x. X is what? Banana. So it would print as banana. Again, it will go back. X in fruit of 2 is what? Cherry. Print x. Cherry would be printed. Now if it goes back, there's nothing left in the fruit. So nothing would be printed. Alright. So you got the final output as apple, banana and cherry. Fine. Alright. So let's move ahead. Next is the while. The syntax for this is while condition is true, then execute set of statement under the while. Start, check for the condition. If it is true, then execute block 1 and then again repeat the loop until the condition is true. In case the condition is false, then just exit the loop. Let's understand this better with an example. This is my code. Like a equal 1. In variable part I got a equal 1. While a is less than 5. Is a equal 1 less than 5? Yeah, condition is true. Then what? Print the value of a. Alright, so we got the output as 1. After getting the output, increase the value of a by 2. So a plus equal to 2. That is 1 plus 2 equal 3. Now again go back to the loop. Check for the condition. Is 3 less than 5? Condition is true. Then again go to the print a part. What is a? 3. So print a. So you will get the output as 3. Again increment the value of a to 2. That is a equal 5. Now check the condition. Is 5 less than 5? No. I think here we got the condition as false. So we got the final output as 1 and 3. Alright. Let's move ahead. Here's another example. A equal 1. In the variable part a equal 1. Check the condition. While a is less than 3. Is 1 less than 3? Yeah, condition is true. Inside the while part, the first condition that we check, if a mod 2 equal 0. Is 1 mod 2 equal 0? No, the condition is false. So we'll jump to the else part. So we'll jump to the else part and print a is odd. Now since the value of a currently is 1, so 1 is odd. Fine. Then what we'll do, we'll increment the value of a by 1. That is 1 plus 1 equal 2. Fine. Now again we'll go back to the while part. Now we'll check if 2 is less than 3. Yeah, the condition is true. Fine. Now what we'll do, we'll jump to the if part and check if 2 mod 2 equal 0. Yeah, the condition is true. So this time we'll check if 2 mod 2 equal 0. So yeah, the condition is true. So what it will do, it will print the if part statement. That is a is even. A in this case was 2. So 2 is even. Fine. So this is our output. Next, again it will go and increment the value of a by 1. So now 2 becomes 3. Again it will go back to the while part. Is 3 less than 3? The condition is false. So your final output is 1 is odd and 2 is even. Fine. So this was about the while statement. Let's move ahead and learn about break. So this break statement, it is used to break the loop at a certain condition. Alright. Let's understand this with the help of this flowchart. Start it, check the condition. If the condition is true, then check the break condition. If the break condition is false, then only execute block 1 and repeat the loop. If the break condition comes to be true, then break the entire loop and then exit the loop. Alright. Let's check it with an example up here. For example, a equal 10. While a is greater than 0, check for if a is not equal to 5. If a is not equal to 5, then print a. Else break it. Fine. Let's execute it. Sorry. Just manage a minus. So we got the output as 9, 8, 7 and 6. Fine. So the moment loop becomes 5, we got exited out of the loop. Next we have is the continue statement. Well, the continue statement won't break the loop. So it will just skip the statement in case the condition is true. Let's understand this with the help of this flowchart. So start, check for condition 1. If it is true, then check for continue condition. If it is false, then execute block and repeat. Then in case if the condition is true, then stop executing that particular block for that particular loop and cut for that particular iteration, and again go back and repeat and check the condition. Alright, let me just show you. Let's just replace this break with continue and let's see what is the result. So yeah, see, got the output as 9, 8, 7, 6, 4, 3, 2, 1, but you didn't got 5 up here, right? Why? So as I told you, this 5 was skipped. Fine. So this was all about the flow control. So let's proceed and learn about function. So what are these functions? Well, a function is a block of organized reusable set of instructions that is used to perform some related action. But why do you even need a function? Well, what if you have to write a program in which you have to use same set of code again and again? For example, you wrote a code of 20 lines or 40 lines, and those 40 lines of code are coming in your main program at 10 different places. And you have to use those 40 lines of code 10 different times in the program. So I don't think that none of you would be interested in writing the same lines of code again and again. So in order to resolve this issue, they created function. So well, this function is a block where you write your code which you think you might use it again at some point of time. Therefore, it allows the reusability of the code and thus minimizes the redundancy. In Python, there are basically two types of function. The first one is the user-defined and the second is built-in function. Let's see them one by one. So what is a user-defined function? Well, any function defined by user is a user-defined function, right? Syntax. It starts with the keyword def. After that, an identifier for a function name, and then you pass the arguments into it. Alright, followed by semicolon, and after that you mention the set of statement inside it. Alright, let's see an example. For example, if you want to add two arguments, so you define a function as add, and inside add you pass two parameters as a and b. So sum equal a plus b and return sum. That's it. So it's as simple as, let me just define a user defined function for you. It's like it starts with the keyword def. After that I'll write a function name as add. Inside that I'll pass two arguments, a and b, semicolon, and this function should return me the sum of a and b. Alright, fine. So this is my user defined function. Next is the built-in function. Now these built-in functions are a predefined set of functions in Python. We have abs function, which returns the absolute value of a number. We have all function, which returns true if all items in an iterable objects are true. We have any function, ASCII function, ben function, bool function, and many other built-in functions are available there in Python. If you want more information about it, you can just check out the Python official doc. Alright. Now that we have defined a function, now let's see how we can call a function. So calling a function, well, there are two ways of calling a function. You can either call it by passing a value or by passing a reference. Let's see them one by one. So first is pass by value. Calling a function by passing the value. For example, a equal 10. Def that is keyword. So we are defining the function as print the value of b is b. And again inside the function we are updating the value of b to be 100. And print the new value of b is b. And then what we are doing? Change it. And we are passing a. Now since the value of a was 10, so this function would take the value of b as 10. So print value of b is 10 and new value of b is 100. Let me just show you in order to resolve this issue. Let's define the value as a equal 10. Define my function. Inside that I'll pass an argument as b. Print the value of b is b. You have to concat. Fine. And next we'll update the value of b to be 100 and again print the new value of b is b. Fine. So this is my function. Now what I'll do, I'll call my function by passing a value. Calling a function by passing a value to it. So I'll write my function and inside that I'll pass the value as a. Since the value of a was 10, let's see the output. See, so we got the output as the value of b is 10 and the new value of b is 100. So this was about calling a function by passing a value to it. Next we have is pass by reference. Calling a function by passing the reference. For example, so we have a list as c, 10, 20, 30. So we are defining a function as change them and we are passing an argument d to it. Inside the function we have print value of d is d. D of 0, it's a numeric constant. We are defining it as 99. D of 1 as 98. Then print the value of d is d. Then change them. Now when we are calling a function by passing the reference, so what we are doing, we are just passing the entire list to it. So what will get the output? We'll get the output as value of d is 10, 20 and 30. And the new value of d is 99, 98 and 30. Let me just show you with an example. C equal 10, 20, 30, right? Now let's define my function 2 inside this. D is what? Print the value of D is D. Alright. Next we'll define some numeric literals like D of 0 is equal to 99. D of 1 equals 98. And then print the new value of D is again D. Fine. This is my function. Now if I call my function using pass by reference, so my function 2, and I pass the value C into it. So let's see what we get the output. So we got the output as the value of D is 10, 20, 30 and the new value of D is 99, 98 and 30. Fine. Let's move ahead. Well, when a parameter is passed by reference, the caller and the callee uses the same variable for the parameter. Well, if the callee modifies the parameter variable, the effect is visible to the caller's variable. But when a parameter is passed by value, the caller and callee have two independent variables with the same value. If the callee modifies the parameter variable, the effect is not visible to the caller. Well, the things that you need to note in this definition are, well, the variable word here means the caller variable itself. That is, if I pass a local variable by reference and assign to it, it will assign the caller's variable itself. Do you know what is the meaning of reference and pass by reference? Well, it is different from the general term reference. It is that this reference is temporary and implicit. What the callee basically get is a variable that is somehow the same as the original one. Here on the screen is a very good example of pass by reference and pass by value. Alright. In pass by reference, you are filling a cup using the reference of the cup, and in pass by value, you are actually filling the cup using some values. So this was all about how you can define a function and how you can call it in Python. Now let's discuss about the lambda function in Python. So what is this lambda function? Well, a lambda function is a small anonymous function. Lambda function can take any number of arguments but can only have one expression. Note the fact that lambda function cannot have more than one expression. So here's the syntax. Lambda argument colon expression. For example, we have x equal lambda a colon a plus 10 and print x of 5. So what it is basically doing, it's defining a lambda function that adds 10 to the number passed in as an argument and then print the result. Let me just show you in our Jupyter notebook. Let's define a lambda function as x equal lambda of a such that a plus 10 and then print x inside that will pass the value of 5. So what do you think the output should be? 5 plus 10, it would be 15. Alright. If you change 5 to 10, the output would be 20. Alright. Let's move ahead. So next is function versus lambda function. So what we are doing up here, we are comparing function with a lambda function. So here's a normal function which takes two arguments and return the multiplication result of both of them. And here is a lambda function for the same. It's like r equal lambda x comma y such that x multiplied by y, and if you call r 12 comma 3, what it will do, it will return the result of 12 multiplied by 3, that is 36. I'll just show you this in our Jupyter notebook. For example, I'm defining a function as def. Let's name my function as multi. I'll pass two arguments up here, x and y, colon. Now return me the product of x and y. That's it. It's done, right? Now, what if I have to define a lambda function for this? So I'll write like z equal lambda of x comma y such that it equals to x multiplied by y. Fine. Now if I want to test this, I'll write print z of, I'll pass two values in it, 12 comma 3. So it should return me as 36, right? So yeah, I got the output as 36. Fine. Let's move ahead. Next is the power of lambda function. Well, the power of lambda function is better shown when you use them as an anonymous function inside another function. For example, let's say you have a function definition that takes one argument and that argument will be multiplied with an unknown number, right? For example, you have my function as n returns lambda a such that a plus n. So you are defining a variable my sum equal my function of 3. For example, let's see in our Jupyter notebook. Define my function and we'll pass an argument as n such that it should return lambda of a such that a multiplied by n. Alright. Now you can use this function definition to make another function that always doubles the number you send in. For example, I can write double me equal my function. I want to double it. So my function of 2. I need to multiply it with 2. Now print what number do I need to multiply? So double me for, I want the double of 12. So double me 12, the output would be 24. So if you want to triple it, just change it to 3, your output would be 36. And so on. Alright. So this was all about the lambda function. Fine. Next we have is Python classes and object. So what is a class and object in Python? Well, Python is an object-oriented programming language and almost everything in Python is an object with its properties and method. And a class, it's like a blueprint for creating objects. Let's see an example of a class. We define a class as class space class name colon and inside that you define its objects. If you want to call an object, let's see how you call it. You're defining a variable as obj1 and you are assigning all the object of my class to it. And if you want to print one of the variable of my class, so you can access it using obj1. Alright. So this was about the classes and object in Python. So coming to our last topic of file handling in Python. Well, file handling is a very important of any web application. Well, you have 4 different features which you can perform in a file handling. You can open, read, write and delete a file using Python. Alright, let's see them one by one. The first one being open. So you can use open function to open a file and it takes 2 parameters, the file name and the mode. Let's see the syntax. Syntax is f equal open path of the file. So you have the syntax as f equal open path of the file and its mode. Fine. Let's see what are the modes. So we have 4 different types of mode: read, append, write and create. For reading, you specify R. It's a default value and it opens the file for reading. And if the file does not exist, it will return you an error. Next is the append. And the mode is A. Alright. What it will do, it will open a file for appending. And in case if the file does not exist, it would create a new one. Next mode is W, which is write. It opens a file for writing and creates a file if it does not exist. Fine, I'll tell you about the difference of appending and writing later in this section. Alright. Next and the final one is create, that is X. It creates the specified file and it returns an error if the file with the same name exists. it creates the specified file and it returns an error if you already have a file with same name. Fine. Let me just show you. Like f equal open path of the file. I'll open it in my D drive, D slash name of the file, test file dot txt, and comma, what should be my mode? It is a reading mode. R. Hit enter. Okay. So as I told you earlier, it would throw you an error if the file does not exist, right? If you want to create it, you have to mention X up here and it will create your file. Let's go to our D directory and let me just show you the file. D, so you can see the test file up here, right? So this is how you can open a file in Python, or you can even write W up here. It won't throw you an error, since it creates a file if it does not exist, but it won't throw you an error in case the file with same name exists. Alright. Next is the read function. Well, suppose this is our file. It consists of the document hello welcome to demo file.txt. This file is for testing purpose. Good luck. Let's open our demo file. Test file. Hello everyone. Welcome to Intellipaat. Good luck. Let's save it. Save it as test file.1. Fine. Let's see what operation we can perform on it. Now, what if I want to read it? So how will I do? So f equal open demo file.txt comma mode r. R is what? Reading mode. And then print f dot read. Fine. Let me just open that file for you. F equal open. The path of the file, it was d:/test file1.txt, and in what mode? I want to open it in read mode, and I want to print all the content which is present in that particular text file. So f dot read it first and then print it. Hit enter. So these are the content of my file. Hello everyone, welcome to Intellipaat and good luck. Fine. Now what if I want to read some parts of the file? Like I want to read the first 5 characters of the file. So what will I do? Let's see. Just copy and paste it. I want to read the first 5 characters. So just mention 5 up here. What will it do? Print first 5 characters from the text file. Hit enter. So you got the output as hello 0, 1, 2, 3, 4 and 5. So these are the first 5 characters from the string. Alright. Fine. Now what if you want to read the first line? So for that you have a function as readLine. Alright. You have a function as readLine, which would be used to return one line or the first line. Again, copy it, paste it up here, readLine, just hit enter. Sorry, you got an error. Okay, readLine. Okay, sorry, L is small, readLine. So you got the output as hello everyone. This is my first line. Next, what if I need to read first 2 lines of my document? So what will I do in that case? So in that case, what you can do, you can use readLine twice and it will print first 2 lines of your text. like this. Again, do it once more. F dot read line, hit enter. Again, the same error. Okay. So what you got? So you got the first two line from your text. Alright. Now looping through the file. Now what if you want to read the file line by line? So you can use a for loop in that case. So it's like for x in f such that print x. If x is 1, then print first line, x is 2, then print second line, 3, so on. Alright. So you'll be able to read the file line by line. Hello everyone, welcome to Intellipaat and good luck. Next is reading and creating. Now to write to an existing file, you must add a parameter to the open function. Like you can write a or w. A will append the file, that it will append or add something at the end of the file, and w, it will overwrite any other existing content. For example, let's copy paste it up here. Instead of r, let's mention a, it's for appending. And f dot write whatever you want to write. This is the appending statement. Execute it. Fine. Now if you will check the file, let's check the existing file. Open it in a readline mode. R for x and f, print x, execute it. So yeah, so as you can see, this is the appending statement got added at the end of the file. Now what if I use w instead of a? So what will it do? This will overwrite my statements. So here I can write print f dot write this will overwrite everything. Execute it. Done. Now let's check it again. What are the contents of my file? So if you check it, so only this is left. This will overwrite everything. Fine. So this was about how you can write to an existing file. Alright. Next we have is creating a new file. Well, you can create it using X, A or W. Using X creates a file and it returns an error if the file exists. Append, it creates a file if the specified file does not exist. And finally W, it creates the file if the specified file does not exist. For example, fopen myfile.txtx, it will just create a new file. And in case you are attempting to create a file with the same name, it will throw you an error. For example, remove this. This file already exists, right? If I'm trying to create it again, it will throw me an error. Alright, as file already exists or file exists. Fine. Next and the last we have is the delete. Well, import OS module is used to delete a file. How you can delete it? Import the OS module, os.remove demofile.txt. That's it. But for that, what you have to do, you have to first close the open file. So f.close, inside this, mention the name of the file, or the path of the file, d:/test file1.txt. First close it. Sorry. It's like f.close. Close the file. Now, if you want to delete it, you need to import OS module to it. Import OS and os.remove inside that name of the file. What is the name of the file? Test file1.txt. That's it. Got the error. The system cannot find the specified file. So I guess the file is, no, it's not deleted. Okay, I haven't specified the path of the file. I just written the name of it. So I'll write d:/ and the file got deleted. So yeah, there is no test file 1. Alright, fine.
Okay, let's get started with NumPy. So I believe you guys already know like what Python is capable of, how powerful it is. So we can use Python for all sort of things, right? From desktop development, web development till data science, we can do anything and everything with Python in the programming world. And next thing is Python builds upon its functional modules. Okay, so it has all core constructs of programming. Like there are 3 types of programming that we have: structural, object oriented, and functional. So it is capable of doing everything. Okay, next is when we work with anything in Python, we have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily, okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So what will we do? We will be starting with this NumPy for today. Okay, so after that we will see, after that we will go for SciPy. So these two are basic packages for data scientists. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array. It is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing, and all those kind of stuff, it will only be the list. Everything will be based on the lists. Okay, so that's how it goes. Okay, so that's what we will start with. So NumPy will have a lot of functions which will help you to play around with the arrays of it. Okay, so that's how it works. So now what we will do, we will just cover the basics of NumPy and then we will go for the coding examples and all. So that's how we will be planning for the day. For that, let me open up a new kernel for you guys so that it gets easier for typing out the codes. Okay, so let's go ahead with the PPT now. So first of all, we will see how to create a NumPy array. Okay, NumPy array means, again I will repeat, it is just Python list. It is nothing more than that, but it has some added features. Along with Python lists, it has some added features. So that's why NumPy is used. Okay, due to some extra features that we don't get in normal lists in Python. Okay.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python, so that will be coming along with pandas and NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax? Syntax is import, then there will be package name, then there will be as keyword just to assign an alias, otherwise you would need to type the entire thing throughout the program, and then we will have a alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, why it is taking time now? Yeah, so see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now, it's not anymore a tuple, so that's why it is editable. Okay, and NumPy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface, then what you need to do, you need to install it using command prompt. Okay, pip install, sorry, I am getting it again and again, pip install numpy, so it will find it and it will install numpy. Okay, I don't have this pip version set, so that's why it is not working, but it should install it. Okay, so that's how it works. That's how we can use numpy in this kind of functions also. Okay, now we can have 2D arrays in Python also, like 2D arrays in numpy also. So how we write it? We write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists. So it will be concatenating it to 2D array. Okay, so it will be changing it to 2D array. So that is how we write it in NumPy. That is how we create arrays in Python. So that's how we do it. So now next will be where it is where it is advantageous rather than using a basic Python list or Python like that, Python list or Python tuple, right? So by NumPy you are changing yes, so we are changing data type from mutable to non-mutable. It's the other one, right? Right. Next is nd array object. Okay, so in NumPy, as I have shown you, 2D arrays, right? It can go up to n and then can have any number. So in real world, if you ask me, we don't use more than two max to max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is like why we use NumPy arrays. So in NumPy, this nd arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. It has to, all of them has to be int arrays. Okay, like that. So items can be accessed using zero based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property. It has zero index. So if we go for NumPy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see first, sorry, if you want to see the first column, you need to do this, right? Sorry. So you need to do this, so you will see the entire values. If you need to see the only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays, I will be coming. Okay, I am working on 2D array. Sorry, I forgot. So that's how it works. Okay, so we will be coming to that in a few minutes. So 2D arrays I will show you. So for others, what was the names? A and B, right? 2D arrays I will be showing you. Not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element, because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has 2 elements. Now if we do this, then it will print all. If we do this, that also will mean the same, and it will print the same. It is pretty basic, pretty much like the lists that we have in Python. Okay, now NumPy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay, this part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than NumPy array. Okay, now next is, if you go into check the individual, yes, right, so it will be begin colon n minus 1, that is how. So right hand side will always be excluded, like that. Okay, next is NumPy array initialization, right? So how do we initialize NumPy arrays? As we have already seen, right, how do we do that, but still this is how you do it. Okay, so initialize means what we want to do is, we don't want to place any list in there. Okay, but what we want to do, we want to have some by default values. Okay, default arrays we want to take it up. Okay, so let's see how we do it. Okay, first one is, we will, I mean, if you guys are familiar with the terms like masking and all, that is for image processing, and for data processing we will do that. A lot of times we will do that. Okay, so a lot of time we will be using this zero based or one based indexes. Okay, so for creating a zero based arrays, right, what we need to do, we need to have some sort of like some shape of zero arrays. Okay, so that's how you do it. Okay, that's how you do it in NumPy. So what you do, you write np.zeros, then you specify the dimension of the array. Okay, 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np.zeros, then row comma column. Okay, that's how a tuple you need to pass it to. Okay, that's this kind of tuple you need to pass it to the Python arrays. Okay, so that's how it works in Python, I mean in NumPy. So that's how you print zero arrays in NumPy. Okay, next is, if you want something with the interval, right? So how you do, you write like this, np.array, within bracket we pass, so it will print you another new array. So what we are doing, we are in here, what we are doing by array, yeah, so in this what we are doing, we are, yeah, right, it's arrange, so it's a range actually. Okay, so what we are doing, we are passing 3 variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having 5, we want lists to be 5 separated, right? So first one and second one difference will be 5, like that. So that's how we have, so we have 3 numbers, right? 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go. Okay, till 20 we will print it out. Okay, so that's how this kind of arrays are getting printed out in NumPy. So using this a range, you can have other type of arrays also. Data visualization, why it is needed, what we are, how you are going to do with data visualization in Python. So that's what we are going to see. Okay, first comes into picture, what is data visualization. So data visualization is basically presenting numeric or any kind of data with using using charts and graphs and or any other pictorial formats, right? So by that, what it does is, if you this is a proved theory that written instead of going for a written or some reading some written thing, and between visualizing a picture or seeing a graph, the second one, that this graph or this image technique helps to remember or grab the context much more easier. Okay, also it gets easier to explain what we are going to do with these graphs and charts, right? So that's why we do use so many graphs and charts in our ppts, in our excel files, right? So to make the client understand easily, like, see, this is the data that we drill down, and this is what we have found out, so this is the trend that you have. So that's why you need to tweak in here or tweak in there to change your parameters, like that. So that's why these things, this data visualization thing gets really important for being data scientist, data analytics, or in any field, right? In any field, this is very important. So if you are working in IT industry or banking or finance, doesn't matter, you will always need this visualization technique. So Python provides a really powerful tool. So a few libraries are there. So as I already told, in Python you would generally not be required to write those long codes, like with the algorithms with displaying pictures and all those things. You are not you will write it, but it's pretty less. So most of the time, what you will do is you will grab a already defined and already optimized library that is available in net. Those are all the time will be open sourced. So those open source libraries you can grab, and you can use those to use those as it fits your purpose. Okay, so that's what is what and why is data visualization important. Next is, if we go to this visualization, this helps the clients to understand the data much more clearly. Also, if you see a few numbers over the years, let's say we are trying we are going to give a summation, like a project estimate for a new project that our company wants to onboard, right? So in that case also, what we would need to do, we would need to analyze the data, right? How the shifts will cover, what is the AD work, what is the AMS work that we have, like the support work or the development work, what we have and what we don't have, those kind of things. Those are basically done by taking data from clients, like, okay, fine, I can give you an estimate, provide me this details. Or what we can do, we can take experience from our previous projects in in our company that is currently being run. We can analyze their data and we can shoot them, like, okay, this is what is the thing. Okay, and we can ask data from clients also. So that's how we can do. Okay, so in those cases, data visualization comes really handy. Okay, and data visualization is presenting the data that you have in a graphical format. So that means, let's say you are collecting trends for something over a few years. So what you will have, 2013, let's say it is education ratio, male 98%, female 100%, like that. This distributed data you will have. So 2013, 14, 15 till 19 you will have some, till 18 you will have some xyz kind of data. But that won't really make sense, right? So if you just plot it, real sense, right? How the ratios have changed, how, what is the trend, right? Like girls are more initiative in this. Or if you have a more drill down, let's say to like those rural and urban area levels, then which level girls are performing better. Okay, so that's what is data visualization all about. So that's where we use it, and that's why we use it. So if you I will show you some example also, real world things where this data visualization comes into picture and how this comes handy. Okay, so that we are going to see in a few minutes. Okay, so that is what is about this. And next is, I mean, data visualization example. See here, we are trying to explain some difference of mammoth and saber-tooth cat. So if you see those pictorial way, if you tell them it has long teeth, both of them will have long teeth, right? So it will get confused. But if you just, I mean, just plot these data, if you just show them with the picture, like compare the upper table and the below pictures, then the later one, the picture one is much more clear, right? So that's where data visualization comes handy. Okay, so that's what the idea, that's why we use it. And as a data scientist, you will almost always be using this technique to get some insight from the data, like that. Okay, Okay, so now the things that I was telling you, like this data visualization, why it is important and how different it becomes when we plot the graphs from seeing the data points only. Let's say in this one, in this chart, there are four data sets, right? They are just points of x and y. Okay, they are just 2D points of x and y. So this, if you see all these four data sets and if you see their basic stats, right, like some average, standard deviation and all this kind of average basic stats, then you will see that those have almost a similar kind of values, right? Some is always like 99, some for x is 99, for y is 82.51, average for x is 9, like that. So all the basic stats of these data sets are similar. So if you just see those with naked eye like this, then you will not find any difference between these data sets. You will basically go ahead and comment, okay, these four data sets are same, nothing to no need to worry, all these are same, all the characteristics are same. Now the next thing I will show you will, where you will see how different the data sets are, how different the data sets are, you will see that. So if you are going to plot this data in this 2D plots, right? So see here what it happens. Do we have it in example? I believe we don't have it. Okay, fine. So if you plot this data in a 2D plane, right, this will look something like this, that is in my screen. So let me just grab my piece of code for this Anaconda portrait. So that's how it becomes, but the data visualization comes handy. Okay, so that's where it comes handy. So I will just get it and will run this one. I have this in my screen. So see, this is how the data sets differ from differ when you just go ahead and plot this in a graph. Okay, I will show you the code, but no need to be worried, that that is I mean already given. So if you see, this is the same kind of data that we got here, right? So if you see here, for the first data set, the data is almost evenly spread and it fits a linear equation, right? Almost fits a linear equation. It's almost there, right? For the second one, see a S-shaped curve is there. For the third data set, it is again a straight line. Okay, only one or two points are here and there. Those are outliers, so can be safely excluded. So this is almost there. But in the fourth line, see that type of data, it is stacked. All the points are stacked in here, because if you check this, all the x values for the last one is set as 8 except one. For one value, that is 19, right? So all the values are stacked in here for x, and this is the 19 one, for which x equals 19. So this is how different the data sets are. Okay, this is how much different the data sets are. But if you see their correlation coefficients, mean, standard, and everything that is printed over here, R is for correlation coefficient. So if you see here, you see all the values are same. I mean, there is not much of a difference. Okay, so one thing need to be remembered, that this Anaconda portrait is a unique data set. Okay, this Anaconda just found out these points, these sets of data with this 2, 4, 6, 8, 10, 11 data points to be having this kind of characteristics. This is a pretty unique thing. After this Anaconda portrait was discussed, there are many attempts to revisit those, and almost everyone who is related to this data science and machine learning or maths or stats things, they always have tried to back calculate thing and tried to predict different kinds of data set to have the same kind of thing, like where the descriptive stats are almost same with four data set, obviously with four x and y data sets. So for four of them, the descriptive stats are almost equals. So that's what I am telling Rajiv. Just let me finish. So this for these data sets, this is the unique data set. Okay. So for in here, those four of them are, all the four of them have same kind of descriptive stats, but it just differs radically when you plot those. Okay, so that is where this comes handy. So for data visualization starting purpose, this is a very good example, and there is no other data set till now discovered which has this kind of values with four different data sets having same kind of descriptive stats, but differ in this radical way, like how these graphs are. Okay, how these graphs are different. Okay, so that's where this thing comes into that's where this thing comes into picture. Okay, that's where it comes handy actually. Okay, now if you check the code that I have pasted here, so see, this is how we import Matplotlib into our Python code. So Matplotlib, why Matplotlib? Coming to it, just as I'm explaining the code, I will explain this and then we will go ahead and discuss this. So this Matplotlib code, right? So that's where what we are doing is, in this Matplotlib code, what we are doing, we are just, this is a Matplotlib library, and this is a object-oriented library also. Okay, so that things we will discuss later. If you want to do that, you can just take this XY points, and you can try plotting these points in the plot like we showed in the last class, right? How to plot a line chart. So you can try that way also. If you are not having the data set also, so then also you can do this. Okay, then also you can do this from this picture itself. I believe in this file, this Anascom quadrate picture won't be given. I think so, because I don't have it. If they have updated, then fine, you can take it from that code part also, but I don't have this one. Okay, so I just had my own version. So anyway, it will work. No need to be worried. Okay, and also the data set is already present, right? So what you can do, you take two arrays x, y, x1, y1, x2, y2, x3, y3, four arrays you can take of x and y, then merge those. Like for x, y, plot together, x1, y1 plot together in the line chart, and then only you can see this kind of plot. This is nothing much. Okay, so that's how you can do. No need to be worried on that part. That's really easy codes. Once I explain this, you will understand. Okay, so what we are doing, we have taken all these x points here, then we have calculated y point with this equation, and if you see, the equation will fit this one to some extent. So yeah, that will be better. So if you focus on this, I will show you how those are plotted. Okay, so that will be helpful for you. So see here, we have used plt.plot x and y1. If you even if you for now, if you do even if you don't give this parameters, it is fine. It doesn't, it is not required. It will give you some kind of plot also. So for now, keep it to plt.plot x comma y1, and you can have the color also. If you don't give it, it's fine. It will give you a nice good color. So that's how it works. Okay, so that's how these are plotted. So others that I have, those are really advanced level things. No need to be worried for now. I will skip those. We will discuss those later. That's fine for now. For now, just see, we have plotted x and y2, x and y1 like that. Okay, so that's how we have done xy1, xy2, xy3, x like x sorry, yeah, like that, xy1, xy2, xy3, and x4 and y4. Why is that? Because if you see, the x part for all these three data sets are same, right? So only one array would do, and for y we have four different arrays, and we have plotted those. Okay, we have plotted those using this plt.plot line. Other lines that are there, even if you don't give it, not an issue, it will still run. Okay, if you have that in the code, you can try. Yeah, label the variable means which one? Like x and y, it will take automatically. So plt.plot, as if you remember, I showed you yesterday, the first one, it will take the horizontal axis, second one it will take the vertical axis, so it will have x and y too. Okay, other things we are we will be coming in shortly. We have this in far more detail shortly. Okay. Okay, so that's what is Anascom Quadrat. So next is data visualization libraries. We have a lot of libraries available for Python to plot these graphs. Okay, plot different kinds of graphs. We have Matplotlib, ggplot, Seaborn, Plotly, and GeoPlotlib. So all these plots comes handy in data visualization, but the Matplotlib It has a really good interface. It has OOP models included. It has different kinds of graphs predefined in it. It can, like, as you saw, right, we have a setup function, we have a access function, text function. All those functions are for customizing the graphs. They are very high level things. So this is just to change your graph, and then that can radically change your graph. Your graphs can be very beautiful. If you explore this more and more, you will see your graphs are getting really beautiful. For presenting it to someone, those will be required. But for data science related purpose, for your solutions, when you are experimenting with the data sets, that is not really required. But again, when you are presenting it to someone, it can come handy. But that's fair enough. I mean, if even if you don't get it right now, it's fair enough. You have time for that. Okay, so that's how it is. Sorry, what is happening? Okay, so next is Matplotlib is there. Next is Seaborn. Seaborn is again built on top of Matplotlib, and that's also a very good plotting library. So, but and generally we use Matplotlib the most. Then comes the Seaborn plot. Others we really don't use it for now. Okay, we really don't use it because those are having some here and there limitations and all. Okay, so this can create 2D graphs and plots using Python scripts. Obviously, whatever we are seeing, it can create multi-dimensional graphs also, but those are not for now. Those are not required. When we see machine learning, we will see that, like, the contour plots are there. What are those and how they look? We will see that. Okay, those are kind of multi-dimensional graphs. So 2D graphs and plots can be created easily using Python script. It can produce the output in a various hard copy format. That means whatever graph you see here, you can save it to a PNG file, JPEG file, or whatever. So that's where this comes really handy. Okay, that's where it really comes handy. Okay, next is next is why to choose Matplotlib, because it has a, first of all, it is a OOP based API. Okay, the library is almost based on OOP settings. So that means it will have the same kind of structure as classes and objects when you try and refer the Matplotlib module. So that's why you must have seen we have used matplotlib.pyplot, right? So matplotlib is the basic class and pyplot is a function of it. So that's why class name dot object name, object name dot function name. That's how we use it, right? That's the OP basic. So that's how we do it. Okay, yesterday you saw we can integrate this using pandas, and as pandas is based on NumPy, so NumPy is also possible. I have shown you examples, but this Matplotlib was not known to you, so you can go back and check the examples where I showed you. Okay, next is very wide variety of graphs. We will see that next, like what all types of graphs we have in Matplotlib, and how that can be used, and what are the usage of those graphs, and where do we use it, like that. We have simple functions used for visualization. So if you go ahead and see here, forget about the first example, see this basic. What we have done, we have taken a np.a range. Okay, we have taken a x variable np.a range, and we have the values from 0 to 10 with 0.1 separated. Okay, then we have taken a y value, which is 2x plus 5, so that is an x and y linear equation. Okay, and we have plotted the xy points, and this is how it looks like. So this is how you plot a line plot in Matplotlib. Okay, next, what we have done, plt.show to show this plot. Okay, to show this plot to you. So that's how easy is that's how easily you can visualize a function in Matplotlib. Okay, so with this plt.show function, you can see the graph in here, and plt.plot will show you the plt.plot will plot you this line. Okay, so that's how easy it gets when you use Matplotlib functions for data visualization. Okay, so that's how it is. And always remember one thing, the behind the scene, the main module that is responsible for this data visualization is called pyplot. Okay, so that's why if I go back to the code, you will always see we have imported the module matplotlib.pyplot. Okay, we always have used it, right? And we have used alias just to have a ease of reference, right? So that we don't need to write the entire thing in there. So that's how it is. Okay, so that's where this matplotlib is. That's how easy matplotlib is.
What are exceptions? So let us understand that. Firstly, let us look at the definition of exceptions with regards to programming. In programming, an exception is defined as an event which stops or interrupts the intended flow of a program's execution. So, as a programmer, when you write code, you have an intended flow of how your code blocks will execute, in what particular order, and what exactly you need to execute. So, anything that comes in between, anything that occurs out of the blue, any exception, so to speak, any error that happens that is unaccounted for, will totally interrupt your flow, and that is called an exception. And we need to deal with that in programming sense, because otherwise we can break our applications, right? So let's look at this from a technical perspective. There are two types of programming languages that exist. So the first is compiler based languages, and the second is interpreter based languages, right? So in compiler based languages, what happens is all of the code is firstly compiled and converted into bytecode so that the machine can execute it all at once. So in this particular case, before the execution of the code is converted into low level language, right? The entirety of the code. So in this particular case, what will happen is you'll basically have your code structure where the code starts. There will be a code module one, a code block one that will execute, which doesn't have any errors or exceptions. So it will execute successfully. And then if you encounter a code block or a part of the code where there is an exception, a code block, so it will simply throw a compiler error that there is an exception over there, or there is a code error over there. Simply go and fix that. But it will not interrupt the code module 3, at least in the compiler sense of way. The module 3 will compile successfully, and you can even run the code and it has a chance of running successfully. So this is called compiler based languages. These are like, for example, we can take C, C++, Java. These are compiler based languages. All of the code is first compiled and then it is executed. So on contrary to that, we have interpreter based languages. Now in interpreter based languages, the entirety of the code is not compiled. It is just executed line by line. Right. So Python is one of those languages. Obviously, Python is an interpreter-based language. So the workflow of interpreter-based languages goes something like this. So the code starts line by line, right? The first code module is executed because it does not have any exceptions. It is correct, so it is executed. So the next code module where there is an exception, when that is encountered, right? What that will do in interpreter-based languages is that it will stop the execution altogether. So the next code module will not execute either, right? So what happens essentially in this particular case is that even if the code module 3 does not have any exceptions, it is completely logically correct, right? It will still not execute. So in interpreter-based languages, not handling exceptions could lead to the entire application breaking, right? So we want to execute things that are correct, right? Even if code module 2 is wrong, we want to resolve that particular issue and we want to move on to code module 3. So unless we handle these exceptions, that is not going to be possible, right? So exception handling is meant to deal with exactly this. So let us look at the workflow of this particular case if we handle the exceptions. So how to handle exceptions in interpreter-based languages? It is sort of the same for compiler-based languages as well, except we all know the logic of whether all the code modules will compile or not in compiler-based languages. In interpreter-based languages, we do not need to concern ourselves with that. What exactly happens over here is that the code module 1 will execute successfully as it should. When the exception is encountered in code module 3, we can see a little bit of change in the flowchart, except for the arrow, instead of the arrow pointing downwards from code module 3, right over here, as we can see, the arrow goes to the right and it basically goes into the condition which says that if there is an exception, execute this part of the code on the right hand side, and then continue as usual to code module 3. So even if there is an error in code module 2, we have created a fail safe for that essentially in this if exception clause. So whenever there is an error which is encountered, we go to the if exception clause, and then the if exception clause continues on to code module 3, and we are able to execute the entirety of the program as much as possible without actually having to stop the execution at all, right? So this is how exception handling happens in a diagrammatic view. So now that we understand the workflow of exception handling in Python, we can look at some examples of exceptions that can actually occur in Python in day-to-day programming. So we'll look at some simple ones so you understand the concept. The first one we're going to look at is called the zero division error. Now, the error name is pretty straightforward. It happens when you try to divide a value by zero, or you basically try to get the remainder of that particular value by zero. So the modulo operator or the division operator. So essentially, if you understand this arithmetically, when you try to actually do this in theory, what happens is you get infinity when you divide a number by zero, right? In computational terms, you cannot actually compute infinity. So to deal with that particular issue, what programming languages do is that they throw an exception when you try to run this particular operation, right? So you can design cases to deal with this particular exception if it happens. Other than that, this is what the error is called. It's called the zero division error. Then we have the name error. Now, in name error, what happens is when there is a variable name that you're using, which has not been defined previously, right? And you're directly using it, it'll throw a name error. For instance, if you try to write a statement which is a equals to b plus 3, and you haven't defined the value of b, right? Then it'll throw a name error because this b variable has not been defined. Then next up, you have type error. Now, the type error refers to data type mismatch, essentially. So what happens in this is when you try to basically perform an operation where there is a data type mismatch. For instance, in this particular example, we can see that a equals to hello, which is a string value, plus 4, which is an integer value. We are trying to add an integer to a string without any implicit or explicit conversion, right? We're not trying to convert this particular integer to a string value and then trying to add it. We're trying to add it as a numeric value itself. Now, in programming logic, that cannot happen. We need to convert this 4 into a string if we want to add it to our hello value, right? So in this particular case, it will throw a type error because there is a data type mismatch between string and an integer. So if programming languages have defined a variety of exceptions, there must be a way to deal with these exceptions as well. So what happens essentially is that every programming language has its own way of dealing with these exceptions, right? In Python, there are ways as well. So let us understand what is exception handling first. Exception handling theoretically is defined as the process of adding fail-safe measures into the code to keep the program running in case of an exception, right? So it's essentially used from the application point of view to stop the application from breaking when an error is encountered, right? So let us understand the various methodologies that Python implements to deal with these particular exceptions. So firstly, we use the try block, right? So the try clause is used to define the block of code that you intend to successfully execute if no exceptions occur, right? So instead of writing code straightforward, like writing printx without the try block, what you'll do is you'll simply write the try and then you'll indent a print statement after the try, right? So this print statement is now under the try clause. So if an exception happens, you can now handle this particular exception. Instead of the program simply giving you an error and stopping, you can now find a way to deal with this particular exception. You can try this code. If this does not work out, you can deal with the exception that happens. So next up we have the except block, right? So the except clause is used to define the block of code that you would want to execute if and when an exception is encountered in the try block, right? So say in this particular case, suppose the print statement fails. So when it fails, the control goes to the except block and it will print exception, right? So you can deal with this various ways. You can add various categories of exception in front of the except clause to deal with that particular exception only, which we will see in the example that we are going to execute. But this is how you would deal with a particular exception. When you try a part of code and it does not execute successfully, you can straightforward go to the except block and execute that statement, which is present in the except block. Then you have the else block. Now this is an optional block of code that you can use. It is used to define the block of code that you would want to execute optionally if no errors occur in the try block. So say if the print statement executes successfully, the except statement will obviously not execute because you haven't encountered an exception, but the else statement will execute because the try statement did not have any exceptions essentially. So it will basically print the value of X and then it will print no errors. Then finally, we have the finally block, right? So this particular block of code is also optional in exception handling. You can use this particular block of code when you want to execute a particular set of instructions, regardless of whether an exception is encountered or not. So the finally block of code will execute whether an exception has been found in the try block or whether the try block has successfully executed. It will still execute. So in this particular case, whether the exception prints or the value of X prints, the will always execute will always print. So this is essentially how you handle exceptions in Python. So now that we understand how these four particular clauses work, we can now move on to the demonstration part of this particular tutorial. So let us see how exception handling works in an hands-on experiment. So let us now see some of these exceptions in action. So firstly, let us try to execute the name error. So if we try to do this, A equals to B plus 1, right? And we execute that. So it simply gives us a name error, right? So the way we can deal with this is by simply going over here and adding a try clause, right? So when we add a try clause, we can put a tab statement over here and add an except statement and print the message that we want to print in case this particular exception occurs, right? So exception has occurred. We do that and we click on play. So we can see that instead of this particular statement executing and giving us a name error, we can see the message an exception has occurred, right? So next up, what we can try is something different. We can write over here except name error, right? So this is the category of exception that we want to deal with specifically instead of dealing with all of the exceptions. That is what happened, right? So if we play this as well, we can see the statement exception has occurred, right? So let us try something else with this. We can also add a finally clause over here or an else clause. Let us first try an else clause, right? So when we add an else clause, we can type print no exception has occurred, right? When we do that and we click on play, it still gives us the message exception has occurred because the exception is actually occurring, right? But instead of that, if we simply change the B to 1, right? Now the statement should successfully execute because there is no exception over here now. We click on that and it'll simply print no exception has occurred. And if we type something like print A over here and click on play again, so it will first print the value of A in the try block, right? And then it will go to else and say no exception has occurred. So next up, we can try something else. Let us try the zero division error. So in this particular case, what we will do is A equals to 100 modulo 0. Let's try that. And print A, right? Now we can type except name error. So we know that this is not the name error, this is the zero division error, right? But we'll still write that and we'll see which exception is actually caught, right? So print name error has occurred except zero division error will print zero div has occurred. Then we play that and we can see that instead of this particular exception printing, the zero division exception has printed, right? So since we did not catch any name errors, the zero division error was caught when this particular statement tried to execute, right? So instead of that, if we simply go over here and change this to 1, right, it'll simply print the actual output. So when we divide 100 by 1, the remainder is 0, right? We can add something else over here, which is called the finally block, and print hello, right? So in this particular case, what will happen is we play this and we get the 0 from the try block and the finally from the hello block. But that is not all. Say if we change this back to 0, right? Now this means that we get the zero division error once again, right? So now what will happen is we'll get this statement, which is zero div has occurred, in which in this particular case the error was caught, the zero division error, and then the finally block was executed regardless of whether the try block executed successfully or an exception block executed, right? So that is how the finally block works. And finally, to look at the last error, which is the try, which is the type error, we'll simply type try b equals to hello plus 17, which is an integer value, right? We do that. We type print over here, type b, we go to except, and we type in the type error, which is the error that we are probably going to catch over here. Print type error, we do that, and then we can try to add an else statement over here. Print the print statement over here will say something like no exception has occurred. And finally, we get the finally block, which says I am going to print regardless, right? So when we try to execute that, we can see the exact workflow of how this is working out. So the tried statements tries to execute. We get this b equals to hello plus 17. This does not execute because there's a type mismatch, the data type mismatch, string and integer. We go to the type error, right? Now, since an error was actually encountered, an exception was actually encountered, the else statement will not execute as well. So this statement will not execute because error was encountered, right? And then finally block, the finally block that we have over here will execute regardless because it executes regardless anyway. So if we simply go back and change this to say 11, which makes this a valid statement now. So it will change the output. So firstly, we will get the 28, which is 11 plus 17. We get the 28. We get the output from the else statement, which says no exception has occurred, no exception was encountered. And then finally, we get the finally statement anyway. So I am going to print regardless, right? So this essentially explains how exception handling works in Python. Now, additionally, we have the option of raising exceptions as well, right? So we have the option of specifically specifying conditions in which we would raise exceptions instead of relying on the predefined exceptions that Python already gives us. So say if we want to throw a type error or an exception in general. So let us type in something like x equals to 14. Right? So this is a value, and now x is equal to 14. Now what we can do is simply type in if x is equal to 14, in which case we will write if x equals to 14, and then given the condition of that particular statement, and then what we would do is raise an exception. This is an exception is the message that we're going to use. So when we do that and click on play, it throws that particular exception, which is this is an exception, right? So we can even configure Python in a way, or we can configure our code in a way to throw exceptions on our custom predefined conditions, right? So the raise statement is used for that. We can also do other exceptions with this particular statement. Now, if I simply start a code block again over here, right, I can raise another exception. Say, for instance, I type in a variable. Now I give the variable a string data type. So let us call this string data. Right now, what we will do is we will check the type of this particular variable. Now, to do that, we'll simply type in if not type a. Now we're checking the data type is int, which is the data type that we're actually checking whether the a variable is of integer data type or not. Raise type error and say that integers are allowed. When we do that and we click on play, we get an exception which says the exact message that we typed in, which is a type error and integers are allowed. So that was the example of how exception handling works. I hope you understand the workflow of it and the exact pattern of how these exceptions occur and how you can handle them very easily. You can also see how you can create your own exceptions by using the raise keyword.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
What is an IDE? An IDE stands for Integrated Development Environment. So it is a software application that contains several tools for helping programmers to write, edit, and evaluate their code. So think of it this way. Whenever you're writing code, you need several applications to work together. Things like code editors to write code and save files, compilers to compile the files, to run the files. If you are writing tests, then you need test runners. If you are trying to take a look at the memory consumption of your application, you might be using a profiler. There are many other tools that you can use. For instance, checking the memory leaks, and all of these things can be done using several tools, but they are all interspersed in the coding world. So to bring them all together, what you can do is you can use an application like Integrated Development Environment. So Integrated Development Environment, or IDE, is just a term used to describe such an application, and these kinds of applications are available for a lot of programming languages, including Python. So what are the benefits of using an IDE? So let's take a look at them. So there are several benefits of using an IDE or an Integrated Development Environment. Let's take a look at them one by one. So firstly, it allows for rapid development. IDEs provide some really great tools for you to write and edit code in quite a speedy way. They allow you to define code snippets so that you can write just a few keystrokes and expand the code and then fill out the important details. It reduces boilerplate coding. They allow you to generate files. They also allow you to do syntax completion. So if you're typing a long name for a variable or a function or a class, you can just type the first few letters of the entire name, and a suggestion will appear, or whether or not you want to use it is up to you. Then comes enforced standards. So many development environments allow you to use something called a linter. What a linter does is it takes a look at your code and it takes a look at a standard that has been set by a company or maybe by you, and it checks whether the code is following those standards. So these standards could be not more than 80 characters on a line, small method names or large method names, methods that are not more than 6 lines in definition. There could be many other standards that you could use. Many companies use these standards to make sure that the code is clean, it's readable, and many companies also enforce standards such as writing documentation, without which your compiler might not even compile your code. So these standards can be set up depending on what your requirements are. If it's just for taking a look at clean code, or whether it's more than clean code, it's more about tooling and all. So these standards can be enforced using an IDE. Then comes easy configuration. You can mold an IDE, especially there are many IDEs that are really easy to configure to your needs. You can change almost anything about many IDEs that you use, going from font to the user interface, configuration about the compilers and interpreters. You can take a look at a lot of things, and you can change all of these things depending on your needs. They do come with a sensible default, but these defaults might not work for you, so you can change them at your own pace. And then comes project management. If you're dealing with multiple projects, then dealing with them without an IDE could be a little difficult. Let's say that your project contains several sub-projects as well. So these kinds of problems can be really difficult to keep track of, and IDEs can help you with that as well. They allow you to export configurations for projects so that you can share that with everyone around your team, and they can use the same thing again. Now, another thing that project management that comes under project management is version control system. So things like Git, GitHub, Subversion, Mercurial, all of these things, they also come under project management, and many IDEs, including Pycharm, have a really good support for using Git and Subversion and Mercurial and other kind of version control systems. Let's take a look at some of the most popular IDEs. So here are some of the most popular IDEs. As you can see, that's Pycharm, it's IntelliJ, which is also from the same company of JetBrains. Then comes Eclipse. Eclipse is more popular for Java development, but it's not really necessary that it can only be used for Java development. For instance, if you want to use Eclipse with Python, there's an extension called PyDev, PYDEV, that could be really helpful. If you are proficient with Eclipse, you know the shortcuts, and you want to use Eclipse for Python development. So for that, you can use PyDev extension. It's a little difficult to install, but if you've already worked with Eclipse before, then you already know how to install it. And once you do, you can use Python with Eclipse. Visual Studio comes with a built-in support for Python. So if you want to use, and if you want to install some additional templates and other things like that, they are also available via the use of plugins. Then comes Komodo IDE. It's also very popular, especially in the Python community. So you can use that as well. Then there's RStudio. It's not for Python, but it's used with R. So it's very useful in that regard. And then as you can see comes PHP Storm. So PHP Storm is something that many web developers use, and since many of these IDEs are free and many of these are not free, and when they are not free, then you need to either download a community version, which is a version of the IDE that comes with limited set of features which are helpful for you when you get started, or you can buy the pro version or the premium version. Many IDEs have different terms for these, or at the end of the day you can also apply for a student's license, which if you are a student they can give it to you either for free or for a much reduced cost. So you can take a look at that as well. Then comes Introduction to Pycharm. So let's take a look at what Pycharm is. So Pycharm is an IDE for Python language. It has been developed and maintained by JetBrains. It's currently under active development. New versions are being released every now and then, and new patches are being released every now and then as well. It is one of the most popular IDEs, especially for Python. If you're a Python developer and you are writing code for Python and you're working in large corporations, chances are you have already come across Pycharm. And Pycharm is really, really good for writing code in such a manner. Pycharm has got some really great features. It's got some really good plugins as well that you can use for your Python code. You can enforce standards. You can do a lot of things. Let's have a demo and we'll see how to use Pycharm. So if you want to use Pycharm, the first thing you have to do is you have to download Pycharm. Now it's very easy. Go to Google, and first thing you have to do is you have to download Python. So you can go to python.org, click on downloads, and download the latest version. Mine is 64-bit Windows. So it already gives me that version to download, and if you don't find the version you want to download, you can scroll around and get the version that you want to. Downloading the latest stable version would be the best way to go. After you have installed Python, you can install Pycharm by downloading it. So you can just search for Pycharm, click on the download link that is given to you in your Google search. When the link opens, it will show you multiple options to download. One of them is the professional version and the other one is the community version. So the professional version is quite useful, especially for those who need the premium features that come with Pycharm. And for those of you who don't really need the premium features, just want to try it out, just want to make sure that you get the basics of Pycharm correctly, then you can download it using the community version. The community version is extremely easy to install and really easy to use, and it's free. And the professional version, although it's not free, gives you a free 30 days trial, so you can use that. It's available for both Windows, Mac, and Linux. I'm using Windows, so I have downloaded Community Edition and I have installed it. Installing it is really easy, so let me just open it for you. I've already installed it, so I'm not going to go with the installation again. But if you want to install it, just open the installer and it will work just fine. After you install it, it gives you the option of opening the Pycharm IDE right there. As you open it, it gives you the opportunity to create a project. If you already have a project, and bear in mind that this has to be a Pycharm project. A Pycharm project basically is a folder with a .idea folder in it that contains all the configuration that Pycharm will use. So you don't need to worry about that. You don't have to use these. You don't have to edit those files yourself. But if you don't already have a Pycharm project, then I would suggest you create one using create new project, which is what I will do. Now, this is just the basic setting. If you want to take a look at some advanced settings, you can take a look at here. Now, you can take a look at the environment that you can use. If you are working with scientific computation, you can take a look at Conda. pipenv is for creating a virtual environment using virtualenv or pipenv. I like using pipenv. It allows you to isolate your dependencies. So if you're trying to use some library such as Django or Flask, but you already have it installed, and now for this project you want to use some new version, you can use a virtual environment in which all the libraries you install will stay in that library, and that for that project only. No other project would be able to access those libraries. So you can use that. And you can take a look at the interpreter. I have Python 3.7. I have Python 3.7, and you can also take a look at Anaconda's distribution of Python if you have and you want to use that. So with that selected, if you have an existing interpreter and you don't want to use the current interpreter, you can just click here and browse for it and then use it. But as of now, I'll be using the base interpreter that Pycharm has already detected for me. I need to change the name of the project. I'll call it Intellipaat demo. I have used pipenv because I find it really easy to use, but it's your choice. If you want to use virtualenv, you can use that. If you want to use Conda as your development environment, you can use that as well. It's totally up to you. Click on create, and the first time you use it, it will take a little bit of a time because it's setting up a virtual environment for you, and virtual environment takes some time. So as I had already created say demos like this, it will create a virtual environment for me, and if it already finds a virtual environment, it will just use that virtual environment. As you can see, it's creating the virtual environment, so let's just wait for a few seconds, and when it gets done, we'll get started with the next steps. Now if it's just a new installation, then it could take a little bit of time for you, and if you have already installed it and if you have already used it, then it might not take that much of a time, so don't worry about it. It will just take a few moments, and when it does, it will open everything up and it will start creating something called indexes. So let me just tell you what indexes are. They are basically things that your Pycharm IDE will create so that it's easy for it to scan the entire project and find files. So that, as you can see, it's launching the skeleton generator. Everything can be seen here. It's discovering the module, reloading the generated skeleton. Skeleton is basically the project structure that it has generated for us. Now it's telling us that it's indexing, which is basically it's taking a look at scanned projects, and it's taking a look at all the files that we have, so that when we try and scan something or search something for it, will be able to much more speed and accuracy. So now that that is done, we can use Python for whatever we want to use. So as you can see, this is the folder that I have. I can click on this arrow to expand it. As of now, since I used pip, I only have pip file. If I open it, this is what it looks like, and it's giving me an option to install a plugin that will help me to get syntax highlighting and better support for pip files. I don't need to do that right now. I'll show you how to install packages in a moment. But first, let me just create a file and show you how to run it. To create a file, right click on the project that you want to create a file in, go to new, and I want to create a Python file, and since it's giving me that option, I'll just create on Python. This has to be a Python file, not a Python unit test file, not a Python stub. So I'll just create a Python file. I'll name it main, and I'll press enter after giving it the name. If I don't give it the name, then I won't be able to create any files. It'll create one for me. Now, as you can see, this is fine, but the code editor looks fine. It's working fine. If I type something, as you can see, it's working fine. The problem that I have as of now is that the text is really, really small. So let me show you how to customize Python to your own taste. So go to settings by clicking on file. Once this appears, you can take a look at a lot of things. It opens with the editor setting, but you can take a look at a lot of things. If you want to search for some setting, like let's say font, click here and it'll show you all the things that you care about. I need to change the editor font, so I have that here. Now it is by default using the JetBrains mono font, but I want to use Fira code, and I want to increase the font size, let's say to 18, let's say to 16, and for line spacing I can take a look at this as well. And as you can see, I get this nice preview right underneath it. So after doing that, I can also enable ligatures. So enabling ligatures basically means that it will allow the code to dictate how it wants certain symbols to look. So if I disable the ligatures, as you can see that not equal to will look like an exclamation point and then an equal to symbol, but if I enable the ligatures, then it looks something like this. So the font will now dictate how certain combinations of symbols should look like. I click on apply and then I click on OK, and now as you can see, the font has been changed. Now you can play around with it a bit, but it works fine. Now let me just write some Python code and then execute it so you can see that it works. So the first thing I'll do, and as you can see, I have syntax highlighting. So if I type in name and I get the suggestion that I want, and I want it to be equal to main. Now if you don't understand this, don't worry. This is just some simple Python code, and I'll even show you some resources through which you can learn Python if you want to get started with Python, and you can already see how we can use Pycharm. So I'll just create a function named main, and here I'll just move the code. For those of you who are wondering, I'm using the shift key and then moving things around. So if I use shift and then press down key, the Pycharm will automatically insert the pass keyword, but I don't want that, so I'll just do it here. So now what will happen is my script will get executed. It'll take a look at the file name, and it'll take a look at an internal variable called name, which automatically gets set. So if I use this file to execute every other file, then I'll get main, and then it'll execute this function, and it will print hello. So to do that, there are many ways I can do it. I can just click here and run it, or I can go to run, click on run, which is here. I click here, I want to run main, and it will run it for me, and as you can see, it's printed hello, and the process exited with the code of 0, which means everything went successful. Now let me show you what else you can do. Let's say that this is not just one file and you use multiple files. So I create another file in which I'll create a configuration class. Let's say configuration helper. Okay, this will be the name of a Python file. I click insert. I'll type in some code, configuration helper. Firstly, I'll define a constructor, and in a moment I'll tell you how I'm doing this. So just type in, as you can see, let me just show you again. I type 2 underscores. It shows me all the things that I can do. I press the tab key. It automatically does everything for me. And now I'll just print construct. Okay. So now if I want to go back to this file, let's say I have multiple files and I've closed this file, first thing you can do is press the shift key twice. So shift 1, shift 2, and you need to do it really fast. And then as you can see, recently opened files are showing here, but if I want to open a file, just type main. It will show me the main method as well as the main file. So let's say that I want to go to the method wherever it's declared. It's showing me the file name right beside the function name as well. I press enter and it automatically takes me to that function. Now that is done, let me just import it. So I need from configuration helper, import configuration helper. I'm using the control and space key together. So hold down control and press space to get automatic completion. And after doing that, all I have to do is create, let's say, an object out of it. This gets done. So now what will happen is if I run this, I can run it from here, and you can take a look at some of the shortcuts as well, which is Control Shift F10 if you want to run it. So the constructor gets run first and hello gets put second. Now as you can see, I have made a spelling mistake, which is deliberate because I want to show you some of the other features of Pycharm. But first, if I want to go to that file again, hold down Control key and then hover over that class name. I click on that class and I am immediately taken to this file in which I have declared this. Now as you can see, I have mistyped the name. So as you can see, it's already giving me an option to do something about it. But another thing I can do, and I want to show you this, is select the class name, right click. There's something called refactor. So if you can see, it's here, and then it also gives a shortcut key, which is Shift F10. Click on rename, and I want to rename it wherever I can, and in the project files you can click on all places as well, so that it can take a look at all the places available to Pycharm and rename anything that's named like this to configuration helper. So as you can see, configuration helper. Now I can click on preview and it will show me all the changes that it will make. So these are the files in which the changes will be made. Click on do refactor. Now it has changed it here, but it has also found out that I'm referencing configuration helper in the main.py file, and it has changed it here, here, and here as well. So these are the kind of facilities that you don't get when you're trying to code it out in a simple notepad or simple text editors, and these are the really powerful benefits that you get when you're using an IDE. Now that is done, let me just show you another thing, which is the debugging capabilities. So I'll just create another function, print with hello, and all I'll have to do here is I have to print, and I'll do some Python code here. I'll format the string, and inside the format all I have to do is pass in name. So what it will do, it will take a look at the string, print hello, comma, and then takes a look at a variable. I can remove this as well. and takes a look at the variable named name and prints that for us. Replaces this empty brackets into name. This is what's known as Python string interpolation also. So you can do that as well. And now, just to make it a little more complicated, I'll just create another function, def get config name. And as you can see, as soon as I type this character, which is an opening parenthesis, Pycharm automatically types self, closes the parenthesis, and types a colon for me. And all I have to do is return default config. Save this, go here, and now if I run this, it works fine. We get constructor, we get hello, and instead of doing this, now what I will do is I will print with hello, but I will use the config get default name. And now if I run this, you will see that the execution will be changed a little. We get constructor hello and this. Now if I want to debug this, debugging basically means stepping through the code line by line to see what has changed. Now this is really easy to do, especially in Python. I want to debug from this line, right? So I can, instead of running it, click on debug main, or I can click on debug as well and choose main. As you can see here, if we do that and that happens, starts debugging, and we get here. As you can see right now, no variables have been declared in memory, so we get nothing. And we get options to step over some code, step into the code, step into to see your code. If it's a library code and you don't want to step into it, then you use this function, which I will do in a moment, and you get to step out. So I want to step into my code and see what happens when this configuration helper gets instantiated. Click here, it opens the file, it gives us the name of the value of the self variable. If I open it, it's giving me the memory location as well. And as you can see, nothing's been initialized as of now. I step in, it prints constructor. If you want to take a look at this, you can take a look at console simultaneously, and you can see constructor has been printed. Now you go ahead, print hello world, take a look at the console, it gets done. Only the config variable has been created. As you can see, there are no variables associated with the config object. And I then step into the function, it returns default config. After that, it steps into the function that we have declared with the print with hello function, prints everything, and then exits, because that was the last line. Everything has been printed and we have come to the end of our code. So that's how you can debug things. Now that that is done, let me show you something interesting. Let's say that you want to, after going to that, click on settings. There are many settings available for you. You can install some plugins to make changes to the way things work. If you are using Vim as the code editor, then you can install the Idea Vim plugin. You can change the look at the material themes as well. There are a lot of things that you can install, and these things either upgrade the functionality of some existing feature, or they introduce new features as well. For version control, you can take a look at many other version control systems like Git. If you want to add a GitHub repository, you can do here as well. Mercurial, Subversion. And finally, for our project, we can take a look at Project Interpreter. Right now, we have not installed any package, so we don't have to do anything. If you want to install a package, click on the Add button. And as you can see, it's getting the list of available packages. Let's say that I want to install Flask. This is what the current version is. If I want to install Flask, I can just click on Install Flask. If I want to specify a version, here are the list of available versions. So you can see it's very graphical, very useful. I'm not going to install Flask right now because I'm not going to be using it in this demo, but you can do it if you want. So with that in mind, this is what it looks like. This is what a breakpoint is. So when we were debugging, I put a breakpoint here so that I can just debug my code and the execution will stop here. And from that point on, I can just step into the code. So it's very easy to do if you want to do it. So there are a lot of features that I can go into. This could be a really, really long demo, but to help you get started, I hope this was quite enough and has whetted your appetite. And if the Python code was not something that you understood, don't worry, I'll guide you to the resources that can help you out. But the intention of this demo was to help you get started with Pycharm, to help you understand how you can use the basic features, how you can customize it to your liking, you can change the theme, you can do a lot of things that you want to do, how you can navigate around the code, how you can debug the code. There are a lot of things that you can do.
So NLP is a subfield of artificial intelligence where we teach computers how to understand and interpret human spoken languages, or in other words, natural language. So what in the world is text mining? Well, simply put, extracting information from unstructured textual data is known as text mining. Now, let's say there's a 500-page thesis on some financial topic and you come across a sentence which ends with the number 30. Now, you have absolutely no idea what that number means. It could be the number of days in a month, the amount of dollars a stock increased over the past week, or the number of items sold in a day. So this number 30 could mean anything. And without proper context, you wouldn't get the right information. And this is where text mining comes in. So with the help of text mining, we can give proper context to the words before and after the number 30. And this would help us to find out more information. Now let's look at the need of text mining. So today, with the advent of social media, companies now have access to massive behavioral data of their customers. And most of this data is present in the form of unstructured textual data. But beneath this textual data lies an enriching source of information which can help companies to boost their business. And this is the reason why text mining is being used across various industries. Now, text mining can be divided into 4 practice areas. So we've got information extraction, which basically deals with identification and extraction of relevant facts and relationships from unstructured data. Then we have document classification and clustering, which aims at grouping and categorizing terms, paragraphs, or documents using classification and clustering methods. After that, we have information retrieval, which aims at storage and retrieval of text documents. And then we have NLP, which forms the major part of text mining. So here we use different computational tasks to analyze and understand the underlying structure of the text data. Right, now we'll dive into NLP. So when you hear the term natural language processing, the first question to pop into your head would be, what is a natural language? So any language that is used for communication by humans is known as natural language. So English, French, Chinese, all of these are natural languages. Now, since we are humans, we're able to understand these languages. But what about a machine? How is a machine able to comprehend all these human spoken languages? Well, this is where NLP comes in. So natural language processing is a subdomain of artificial intelligence where we understand and interpret human languages using a computer. Now, let's see how is NLP used in text mining. So just think about how much text you see each day. Email, SMS, web pages, the list is just endless. So with the help of NLP, we can go through all of this text data and use it for different purposes such as character recognition, sentiment analysis, and spell checking. Right. Now we'll go ahead and install Anaconda into our systems. So Anaconda is basically a free and open source distribution for Python and R programming languages. And it is specifically designed to perform data science and machine learning applications. Right, so these are the 4 steps to work with Anaconda. So first we'd have to download the Anaconda installer and then we'll install Anaconda. Then we'd have to open Anaconda prompt and update Anaconda. Right, now let me just guide you how we can do this. So first we'd have to go to this website, anaconda.com distribution download section, and you'd have to download the version for whichever operating system you're using. So if you're using a Windows system, then you'll download Anaconda for Windows. If you're using Mac, then you'll download it for Mac. And if you're using Linux, then you'll download it for Linux. Now, you've got 2 versions of Python. So Python 3.7 and Python 2.7. And we'll be downloading the latest version of Python, which is Python 3.7. So once we download this, we have this setup wizard over here. So we just have to click on next and it'll take care. Now, once the installation is done, we'd have to open up the command prompt. So this is what we get when we open the Anaconda prompt. Now inside this, we'll have to type in conda update Anaconda and we'll have the latest version of Anaconda in our system. Alright, now let me just go ahead and show how to do it. So I'll just type in download Anaconda. I'll click on this link over here, Anaconda Python R distribution. And over here, I'll click on this download. So I've got different versions over here for Windows, Mac and Linux. And since I'm using a Windows system, I'll download Anaconda for the Windows system. So this is the latest version of Anaconda, Python 3.7. I just have to click on download. Right, so once the download is done, I'll get a setup wizard and I'd have to set it up. And I'll go and click on Anaconda prompt. So this is my Anaconda prompt over here. So now that we've successfully installed Anaconda into our systems, we'll go ahead and work with the OS module. Right. So the OS module, it provides functionalities to perform operating system dependent operations. So these operations include creating directories, creating, renaming and removing files and many other tasks. And these are the different methods we've got. So we've got os.rename, os.open, os.list directory, os.make direct, os.get current working directory and os.fdopen. Now to work with the OS library, we'd have to launch the Jupyter Notebook. So we can either launch the Jupyter Notebook through Anaconda Navigator or we can launch it through the Anaconda prompt. So Anaconda Navigator basically provides you a GUI. So you can either use this or the Anaconda prompt. Now when you open the Anaconda Navigator, you have Jupyter Notebook inside this and all you have to do is click on launch. Now once you do that, you have your Jupyter Notebook right in front of you. So over here, you'd have to click on new and open up a new Python notebook. Now once you do that, you have a new page and over there you'll be performing different operations. So your first task would be to import the OS library. So you'll just type in import OS. Now if you want to have a glance at the current working directory, all you have to do is type in os.get current working directory and it will give you the current working directory. And if you want to create a new folder, then you'll type in os.make dirs and then you will give in the path. After that, you will give in the name of the directory which you want to create. So let's perform this. So again, I'll just type in Anaconda prompt over here. Now inside this, I'll type in Jupyter Notebook. Right, so now we see that we've launched the Jupyter Notebook over here. Now I'll click on new and I'll open up a new Python 3 notebook. So our first task was to import the OS module. So I'll type import OS and I've successfully imported this module. So as I stated in the PPT, the OS module is basically used to work with different operating system applications. So you can create different directories, you can open up new files, you can rename files and so on. So our first task over here is to have a glance at our current working directory. So I'll type in os.getcwd and I'll put in the parenthesis over here. Right, so this is my current working directory, C users Intellipaat. Now I want to make a new directory in my C drive. So this would be the command for that. So I'll type in os.make dirs and over here I'd have to give in the path. So I'll type in C:/ and I'll name the folder as, let's say, new folder. Let me click on run. Right, so now I've successfully created this folder. Now let me actually go to the C drive and see if this folder exists or not. So this is my C drive over here and I see that we have this folder with the name new folder. Now we'll go ahead and perform some more operations. So let's say I want to open a file which is present in my system. So to do that, I've got this command os.open and inside this I will give in the path of the file and then I'll give the name of the file. After that, I also have to give the extension of file, right? So this is a text file, so I'll type in file.txt. And over here, this is basically the flag. So over here, I'd basically be setting what sort of operation I want to do. So O_RDWR, it stands for read and write. So I've got different operations. So I can open this file in only either read format or write format or read write format. Now, after that, we set in another parameter over here, which is os.o_create. So this means that if a file with the name file.txt doesn't exist, then it'll automatically create this new file and then it'll open it up. And then we've got another operation. So if I want to have a glance at all of the contents which are present in a folder, then for that the command would be os.listdir and I will give in the path. So over here I want to have a glance at all of the contents which are present in the D drive. So I'll just give in D over here. So these are all of the contents which are present in the D drive. Right, so now I'd want to open this sparta.txt file using the OS module. So let me do that. So the command was os.open and inside this, as we saw, first we'd have to give in the path. So let me copy the path over here. I'll click on properties. I'll copy all of this and I'll paste it over here. You'd have to keep in mind that you'd have to give in / over here. So the path over here. So to separate all of these, you'd have to give in a /. Again, you'll give in a / over here and then you will give in the name of the file. So the name of the file is sparta.txt. After this, I'll give in the flag over here, which would be os.o_, it'll be read and write. And then I'll give in the pipe operator So over here, I'll just state if the file doesn't exist, then I'll tell the operating system to create it. So os.create, I'll click on run. Right, so we have successfully opened this file. Now I'd want to have a glance at all of the contents which are present in the C drive. So I'll type in os.list directory, and inside this I'd have to give in the path. So I'd want to have a glance at all of the contents which are present in the C drive. Right, so these are all of the folders or all of the contents which are present inside the C drive. Then I have a couple more commands over here. So this is the command to change the working directory. So over here, I am changing my working directory from D drive to my folder. So I just have to give in the path for this, and this is how I can change the current working directory. And then we can also change the name of a file. So let's say if the name of the file was oldfile.txt, then to rename it, I'll just give in newfile.txt over here. So let's perform both of these operations. So let me perform both of these operations over here. So I'll type in os.chdr, and inside this I'll set the working directory to just C drive, C:// right. I've changed the working directory. Now let me also check the current working directory now. Right, so now I've changed the working directory to C drive. Now let me go ahead and rename a file over here. So I'll type in rename. So over here this takes in two parameters. First is the path where the file is located and the name of the file. So I'd just rename this file over here Sparta. Right, so as we saw earlier, the name of the file was sparta.txt. Let me also remove this over here. Let me just put in a single quotation mark. Now after this, I'd have to rename this. So I'll copy this all again and I'll paste it over here. Now I'll change this to Sparta new. I'll click on run. Right, so now we see that we've got a new file over here. So initially it was sparta.txt. Now we've changed it to Sparta new. Right, so that was the OS module. So the OS module, we saw how can we create new directories and how can we change the names of some files. Now we'll go ahead and do some proper file handling in Python. So the IO module is the default module in Python that is used to perform file handling operations. And it contains functions that return a file object called handle. And this handle is then used to read from a file or write to a file. So this is the command to create a file object. So we'll be using this function from the IO module. So open, and this has two parameters. So this is the first parameter file, and over here we'll give in the path of the file or just the name of the file. After that we've got the mode. So over here this mode basically specifies the way we want to open a file. So we've got these different modes over here, R, R+, W and W+. So R basically stands for read only mode, right? So if we open a file in read only mode, then we can't edit it. So it's only read only mode and it starts from the beginning of the file. After that we've got R+, which stands for read and write mode. So over here the file pointer again starts at the beginning of the file, and with this we can read the file as well as write something in the file. Then we've got W, which stands for write only mode, and even this, the pointer starts at the beginning of the file and it starts to overwrite the existing file. Then we've got W+, which allows us to write and as well as read. Now this doesn't start from the beginning, but it actually starts at the end of the file, right? So we can start writing from the end of the file over here. So these are the different modes which we can open a file. Now these are the different methods from the IO module with which we can read from a file. So now let's say we've opened up a file. So open, and then I'll give in the path, and I'm opening this in read only mode. Now I'll store the file in this F1 instance over here. Now if I want to read the entire file, I'll just type in f1.read over here. So this would give me the entire file over here. Now instead of reading the entire file, let's say if I want to read only the first line over there, then what I'll do is I'll type in read line. So I'm storing this file object in this F1 instance over here. After that I'll type in f1.readline, and this would just give me the first line over here. So let me perform these two operations. Right, so I'll type in import IO over here. Let me load this up. Now I'd have to open the file. So open, I'll take the path. So I want to open up the same file, which is sparta.txt. Right, now I want to open this in read only mode. So I'll type in R over here. Right, so I've also given the board. Now let me click on run. Right, so I've created an instance of this file. Now let me go ahead and read the contents of this file. So I'll type in f1.read. So these are the 3 lines which are present in this file. This is Sparta, this is 300, and this is Intellipaat. So let me just verify this. I'll open up this file, right? So these are 3 lines. This is Sparta, this is 300, and this is Intellipaat. Now, as you see, all of these 3 lines are separated by /n. So over here, /n denotes a new line over here. Now, instead of reading all of these 3 lines, I want to read only the first line from this file. So the command for this would be os.readLine. Right, so now let me click on run. Right, so I've just read one line from this entire file. Now we'll see how to read a file line by line using for loop. So again, first we'd have to open up the file and save this file in an instance. So over here I'm saving this in F1. After that I'll start the for loop. So over here I'll create a new variable. So for line in F1, and this line stores every line which is present in this file over here. So it'll store the first line and then we are printing the first line. Now once that is done, it'll go back and then print the second line, and it'll go back and then print the third line, right? So this is what happens. Now after we print all of the lines, I'm just typing f1.close. So when I type f1.close, it'll just clear all of the buffers and close the file. So I'll just type in for line in f1, and over here I want to print f1, right? So let me start off by using the for loop. So I'll type in for line in f1, and I'd have to print each of the line. So I'll type print line, and I'd have to close the buffer. So f1 dot close. Let me close this. Now let me click on run. Right, so let me start off by using the for loop over here. So I'll type in for line in f1. So this is f1 and not s1. I'd have to print each of the lines. So I'll type in print line, and then I'd have to close the file. So I'll type in f1 dot close. Right, so let me run this. Right, so I've extracted each of these lines with the help of the for loop. So we've got this is Sparta, this is 300, and this is Intellipaat. Now let's see how can we write something to a file. So to write something to a file, we can use the write method. So again, we'd have to start off by opening the file, but this time we'll be opening this in write mode. So over here, I'll set mode is equal to W, and while writing, I also have to set the encoding type. So the encoding of this file is UTF-8, and what I'll do is I'll add 3 new lines over here. So I'll type in, this is the first line, this is the second line, and this is the third line, and these 3 would be added to this current file. Now instead of adding one single line, let's say if I wanted to add multiple lines over here. So for this, what I'd have to do is I'll create a list, and inside this list I'll separate these 3 items with the help of /n. So as we already know, this /n, it denotes a new line. Right, now after that we'll open the file, and over here we'll open this in the mode A+. So A+ stands for the append mode, and we'll write this entire list into the file over here. Now let's perform these operations. Right, so what I'll do is I'll copy the same command over here and paste it over here. So the file would be the same, and over here I'll set the mode to be equal to W. So W stands for write, and after this I'd have to set the encoding. So encoding would be equal to UTF-8. So I'll type in UTF-8 over here, and I'll click on run. Right, so I've successfully opened this file in write mode. Now I'd have to go ahead and write something into this. So I'll type in f1 dot write over here, and let me write something inside this. So let me add the first line over here. So the first line would be this is 1. I'll click on run. Then I'll type, let's say, f1 dot write, and I'll type this is 2. I'll click on run again. Then I'll type f1 dot write, and I'll add the line this is 3. Now let me go ahead and open the file. So this time I'll open the file in read only mode. So I'll set this mode to be equal to R, and I'll remove the encoding from over here. I'll click on run. Right, now I'd have to type in f1 dot read. Right, so this is what I have. This is 1, this is 2, and this is 3. Right, so I've successfully added these 3 elements into my file. Now as you see over here, my file initially had these 3 lines over here. This is Sparta, this is 300, and this is Intellipaat. Now when we use the write mode and we entered these 3 lines, this is 1, this is 2, and this is 3, what it did was it replaced these 3 lines with this. And this happened because the pointer starts at the beginning of the file. And when the pointer starts at the beginning of the file, all that which was there initially, that would be replaced. So let me go to the file now and see how it looks like, right? So I have a single line now. This is 1, this is 2, and this is 3, because the earlier thing was replaced. Now I'll go ahead and actually create a list over here. So I'll name this as L1 and I'll add some values over here. So let's say the first value is A. I'll add a new line after this. Then the second value is B. Again, I'll add a new line after this. And then I'll add a new value which is C. After that, I'll add a new line. Now I'll open this file in append mode. So this would be the same. The mode would be A plus. And I'd have to give the encoding again. So encoding would be UTF-8. Right. So this time I've opened the file in append mode. Now what I'll do is I will go ahead and add this. So f1 dot write lines, and inside this I'll just put in L1. Now I'll go ahead and open the file. Let's see what do we get. So I'm opening the file in read mode now. Now let me read what we have in this file. So now I have successfully added these 3 characters over here, A, B and C. So now let me open the file, right? So this was the first line. After that I added A, B and C. Alright guys, now let's see how can we work with Word document files. So we have this library with the name Python docx, and we can use this for creating and updating Microsoft Word documents. So to install this library, we'll again have to go to Anaconda prompt, and inside Anaconda prompt we'll given this command conda install -c conda forge python docx, right? So with the help of this command we'll be installing Python docx library. So once the installation is done, we'll go to either Anaconda prompt or Anaconda navigator and then launch the Jupyter notebook. So we'll open a new notebook over here, new Python notebook, and we'll type in import docx. So here you have to keep in mind that when importing the library, you'd have to type docx and not Python docx. So you'll type in import docx. So once you import the library, now let's see how can we create and update a Word document. So starting off, we'd have to create an instance of our Word document. So to create an instance, we'll invoke the document method. So we'll type in docx.document and we'll create an instance of the Word document. So I'm naming this instance as document. Now once we have this instance, we can add all of the content into our Word document. So I'll type in document.add heading, and with the help of this I can add a heading to my document, right? So over here I'm adding the heading. This is a 0 level heading. So here 0 indicates the level of the heading, right?
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers. We rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
So once we add the heading, now we are going ahead and adding a new paragraph. So here I'm typing document.add paragraph and I'm just writing this is a paragraph. And after that, if I want to add a page break, so we can use this method document.add page break. So we created an instance, and with the help of that instance, we added a heading and we also added a paragraph. Now it's time to save the document. So to save the document, we'll type in document.save, and inside this we'll give in the name by which we want to save the document. So I'm saying the document as document.docx, right? So this is how we can create a document. Now let's see how can we read a Word document. So to read a document, we'd have to start off by importing this document method from docx, and then we'll use this document method, and inside this we'll pass in the name of the document. So we'll pass in document.docx, and this is the file which we had just created earlier, and we'll save this in a new instance and name that to be doc. So once we have this instance over here, we'll use the for loop, and with the help of this for loop, will print all of the content inside this document. So I'm typing in for para and doc.paragraphs print para.text, right? So it will take in each paragraph over here and it will print each paragraph with the help of this for loop. Right, now let's go to Jupyter Notebook and actually perform this. So I'll start off by importing the library, which is docx. So I'll type in import docx. Now I'll go ahead and create an instance of this. So docx.document, and I'll name the instance as doc. So now that I have the instance, I can add the content into this. So I'll type in doc.add heading. Now let me add the heading. So I'll just say heading 1 over here, and then I'll add a couple of paragraphs. So this time doc.add paragraph, and inside this I'll type in p1, and then I'll add another paragraph. So I'll type in doc.add paragraph again, and I'll add p2 inside this. After this I'll add a page break. So I'll type in doc.add page break, and I'll click on run. Now after the page break I'll give another heading. So doc.add heading, and I'll give the heading as heading 2. So all of this is done. Now it's time to save this document. So I'd have to type in doc.save, and I'll give the name of the file. So I will save this as, let's say, my doc.docx. Right, so now I have successfully saved this file. Now it's time to read this document which I've just created. So I'd have to import document. So I'll type in from docx. I'd have to import document. Right, so now that I've imported this, so I'll just give in the name of the doc which I've just created. So my doc.docx, and I will store this in a new document again, and I will name this as d1. Right, so now I have created a new instance of the document which I had created earlier. Now I'll use the for loop. So for para in d1 dot paragraphs, and I'll just print this out. So print a para dot text. So now we have the content which is present in the document over here. Heading 1, para 2, and then we added a page break. After that we have the heading 2. Right, so this is how we can work with the docx module. Now let's head on to the natural language toolkit. So NLTK is one of the most widely used packages for the purpose of natural language processing. So NLTK provides multiple packages to perform different operations such as tokenization, POS tagging, named entity recognition, and sentiment analysis. Right? So NLTK provides very easy to work with modules, and with these modules, all of your work becomes much more organized and much more easier. Now again, let's see how can we install the NLTK package. So again, we'll have to go to Anaconda prompt, and we'll give this command inside Anaconda prompt over here. So we'll have to type in conda install -c Anaconda NLTK, and this is how we can install the NLTK package. Right, now once we install the NLTK library, we have something known as the NLTK corpora. Now you must be wondering what exactly is a corpora. So before understanding corpora, let's understand what is corpus. So a corpus is a huge collection of written texts, and a compilation of these corpuses is what is called as a corpora. Now NLTK provides this huge corpora for multiple purposes. So it has got all of these different corpuses pertaining to different domains, and we can use it to perform various NLP tasks. Right, now let's see how can we download this NLTK corpora. So once we install NLTK, we'll have to go to Jupyter Notebook and then type in import NLTK. And then after that, we just have to type in nltk.download. So this would give you a setup wizard. Now all you have to do is click on download, and this will install all of the corpuses which are present in NLTK. So this is how you can import a corpus from NLTK. So there's this corpus with the title names, and we are importing this corpus. So I'll just type in from nltk.corpus import names, and this just has a list of all of different words. So to have a glance at all of those words, I'll type in names.words. Right, now let me go to Jupyter Notebook and just show you how can we do this. Right, now let me start off by importing NLTK. So from nltk.corpus what I want is names. So this is basically the name of the corpus which we are importing. Right, now I've imported this corpus. Now I want to have a glance at the list of the names which are present. So I'll just type in names.words and I'll click on run. So this is the list of the names which is present inside this corpus. Right, so to do sentiment analysis with Twitter, we'd actually need a developer account. So we'll go to developer.twitter.com and over here this is my profile which is already there. I'll click on apps and then go ahead and create a new application. So we have this option to create an app, and if you guys want to create a new app, you'd have to click on this, fill up a few details and you'll have your new app ready. But then again, I have already created an app with this name over here, Sentiment 123 Demo. Now let me have a glance at the details, right? So this is my app and it contains these keys and tokens. So in our code, we would have to use these consumer API keys and access token secret. So you'd have to note down these values and then put inside your code. Alright, now let's go ahead and do some sentiment analysis. So first, we need this NumPy package, which would basically act as the API with Twitter. And then with the help of text blob, we can understand the sentiment of different tweets. So we'll import these two. First is NumPy, next is text blob. And then we'll go ahead and give the values of these four. Consumer key secret, access token and access token secret. So these are the same values. This is the API key, API secret key, access token and access token secret. And I've given the same values over here. After that, using NumPy.oauth handler, I would have to first give in the consumer key and the consumer key secret. And I'll store that in this object auth. Now, again, this auth object contains set access token. Now I'll give in the values of access token and access token secret. Now finally, I will send this object inside the NumPy.api. So this is how we are basically establishing the connection with Twitter. So we have given all of these four values and we are authenticating this API. And then finally, we can go ahead and give in the hashtag for which we'd have to find the sentiment. So let's say I want to find the sentiment for this word Avengers. So using this object API, I'll just type in api.search and it contains the keyword Avengers and I'll store this in the object public tweets. Now I'll start a for loop. So I will go through all of the tweets which are stored in public tweets and I'll start off by printing the first tweet. And then I'll pass the tweet.text as a parameter for this text blob function and I'll store the result in this analysis object. Now, this analysis object helps me to find out the polarity and the subjectivity of these tweets. It has these two things. One is polarity, next is subjectivity. So first, what we'll do is, we'll just check if the sentiment analysis.sentiment of 0. So basically, this is the first element inside this list. So if the value inside this is greater than 0. So we are basically checking if polarity is greater than 0. Then we'll just print that the sentiment of this tweet is positive. On the other hand, if the polarity of the sentiment is less than 0, then we'll print negative. And if it is not greater than 0, if it is not less than 0, then it basically means that it's equal to 0. So we'll just print that the tweet is neutral. Now let me go ahead and run this. So these are all of the tweets which contain the keyword Avengers. So this is our first tweet. We see that the polarity is 0.0, subjectivity is 0.0 and it is neutral. Next again, this is the tweet. Again, polarity is 0.0, subjectivity is 0.0 and then again it is neutral. So you see that for most of these, polarity, subjectivity are 0 and it is neutral over here. And for this case over here, polarity is 0.6. If the value of polarity is greater to +1, then it would mean that it is highly positive. Similarly, if the value of polarity is closer to -1, then it would mean that the sentiment of the tweet is very negative. And then what we have over here is subjectivity. So subjectivity basically tells us how subjective or how personal the tweet is. So we see this tweet that I just needed to share with everyone how Hertz is a truly amazing company. And for this, polarity is 0.6 and subjectivity is 0.9. And then again, for this statement over here, we see that polarity is 0.375, subjectivity is 4.7, and we see that it is positive. And then again, for this statement over here, polarity is 0.0, subjectivity is 0.0, and it is neutral. Right, guys? So this is how we can do sentiment analysis in Python. Consider yourself to be data scientist at a prestigious telecom company, and the name of that company is Neo. And they are facing a major problem, and that basically is their customers are churning out to other competitors. Now, you as a data scientist at that particular company have to make sure to stop this churning out, and also have to find out the reasons why customers are churning out to other companies. Right, so this is the problem statement, and what you're basically going to do is a bit of data manipulation, data visualization operations, and then you'll go ahead and build the ML algorithms on top of this data set. So you'll start off with the linear regression algorithm, and then you'll build the logistic regression, decision tree, and random forest algorithms. All right, and we'll be working with this customer churn data set. So this is our data set which comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, dependents, and so on, right? So yeah, so this is our first task, data manipulation. And to do this, let's go ahead and actually import all of our libraries. So I'll just type in import pandas as PD, and then I'll also load the NumPy library. So I'll type in import NumPy as NP. I'd also need the Matplotalib library. So I'll type in from Matplotalib import pyplot as PLT. So these are all of my required libraries. I'll just wait till these libraries are loaded. Right, this is done. Now I'll also go ahead and load up my customer churn data frame, and I'll store it into an object and name that object to be equal to customer churn. I'll just use pd.read_csv, and inside this I will give in the name of the data frame, which is customer churn.csv. Right, so I have successfully loaded the file and I've stored it into a new object, and also I've named that new object to be equal to customer churn. Now I'll go ahead and have a glance at the head of this. So customer churn dot head, and this is the data set on which we'll be implementing all of the operations. So this is just the unique customer ID. This column gender tells us about the gender of the customer, whether the customer is male or female. The senior citizen column tells us whether the customer is a senior citizen or not. So if it's 0, then the customer is not a senior citizen. If it's 1, then the customer is a senior citizen. And then this tells us if the customer has a partner or not. This tells us if the customer has dependents or not. This is the tenure of the customer in months, right? So 1 month, 34 months, 2 months, and so on. This tells us if the customer has phone service or not. Does the customer have multiple lines? And this is the type of internet service used, and then whether the customer has online security, whether he has device protection, tech support, streaming TV, streaming movies, and so on. And then this column is for contract. So this just tells you the contract type of the customer. So the contract type of the customer could either be month to month, 1 year, or 2 year, and there's a type of billing, whether it is paperless or not. After this, we have the type of payment method. So the type of payment method could be these: electronic check, mail check, bank transfer, and so on. And then these are the monthly charges and total charges incurred by the customer. Right. So now let's start off with our data manipulation tasks. So this is our very simple task. We just have to extract some individual columns from the entire data frame. We'll have to extract the 5th column and store it in customer 5. So let me do that. I'll type in the name of the data frame first, which is customer churn, and I would use .ilog. I would need all of the rows, and I would need the 5th column since the indexing starts from 0. So 0, 1, 2, 3, and 4, right? So this would be my 5th column over here. And I will store this in, let's say, C_5. And I'll have a glance at the head of this, C_5.head. Right, so we have successfully extracted the 5th column from this entire data frame, and this is the head of it. Similarly, we'd have to extract the 15th column and store it in customer 15. Right, so if it's the 15th column, then the index number would be 14, because again, the indexing starts from 0. Right, I'll store this in C_15, and I'll also make this to be C_15. I'll click on run, right? So this is the streaming movies column and I get the same thing over here. This is column number 15 and I've extracted only this particular column from the entire data frame, right? This was basic extraction of columns from the entire data frame. After that, we'd have to do data extraction on the basis of a condition. We'll have to extract all the male senior citizens whose payment method is electronic check. Right. So there are three conditions over here. The first condition is the gender of the customer needs to be male. Second condition is senior citizen, the value of senior citizen needs to be equal to 1. And the third condition is the payment method needs to be equal to electronic check. So I'll give in all of these three conditions over here. I'll start off by giving the first condition, customer churn. I'll type in gender and the gender needs to be equal to male, right? I'll cut this and paste this inside this. Of this, I'll use the AND operator and then given the second condition. So the second condition would go something like this, customer churn. After this, we'd have to set the senior citizen value. Right, so senior citizen, this needs to be equal to 1. And then I'll go ahead and give in the third condition. So over here, the third condition, this is for the payment method column. So the payment method needs to be equal to electronic check. Right. So I have all of my three conditions over here. I'll just paste a cell below. Now, what I'll do is I will copy all of these three conditions and I will paste them inside this. And I will store it into a new object and name that object to be crandom, right? Now I will print the head of this, crandom.head. So we see that so if you have a glance at this gender column, then you'll notice that all of the values are male. Similarly, if you have a glance at the senior citizen column, then all of these values are 1. Similarly, I'll go to the payment method column, then you'll notice that all of these values are electronic check. So I've given three conditions over here and all of these conditions have been satisfied. So next up, we'd have to extract all of those customers whose tenure is greater than 70 or their monthly charges is greater than $100. Okay, again, we'll do the same thing. Customer churn, tenure needs to be greater than 70. I'll put this up inside this. Now, what you need to notice over here is we are using the OR operator. So it's either the first condition or the second condition, right? So if one of these conditions is true, then we'll get that particular record. So again, customer churn, and this time it's the monthly charges. So the monthly charges have to be greater than 100. These are the two conditions. So either the tenure of the customer needs to be greater than 70 months or the monthly charges of the customer needs to be greater than $100. Again, I'll insert a cell below and all I'll do is cut this and paste it inside this. Right. And I will store this in again crandom. Now let me again print the head of this crandom.head. Right, now I'll head on to the tenure column. Now you see that none of the tenure or none of the values of the tenure over here is greater than 70. But if I go to the monthly charges column, then you'll notice that the monthly charges are greater than 100. So it's either or. So one of these conditions has to be true. And in this case, we see that the second condition is true over here, right? So if either of the condition is true, then we'll get that entire record. After this, we'd have to extract all those customers whose contract is of 2 years, payment method is mail check, and value of churn is ES. Right. I'll again copy this, paste this over here, let me delete this from this. Right, so we have these conditions over here. So we'll have to extract those customers where contract is of 2 years, payment method is mail check, and churn is equal to yes. So let me put in all of these conditions over here. First is contract, and this needs to be equal to 2 years. So let me just check, how is it? Contract is of 2 year, right? 2 space year. After that, it's the second condition, and over here the payment method needs to be equal to mailed check. Again, I'll put in the double equal to operator, and I'll give in the value, and the value is equal to mail check, and then I'll give in the final condition over here. So customer churn, and this time the churn needs to be equal to yes. Right, so I've given all of these three conditions and I've separated them using the AND operator. Again, I will store this in C underscore random. Let me print this out, C underscore random. So we see that there are just 3 records, or there are just 3 customers who satisfy all of these 3 conditions. So let me have a look at the contract of this, right? So contract is of 2 years for all of these 3 customers. Next is the payment method, and again payment method is mail check and churn. All of these values are yes, right? So out of all of those 7,000 rows, only there are 3 rows which satisfy these 3 conditions. Next, this is a question on random sampling. So we just have to extract 333 random records from the entire data frame. And to do this, we'll be using the sample function. So I'll type in customer churn and I'll use the sample method over here. And inside this, what I'll do is I'll give the value of the number of records which I want to sample. So I want 333 records. I'll store this in C underscore 333. Let me print out the head of it. Right, so now what I'll do is, so whenever I run this, every time I'll get a different sample of 333 records. I'll run this again, right? So if you have a glance over here, so all of these values would be changing, the customer IDs would be changing, the indexes would be changing, right? So keep a glance or have a glance at these row IDs indexes over here, right? So again, if you have a glance at this, the row IDs are changing. So this is random sampling. I'm randomly sampling 333 records from this entire data frame over here, and I'm doing that with the help of the sample method. Right, and then this is the final operation when it comes to data manipulation. So I'd have to get the count of different levels from the churn column. So if I want to get the count of the different levels present in a categorical column, I have the value counts method. So first I'll give in the name of the data frame, which is customer churn. After that, I'll give in the name of the column, which is churn, and then I'll just type in value counts, right? So this is it. So let me just wait till I get the result, right? So we see that no, so the number of customers who will not be churning out is 5,174, and the number of customers who will be churning out is 1,869. So you can do the same thing for other categorical columns as well. So let's say if I want to get the count values or the number of counts of different levels for, let's say, the contract column, I'll just change the name of the column over here. So I'll put it to be equal to contract, right? So there are 3,875 customers whose contract type is of month to month. There are 1,695 customers whose contract is of 2 years, and there are 1,473 customers whose contract is of 1 year. Right, so these were some basic data manipulation operations. After that, we'll head on to data visualization. All right. So here we'll have to create a simple bar plot for the internet service column. And Yeah, we'd have to set the x-axis label to categories of internet service, y-axis label to count of categories, the title of the plot, distribution of internet service, and the color of the bars need to be equal to orange. Right. So I'll just type in plt dot bar over here. Now I'll insert another cell over here. Now what I'll actually do is, so this basically takes in two parameters first. So the first parameter is the names of all of the bars, and the second parameter is the values for those bars, right? So the names of the bars would be coming from the internet service column. So internet service, and I actually want the value counts of this value counts, and from this I don't want the values, I just need the keys. And again I'd have to convert them into a list. So I'll use toList over here. Now I'll click on run. Let's see what do we get, right? So these are the three levels present in the internet service column. So from this internet service column, what I've done is I've used the value counts method. So this value counts method has two things, keys and values. Now I don't want the values as such, I just want the keys, and I'll take these keys and I'll convert these keys into a list, right? So this is the list of the names present in this internet service column. Now I'll cut this and paste it over here, and this would be my first parameter, and my second parameter would be all of the values. And if I want all of the values, I'll just remove the method keys from there, right? So this over here would give me all of the values present with respect to this internet service column, right? So fiber optic, or in other words, the number of customers whose internet service is fiber optic is 3096. Number of customers whose internet service is DSL is 2421. And number of customers who don't avail the internet service are 1526. Right? Now again, I'll cut this and I'll paste it over here. Now let me print this out. So this is my basic bar plot over here, right? So this is my bar plot. On the x-axis, I have the names representing these bars over here, right? So this bar is for all of the customers whose internet service is fiber optic. This is for those customers whose internet service is DSL, and this is for those customers who are not availing the internet service. And these are their counts over here, present on the y-axis. Now, we have to do some other things over here. I had to change the color of the bars. So the color of the bars was supposed to be set to orange. And for this, I have the color parameter, and I'll just set it to be equal to orange. I'll run this again, right? So we have successfully changed the color of these bars over here. Now I'd have to set the x-axis label and the y-axis label. So I'll just type in plt.xlabel, and the x label needs to be equal to categories of internet service. Let me type that down. Categories of internet service. After that, I would need to put in the label for the y-axis. So this would be plt.ylabel, and I'll just put it to be equal to count. And then finally, I'd have to give in the title. So plt.title, and I'll set the title over here. And the title needs to be equal to distribution of internet service. Let me type that out. Distribution of internet service. I'll click on run, right? So this is our final bar plot, which gives us the distribution of internet service, and the x-axis label is categories of internet service, and the y-axis label is count, right? So this is how we can create a simple bar plot, and all of this. So these are the basic steps behind before you go ahead and build all of your machine learning algorithms. So the pre-processing, the data pre-processing part is always the main part of your data science life cycle. So this is where you properly comprehend your data set. This is where you understand the structure of the data set. You understand the correlation between all of the columns, the correlation between the dependent variable and the independent variable. So by manipulating the data set and visualizing the structure of the data set, This is where you understand all of the patterns in the dataset and you get insights from the dataset. Right, so next up we have to build a histogram for the tenure column. So again, it'll be a similar operation, plt.hist, and I'd have to build a histogram for the tenure column. So it'll be customer churn tenure, and I'd have to set the number of bins to be equal to 30, and I'd have to set the color to be equal to green. So I'll just type in color equals green over here. So this is our histogram, and this gives us the distribution of the tenure of the customers. So so if you look at it closely, so this is basically the count over here, right? So there are around 800 odd customers whose tenure is not even 1 month. So they are churning out before they even complete 1 month. And again, there's a huge peak over here. So there are around more than 600 customers whose tenure is 70 months or more than 70 months. And then rest is pretty much the same, right? So the average customer, this is the normal range of the customer. So it's between 200 to 400. And the average tenure of the customer, you can say, would be somewhere between 20 months to 50 months or 60 months, right? And this is where you have the peak. So you have the peak at the starting and you have the peak at the ending. Again, let's go ahead and add the title. So it'll be just plt dot title over here. And the title of the plot needs to be equal to distribution of tenure. I'll do that. Alright, so I have created this plot, and this is the title of the plot, which is distribution of tenure. So we've made a bar plot, we've made a histogram. Now you guys also need to understand the difference between a bar plot and a histogram. So a bar plot is normally used for all of the categorical columns. So whenever you want to understand the distribution of categorical columns, that is when you'll go with a bar plot. And when you want to understand the distribution of a continuous numerical column, that is when you'll go with a histogram. Right, so next up, we'd have to create a scatter plot between monthly charges and tenure. So tenure is on x-axis and monthly charges is on y-axis. So plt dot scatter, x-axis would be tenure, so customer churn, tenure, and then I'll set in the column for the y-axis. This will be customer churn, and this will be equal to monthly charges. Let me just run this, right? So this is what we get over here. Now let me also set in the labels for this. So plt dot x label, and this would be equal to tenure. Let me type in tenure over here. Similarly, I'll also set the y label over here. So this will be plt dot y label, and this would be equal to monthly charges. Right, so now we also get the corresponding x and y axis labels. After this, I'll also go ahead and set the title. So it'll be plt dot title, and this would be monthly charges versus tenure. Monthly charges versus tenure. Right, so this is our final scatter plot where we have the x-axis and y-axis labels, and this is the title, which is monthly charges versus tenure. Right. And finally, we'd have to also build a box plot between the tenure column and the contract column. So tenure needs to be on the y-axis and contract needs to be on the x-axis. For this, I'll just type in customer churn dot box plot, and so now I'll set in this to be equal to customer churn contract, and after this I have the column to be equal to customer churn, and this needs to be equal to tenure. Let's see what is the error over here. Columns not found. So let me actually remove this from over here and let's see what happens. Alright, so now we get the result. So we had actually given the name of the data frame initially itself, so it was customer churn dot box plot. And now all you have to do is assign the contract onto the x-axis. So now when I said by equals to contract, what is happening is I'll have one box plot each for the different levels of the contract column. So I have one box plot for the month to month level. I have another box plot for the 1 year level and another box plot for the 2 year level. And over here, the y-axis, this is being determined by the tenure column, right? So this over here, 0 to 70, this is the tenure of the customer. And what we understand from this box plot over here is, so if the contract of the customer is of 2 years, then most probably the median tenure of the customer is very high. So if the contract of the customer is of 2 years, then his tenure or median tenure would be around 65 months. Similarly, if the contract of the customer is 1 year, then the median tenure of the customer would be around 45 months. And then if the contract of the customer is month to month, then the median tenure of the customer would be around 15 odd months. Right, so these were all of the examples of visualization. Now it's finally time to head on to machine learning. Right, so this was your data pre-processing part, where you had understood the structure of the data. You had learned how to extract individual columns, and after that you learned how to visualize the data and get some interesting insights from the structure of the data. We'll start off with our first machine learning algorithm, which would be linear regression over here. And linear regression, as you already know, so over here the dependent variable would be a numerical column, and you're basically trying to understand how does one variable change with respect to another variable. And over here we'd have to build a simple linear model where our dependent variable is monthly charges and the independent variable is equal to tenure, right? So, or in other words, we are basically trying to understand how does monthly charges vary with respect to tenure. So monthly charges, dependent variable, tenure is the independent variable. And these are all of the subsets when it comes to this linear model. So we'll start off by dividing the data set into 70-30 split, and then we'll build the model on the train set, pick the values on the test set. After that, we'd have to find out the root mean square error, and yep, we'd have to print out that root mean square error. So let me go ahead and import the linear regression model from sklearn. So I'll type in from sklearn import linear model. After this, I'll type in from sklearn dot linear model import I need linear regression, right? So these are my two basic libraries. So I needed linear model, I needed linear regression. Now I would also require the train test split. So I'll type in from sklearn dot model selection import train test split, right? So this train test split method would help me to divide my dataset into training and testing sets. So now it's time to divide my data into training and testing sets. So before that, I'd have to get my target and the features, or in other words, I'll have to separate my dependent variable and the independent variable. So monthly charges is the dependent variable. So what I'll do is y equals, and I'll extract only the monthly charges column, and I will store it in a new variable and name that variable to be equal to y. Similarly, I'll only extract the tenure column, right? So I'm extracting the monthly charges column and I'm storing it into a new object, naming that object to be equal to y. Similarly, I'm extracting only the tenure column and I'm storing that column into x. Run columns, customer churn. What seems to be the problem over here? monthly charges. Let me put it to be capital C over here. Right. Now let me print out the head of these two, y dot head and x dot head. Right. So these are the values from monthly charges column and these are the values from the tenure column. Now let me go ahead and divide these two into training and testing sets. So I'll use in train test split. I'll pass in x as the first parameter. So all of the features would be which are stored in x go as the first parameter. After that, I'd have to give in the target labels, and the target labels are which are basically my monthly charges, which are stored in y. And then finally, I'd have to give in the test size. So let me check what was the test size. So the test size was supposed to be 0.70. And then I'll also set a random state. So if I want to use these values again, I can just set the random state to be equal to the same value which I'm giving over here. This is smallest over here, right? So this test size 0.70 basically means that 30% of the records would go into the testing set. Oh, this has to be 0.30. Sorry for that. Yeah. So 30% of the records would go into the test set, and 70%, the rest 70% of the records would go into the training set. Now I'll be getting 4 results over here, and those 4 results are X train, Y train, X test, and Y test. These are actually the labels which we conventionally use. I'll explain what these are exactly. X train, Y train, and then we have so this would actually be X test first, X train, X test, Y train, and Y test. So over here, X train represents all of all of those values of your features which are present in the training set. X test represents all of the features which are present in the test set. Y train represents all of the dependent values which are present in the train set, and Y test represents all of the dependent values which are present in the test set. And whenever we are building a model, we'll build that model on top of the train set, right? So we'll build the model on top of X train and Y train. Let me also show you the shape of all of these. So X train dot shape. Let me do the same for the rest. X train dot shape. I'll make this to be Y train. I'll make this to be X test. And I'll make this to be Y test. Right. So X train, Y train. So the training set has these many records, and the testing set has these many records over here, right? So these are all of the features which are present in the training set, and these are all of the features which are present in the. Sorry, these are all the features of your dependent variables, and these are all of the features of the independent variables, and these are all of the target values when it comes to the test set, and these are all of the target values when it comes to the your dependent variables. All right. So now that we have X train, Y train, X test, and Y test, then let's go ahead and build a model on top of the training data. Now I will go ahead and create an. So normally your training data would be bigger because so let's say your splits are either 70-30, 65-30, or 80-20. Because the more data you give for training, that is better. But then again, you can't give out your entire data for the training set, right? So the purpose of training your model is to make sure that your model learns the underlying patterns of that data. And once the learning is done, you'd have to also test how well the learning is done, right? And to test, you'd also need a sample space for that test set. So consider this simple case. So let's say you're giving an exam, but for that exam, let's say if you got 100 exercises. So your syllabus comprises of all of the 100 exercises, and you'd have to learn all of those 100 exercises. But when it comes to your test, it will have only 10 exercises from all of those 100 exercises, right? So the training needs to be done, but then again, the test space, it needs to be completely new, which is not learned by the model, during the training phase, right? That is why the training set has to be completely different and the test set has to be completely different. And the division of training and testing set is done to make sure that overfitting doesn't happen. And when overfitting happens, the problem is this model will perform well on this particular data set, but when a new data set comes in, it'll miserably fail. Right? So this is the reason why we divide the data into training and testing set. Right. So now let me go ahead and create an instance of the linear regression model, and I'll name that to be regressor. So I've created an instance of linear regression over here, and I'll go ahead and fit the model on top of the training set. So it'll be X train and Y train. Right, so I've fit the model on top of the training set. Now it's time to predict the values. So it'll be regressor dot predict, and I'll be predicting the values on top of the X test. And I will store this in, let's say, ypred. Now I've fit the model on top of the training set, and I've also predicted the values on top of the test set. Now I'd have to know how well the prediction has been done, and for this, when it comes to linear regression, we have something known as the root mean square error. So the lower the value of root mean square error, the better your model. And again, we have an inbuilt method to calculate the root mean square error. So I just have to import sklearn.metrics, and from sklearn.metrics I'd be importing mean square error. Now after this, so mean squared error, what we actually want is root mean squared error. So I would need the np dot square root, and let me use the mean squared error, and this takes in two parameters. First parameter comprised of the actual values which are present in y test, and second parameter are the predicted values which are present in ypred. So I will cut this and let me ease this to be in this over here. Right, so we get a root mean squared error value of 29.39. Right, so now let's say if we build some other model with some other independent variables. Now we'll go ahead and build the model, and we'll also predict the values. Now after predicting the values, we'll also have to calculate the root mean square error. So this root mean square error is actually relative. So let's say if there is some other model, let's say model 2, and if the root mean square error of that model 2 is, let's say, 39, then this model would be better than the second model. Similarly, if there's, let's say, model 3 whose root mean square error is 19, then that model 3 would be better than this model which you built over here. So here we are predicting the monthly charges values. That is exactly right. So let me actually show you that. So let's see, I'll put in ypred, and let's say I'll have a glance at the first 5 values, right? So these are the monthly charges predicted. Let me also show you y test, then 5, right? So these are the actual values and these are the predicted values over here. Right. So this is not exactly dependent on the churn of the customer. So what we are doing is we are building an entire data science lifecycle process. So over here, we are trying to understand the relationship between the tenure of the customer and the monthly charges of the customer, right? So over here, what we are basically trying to understand is, let's say if the tenure of the customer is at around 10 months, what would be his monthly charges? Again, if the tenure of the customer is 30 months, what would be his monthly charges? Similarly, if the tenure of the customer is 70 months, then what would be his monthly charges? So this is what we are trying to understand over here, right? So this time we'd have to build a logistic regression model where dependent variable is churn and independent variables are tenure and monthly charges. Again, I do the same thing. Let me actually copy these two. So this is what we did over here, Aditya, right? So this is where we went ahead and predicted the values, didn't we? Right? So I have divided my data set into training and testing set, and over here I am fitting the model only on the train set, right? So training is happening on the training set, or the model is learning from the train set, and we are predicting the values on the test set. So this model, this linear regression model, has not yet seen all of the records present in the test set. It has only learned from the values which are present in the training set. So we'll go ahead and build the linear regression model now. Customer churn. Let me also put in Y. I'll do the same thing. So in the logistic regression model, our independent variable is monthly charges. Let me put monthly charges over here, and the logistic regression, the dependent variable is churn. So I have extracted or I have got my features and my target over here. So features are basically my monthly charges and my target is present in the churn column. And I'd want to understand if the customer would churn or not on the basis of the monthly charges of the customer, right? So I've done this, and the rest of the process would be the same over here. I'll go ahead and divide this data frame into train and test, right? So this is 65-35 ratio this time. So I'll set it to be 35. So this time 35% of the records would be present in the test set, and the rest 65% of the records would be present in the train set. And I'm storing all of those into xtrain, xtest, ytrain, and ytest. Right. After this, I'd have to import the logistic regression model. So from sklearn dot linear model, I'd have to import the logistic regression model, and I'd have to create an instance of this. So I'll name this to be equal to log model. Right, so I have created an instance of this, and I'll go ahead and fit the model on top of the training set. Right, the entire process when it comes to implementing this is pretty much the same, right? So Python makes it extremely easy. The sklearn library makes it extremely easy. All you have to do is take in the data, find out your independent variables and your dependent variable, and then go ahead and divide those target and features into training and testing set, build the model on top of the train set, and then break the values on top of the test set, and then you will find out the metrics. So for classification, it's confusion metrics and your normal accuracy score, and for linear regression, it could be either root mean square error, or moving averages error. So log model dot fit, and I will fit this model on top of the training set again. So xtrain and ytrain, right? So I have fit the model. Yes, we can also have multiple independent variables, Sharadata. So again, so if we have a single independent variable, then that's that's a simple model. So when it comes to simple linear regression, we have a single independent variable. When it comes to multiple linear regression, you'll have multiple independent variables, right? So this basically means that we are trying to understand how does our dependent variable change with respect to multiple independent variables over there. And so again, consider this equation. So linear regression equation is based on this. Let me actually open Notepad over here, right? So y equals, let's say, x1 plus x2 plus x3 plus x4. So what happens in a simple linear regression is you just have one independent variable, which would be x1. What happens in multiple linear regression is you have multiple independent variables, which are x2, x3, x4, and so on, right? And you're trying to understand how does y vary with respect to all of these independent variables. That's pretty much it. Right, so let's proceed with this. We have built the model on top of the training set. Now let's go ahead and predict the values on top of the test set. So it'll be log model dot predict. So here we change the value of x, and no, we are not changing the value of x. We have multiple x values over here, right? So this becomes mx1 plus m2x2 plus m3x3 plus m4x4 and so on. We have multiple independent variables, and you are trying to understand how does y vary with those multiple independent variables. So log model dot predict, and I want to predict my values on top of the test set, and I'll store this in again ypred. Right, so we have predicted the values now. Right, so when it comes to a classification model, we can use the confusion matrix, right? So let me import the confusion matrix. So from sklearn.matrix, I will import the confusion matrix, also the accuracy score. Now let me find out both of this. I'll pass in the actual values and the predicted values. Actual values are present in ytest and predicted values are present in ypred. Similarly, accuracy score, I'll do the same thing. Ytest and ypred. Right, so this is our confusion matrix and this is the accuracy, right? So to get the accuracy, what you'll basically do is you'll divide the left diagonal with all of the values. So left diagonal represents all of your correctly predicted classifications. So this comprises of all of your true positives, right? So this part over here, this is all of your true positives and this is all of your true negatives, right? So when you divide this with the entire sample space, that is when you will get the accuracy. So let me do that. So that'll be 1815 divided by 1815 plus 651, and I get the same accuracy, which is 73.60, right? So I get an accuracy of 73% for the model which I've built. Now I'd have to build a multiple logistic regression model, or the dependent variable is the same and the independent variables are tenure and monthly charges. So now we have two independent variables, so I'll make the changes here itself, right? So Charu, the question which you're asking, what if we had multiple independent variables, right? So over here we have two independent variables. So this time the independent variables are monthly charges and tenure, and I'm trying to understand whether the customer would churn or not on the basis of these two columns, which are monthly charges and tenure, right? So X now would comprise of these features and Y is the same, and the ratio is 80-20. So I'll change the test size to be equal to 20 over here. I'll go ahead and fit the model. It's the same. Again, I'll predict the values is the same, right? So I build the model, I predicted the values. The only difference which I made over here is I have two independent variables this time instead of a single independent variable, right? Predicting the values. After that, I'll import confusion matrix and accuracy score, right? Now over here, again, I'm calculating the confusion matrix and this time I get an accuracy of 77.50, right? So this time it'll be 935 plus 157 divided by 935 plus 157 plus 106 plus 211, right? So we get an accuracy of 77.50. So this left diagonal are all of the values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. So this was logistic regression, and then we've got two more machine learning algorithms left, which are decision tree and random forest. So let's build these two. Right, so for decision tree, dependent variable is the same, which is churn, and independent variable is tenure. Right, so let me manually do this. X is customer churn, and the independent variable is tenure. Let me also extract the dependent variable. So the dependent variable would be churn. You have to make sure that you put in the spellings correct, and also you have to take care of the small caps and the capital letters over here. Right, now I will go ahead and also import the decision tree classifier. So from sklearn dot tree, I'll be importing the decision tree classifier. Now I'll go ahead and divide this data frame into train and test. So it'll be the same process. Let me copy this. Let me paste it over here. So the split is 80-20, which is what we are doing over here, right? So this is our feature, this is our target labels, and we have divided the dataset into training and testing set. Now let me go ahead and create an instance of this decision tree classifier. I'll name this instance to be, let's say, my tree. Right, and I'll go ahead and fit the model on top of the training set. So my tree dot fit, this takes in two parameters, which are xtrain and ytrain. I fit the model. Now it's time to predict the values. My tree dot predict, and I'll be predicting on top of the x test. Now I'll import the metrics. Right, so let me calculate the confusion metrics and also the accuracy score. Confusion metrics, so I'll actually have to store this in a object first. Again, I'll be storing this into ypred. Let me run the cell again, and this again takes in two parameters. First parameter is all of the actual values which are present in ytest, and all of the predicted values which are present in ypred. So this is our confusion metrics. Now let me calculate the accuracy, which would be 965 plus 87 divided by 965 plus 87 plus 281 plus 76. Right, so for this decision tree model, we get an accuracy of 74%. Right, so the process is entirely the same, guys. Right, what we are doing is, again, at the risk of being redundant, so what we are basically doing is finding out our features and target variable. After that, we are dividing the features and target into training and testing split, and then we'll go ahead and build the model on top of the train data, and then we'll predict the values on top of the test data. Once the prediction is done, we'll calculate the accuracy to find out how well our model has learned. Right, so in the entire data science life cycle, our most important part is the data processing part. Right, so because to the model building the, so it depends on your problem statement, Aditya. Right, so let's say if your dependence on your it depends on your problem statement and what exactly you're trying to find out. So let's say if your dependent variable is a continuous, if it's a continuous variable, if it's a continuous numerical, then you'll go with linear regression. And if you want, if you have multiple categories, right? So if you have multiple categories, then you'll go with either decision tree or random forest. So when it comes to logistic regression, it is a binary classifier. So let's say if you have just two labels in your dependent variable, like this case over here, right? So this is where you'll go with logistic regression. But then again, if you have multiple categories, or if it's a multi-classification problem, then you'll most probably go with decision tree and random forest. And again, when you compare decision tree and random forest, random forest is always better than decision tree because random forest is an ensemble model. So again, through your course, you would have learned that a random forest is nothing but an ensemble of decision trees. And the accuracy or the prediction given by a random forest is better than a decision tree. So that you can actually take for granted, right? So whatever accuracy a decision tree gives, the accuracy given by a random forest is better. So just to verify that, let me actually go ahead and build a random forest model on this same data over here, right? So we'll take the same X and Y values. No, so again, problem statement was different, Aditya. So linear regression we use to understand how does monthly charges vary with tenure. But the other algorithms which we've built, that was to understand how does churn vary with other factors, right? So over there, monthly charges was a numerical column, but churn is a categorical column. So we can compare logistic regression and decision tree, right? So let's say if we compare logistic regression and decision tree, right? So logistic regression gives us an accuracy of 77%. Yes, right. So logistic regression till now, yes, has given us the best accuracy, right? Right. So now finally, we'll also go ahead and build an ensemble model, which is random forest. So let's actually compare the accuracy given by this decision tree and the random forest. So from sklearn.ensemble, I'll import the random forest classifier and I'll create an instance of this. Maybe I'll name this as RF and I'll just create an instance. Right. And I'll go ahead and with the model on top of X train and Y train. X train and Y train I fit the model. Now it's finally time to predict the value. So rf dot predict, and I am predicting the values on top of the X test. Let me build the confusion matrix over here. Right, now let me check the accuracy. So I'll just type in accuracy score and I'll pass in y test and y pred. Y test, y pred. So we get an accuracy of 74.66 and it's 74.66, right? So there's not much of a difference when you compare decision tree and random forest over here, right? So we've got the same values, right? But normally in general, if you're building a random forest model, so you'll either get a better accuracy or you'll get the same accuracy, right? So this is your normal entire data science life cycle. So you'll start off with the data pre-processing part, data exploration part, where you will understand the structure of the data set. You'll visualize the data set and understand whatever is happening underneath it. Right after that, once you understand and comprehend your data properly, that is when you'll go ahead and build your model. Again, when it comes to building your model, you will sort of follow the same procedure. You'll find out your independent variables and the dependent variable. Then you'll go ahead and divide those two into your training and testing set. You'll build the model on top of the training set, and then you'll break the values on top of the test set, and finally you'll calculate the accuracy. Right? So here, this is pretty much it for today's session, right? So this is your entire end-to-end project on the customer churn dataset, which comprises of data manipulation, data visualization, and implementing all of the machine learning algorithms.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer and also what should be taught to our trainees so that we can make them a better programmer and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
REST APIs are quite useful and Python is quite easy to use when we're trying to build REST APIs. So in this session, we'll take a look at how to combine your knowledge of Python and web applications and how to deliver the data that you want to deliver via a web service or a REST API. And in this session, we'll take a look at what REST APIs are, what are APIs, how do you use REST APIs, and then we'll bring a quick demo in which we'll be using the Flask web servers to build a web API using Python. So without further ado, let's start. But before we begin, if you have any questions, then please do ask in the question section. And for those of you who are joining via YouTube, there's a link in the chat box that you can click to join this as a webinar, and then you can ask me questions in real time so that I can answer them. So let's take a look at the agenda for this session. So in this session, we'll take a look at what are data types. Then we'll take, okay, so this is. So we'll take a look at APIs first. We'll take a look at what are APIs. Let's take a look at what APIs are. So an API stands for an application programming interface. So in case you've ever wondered how two applications interact with each other, or how two applications can connect to each other and then can pass messages, then APIs are the way that we do it. So in case you've ever logged into a website and they give you the option to log in via your Google account or Facebook account, you might be wondering how they do that. Do they get the access to the Facebook's database servers and use those credentials to then log into the Facebook's databases and then authenticate you? That's not really a secure way to do it, but a more secure way to do it is via APIs. So that's why we use APIs to expose certain endpoints or certain procedures that other programs or applications can use to talk to us, to describe to our application what data they want, what applications or what processes they want to perform. This API transaction or API communication also allows for a lot of other kinds of applications like cloud computing applications, in which you are basically offloading a lot of your computations to cloud computing. And this is also something that is done via an API. So APIs are quite prevalent, but a particular type of API is called a REST API. So what are REST APIs? Well, when you take a look at an API, you could be many kinds of APIs, but if you're looking at a web API, then it's most probably a REST API. So REST API is basically a standard. It's an architectural style. It's how you define your URLs so that the person who's trying to get something from your API can describe the best way that he or she can the data that they want. And then our APIs respond to those requests. So these requests work on URL parameters and methods. So to give you a quick introduction, if you've ever worked with HTTP, which is the protocol that the internet uses, there are several methods that you can use. A method is basically just the intention of your request. So for instance, if you wish to get some data, if you wish to get data from a web API, then you use the GET request or the GET method, as is shown in the image below. You use the POST request to submit some data to the web API so that you can save it. The GET request with a ID or a unique identifier gets you a particular record of that. So for instance, if I have a web API that is serving up user information, then I can just tell it to get me all the users or save a user to my database. Or if I give it a particular ID, then my API will check in my database to see if that ID belongs to a particular user If it does, then I will send back that user. Otherwise, I'll send an empty response. Similarly, if you want to update the information that the person has given, you can use a put or patch request. Now, a put request is basically a request in which you tell it to update the entire row. So all the columns are rewritten. And in a patch request, you just update a particular data field. Nowadays, these are used in conjunction. So both of them are used with each other, but there could be other reasons as well. And then finally, if you want to delete a particular user or a particular record from a database using our REST APIs, then you can basically send a delete request to a user URL by providing a particular ID. Now, one thing you will notice is that I've written /users. So the URL is not going to be like that. It's going to be the localhost URL. You can type http:// and your entire web address to the API, and then /, and then from there, the API's URL will be like the one that you're saying. So for instance, api.mywebsite.com/API/ and then I send the request to the user's URL. This will get me all the users. Now, APIs can be really, really more complex, and APIs are built around the idea of resources. So resources are basically things in our databases. So it could be users, blog posts, comments, anything like that. And instead of us then using the user's URL, we use the blog post URL. So instead of going api.mywebsite.com/users, I'll go api.mywebsite.com/ and then blogs or comments. And then I can use the same request pattern that I'm using here by providing an ID, get a particular ID, so on and so forth. So that's how that works. Now let's take a look at REST APIs in Python. So Python is quite easy to use when it comes to building REST APIs. In Python, you can use many of the available frameworks or libraries or any other kind of software package that you can to build a REST API. Now, Python is quite versatile, so you have a lot of options when it comes to building a web API in Python. You have Django as a framework. Now, it's a full-blown framework. It's not a micro framework like Flask and Web2Py. Mainly because in Django, you get a lot of functionalities out of the box. You don't need to configure a lot of things. You get a web server, you get database interactions, you get validations, you get template rendering. There's a lot of things that you get out of the box for free. Or on the other hand, frameworks like Flask and Web2Py, they provide the basic functionalities that they think is required for a web API. And the other tasks, such as interacting with the database, caching the data, other things, you can build on your own, or if you want, you can probably use a plugin that has been built to integrate with the framework. So there are a lot of things that you can mix and match when it comes to Flask. So when it comes to using micro frameworks over full-blown frameworks, it really comes down to your choice. You could use a full-blown framework if you choose to. The problem there is that then you lose a lot of flexibility. You would have to, if you want to use your own caching mechanism, you need to figure out a way to integrate it with the framework. On the other hand, if you use micro frameworks like Flask, you get to choose your own ways of doing things. You get to decide how you want to cache data. You get to decide how you want to validate your data and how you want to parse the requests and responses. So you can do it that way as well. Depends on the application, depends on the team size, depends on a lot of factors when building a REST API. Now let's take a look at a demo. So before we take a look at the demo, you should have an application called Postman. It looks like this. You need to have this installed on your system because we'll be firstly taking a look at how to send requests and get response back. So this is a client that allows us to send HTTP requests and analyze the response that we get back. Now, I have already created the code for API and we'll walk through it. And mainly what I've done is I have created a folder called user API. Inside it, I have installed Flask, and that's the only thing I've done, and I'll show you how I did that. So I go into the user API folder. Now I am using something called pipenv to do that. Now pipenv is quite useful. In case you want to know what pipenv is and how you use it, we have other sessions on that as well. But to give you basic understanding, a pipenv or a pip environment is basically something that allows us to create a virtual environment for our application. So any software package that I install for this application will be confined to this application. On other folders, other applications, I won't be able to use the same frameworks and the same libraries. So in case tomorrow I decide to build another web API, but not using the Flask current version of Flask, but an older version of Flask, let's say Flask 0.8. I won't have to uninstall the current version and then reinstall version 0.8 for that particular application. I can just use a pip environment and do that. So after doing that, I can just install using pip env install Flask. Now I already have it installed, so I think it's going to not work, or it's going to say the requirement is already satisfied. But in case you are going to install it on your system, then you can, as you can see, the installation succeeded quite fast because it's already installed. But in case you're doing on your system, then you will get a much longer description of the steps that have happened. Now, that's the only thing that I need you to install, Flask. Other than that, we are going to be using in pure Python. So you go to the folder and you create an api.py. And then you create two other folders, a user model and a user service. So let's wait for it to open. So our goal with this API is to build an API in which a user can access users in our database. So if someone sends a request to our web API, then they can access our users in the databases, and they can store and they can do a lot of other things as well. So I'll just reconfigure my IDE. Now it works. So to give you a brief understanding of what I'm doing, I have firstly imported Flask, request, and JSONify from our application. I'll explain why we're using that in a moment. And we have imported from user service, we have imported the user service module. So when we go to this folder, we have imported user service from here. Now what's going on here is that I have created a Flask application and I have instantiated my service, and I'll explain why we have separated these things out. And this is the piece of code that you need to write if you want requests from other origins. So when you're building a REST API, then this is something that you need to add. This is something that we use to allow requests from other origins. This is to allow us to get away from an error called course error or cross-origin request error. Basically, what we're doing here is we're telling any other website that tries to access data from our website, it's going to be fine because we allow them to do that. So with that, now we'll go to the routes. So these are the URLs that we had already discussed. If I want to get all the users, I want
use of Python at the same time, you will be creating a very good user experience for the person who's going to be watching your website. And at the end of the day, to keep it very structured, you will have a program manager who will overlook all of these, and it is going to be a very structured process of how you'll be going through the same as well. And of course, you will have a scrum master at the end of the day to bring all of these together to ensure that when you're working with a website or a web application, that everything goes smoothly and as the way that it's initially planned as well. So if you're working with front-end technologies and you want to go on to become a web developer using Python, make sure to keep all of this in mind. And of course, coming to the third skill, it's basically all the Python libraries that you have to know which exist. Everything from requests, beautiful soup, we have Pygame, we have Scrappy. So basically from web scraping all the way till building your own games using Python, Python has it all. But the most important aspect of Python, as we've been talking for a while now, is Python for the use in machine learning, Python for the use in data science, and Python to achieve artificial intelligence at the end of the day. So there are some amazing libraries and frameworks here. There's TensorFlow, Keras, there's Spark, again NumPy, PyTorch, MXNet, Panda, Scikit-learn, and many other Python libraries which will basically help you to pick up one which you like and what you would work with, and at the end of the day, what problem are you trying to solve. So Python will give you a choice of 250 plus libraries where you can pick up one, become a master in it, and pretty much go on to have a successful career as a Python developer at the end of the day. Because there are experts who are wanted for Keras, there are experts who are wanted for TensorFlow, there are experts who are wanted for as Django developers, Pygame for game developers, and there is much more. So you need to understand that all of these are trending. All of these are among the top libraries for any programming language in the world right now, and that is how much Python's libraries have all blown up. So make sure you jump on this and make the best use out of it. The skill number 4 that you need to understand is basically version control systems. So basically Git is among the world's most famous version control system out there, and pretty much this will help you not just as a Python developer but as a programmer in general, because when you're working with Git, there is a lot of structured process which basically happens. It ensures that there is no confusion when multiple people are working on the file, and for example, a file which is already committed and deployed. So basically when a file has been deployed and committed in a separate branch, well, let's say call it the development branch or call it the branch where the data is actually the data which is live on the website or whatever it is, well, this data you're not messing up for testing purposes, or you're not working on it actively, which might actually cause real-time changes to your website. So making use of Git will not only help you with Python, it will help you with all the other programming languages, by helping you stage your content, by helping you track your commits, and to ensure that if there is modifications needed and modifications done, who has done the modifications to what branch at what point of time, and you can even leave comments to the modifications done as well. So this will keep the entire concept of programming and bring it into a world of structure and give it some foundation where there is no confusions, there is no anomalies, and basically no mix-up when there is more than one developer working on something at the same time. So this brings us to skill number 5. Skill number 5 is very important. It's artificial intelligence and machine learning. Why do we keep mentioning so much? Again, as I mentioned, it is the preferred language for AI and ML. It gives you multiple libraries out there. Everything from working with neural networks, working with machine learning, working with deep learning, and as I've mentioned, all the things that follow in these concepts as well. For example, in neural networks, you have convolutional neural networks, you have recurrent neural networks, you have concepts such as autoencoders, you can perform time series analysis. So all these fancy terms and concepts, they might sound fancy and they might sound convoluted at this point of time, but they are the foundation of what makes Python a beautiful language to work with. And basically they're so easy to learn. All you need is a structured process. All you need is the right hands-on, the right instructors, and pretty much the right content to help you master a language such as Python. And of course, this brings us to the 6th skill, which is communication. This is the most important skill if you're looking to build a very serious career in Python. Well, why do I say that? Because, ladies and gentlemen, let us be very honest here. If you're working for an organization as a Python developer, there are chances that you will be working in a team and you will not be doing everything solo. If that is the case, you need to work amongst your team, you need to work among multiple other teams. See, for example, if you're a web developer or a data scientist for that matter, you'll be working with the data ingestion team in the morning. You can be performing analysis, writing neural network models in the afternoon, and at the end of the day, you might be creating very good visualization by using multiple tools tools out there, Matplotalib or whatever it is, and you can be presenting all this information to a non-technical audience. You as a programmer will understand all of these concepts because probably you have been working on it, you're trained on it, you're certified on it and whatnot. When you're explaining all of this to a person who might not know it, there lies a small challenge. So communication plays a very important key, not just when you're becoming a developer in Python, but then when you're becoming a developer in general, ladies and gentlemen. So on that note, what are some of the key takeaways that you can pretty much notice at this point of time? The first thing that I can tell you is if you are willing to take up Python seriously, or if you want to understand why you should pick up Python, first check if you have the problem solving skills, if you have an interest towards solving problems, because Python at the end of the day can of course be used for recreational programming, it can be used even for competitive programming as well, and most of the time it is basically used when the problem statement comes up and how you can use a programming language to solve that problem. So make sure you ask yourself if you have the intent, if you have the interest to solve problems. And then programming, of course, since Python is a programming language, one of the top in the world, you need to make sure that your game is up when you're working with programming, and when you're working with a language such as Python, this is very important, ladies and gentlemen. The next point is communication. As I mentioned, communication is very important, it is key, and when you have to check out how much there is to learn, pretty much I hope you guys were not overwhelmed with all that was shown on your screen, because again 250 plus libraries, as I mentioned, is a lot, and you might be wondering, do I need to learn all the libraries? Well, no, you just need to start by being eager, by being curious, by checking out what Python offers, what do you like with respect to the language, what do you like to do, and how can Python help you get to your goal. It is as simple as this. Ask yourself these 4 questions and pretty much this will help you to the maximum. So on that note, let us quickly check out a demo. I'll be showing you how elegant it is to work with Python by picking up a problem and solving it using machine learning as well. So guys, the point of this demo is to ensure that you guys get to understand how easy it is to work with Python. Of course, we can work on a very complex data set, we can work on a very complex demo basically, and the point is to not overwhelm you. The point here is to ensure that you get a clear understanding with respect to Python, with respect to its usage, and well, all of us basically like less code to achieve maximum efficiency and to solve the problem, right? So nobody wants to write 10,000 lines of code if it can be done in say 2,000 lines of code, and that exactly is your takeaway after going through the demo session, ladies and gentlemen. So basically we're going to try to predict to see if a person has diabetes or not, or check the onset of diabetes basically by making use of machine learning with Python. Even before we begin, as I mentioned, Python and machine learning has been amazing. You have multiple libraries here. You have one amazing library to work with machine learning, and that's scikit-learn. Scikit-learn is pretty much used 99% of the time when you're working with machine learning, or you have a requirement where there's a problem and you have to solve it. So let's go on to understand and check how we can basically make use of machine learning to solve the problem for us. So basically let us go on to check what is the accuracy of detecting the presence of diabetes. Diabetes is again a rising concern in my opinion. Be it a country like India, be it a country like USA, or let's say anywhere across the world, diabetes is a very deadly disease, right? Pretty much it is the condition where your body cannot maintain the blood sugar, and this will cause a lot of havoc if you're not diagnosed and if you're not prepared for it, or if you've been ignoring it for a while. So at the end of the day, it is basically your job to ensure to see how you can bring the world of computing and medicine together. See, medicine is a field where it's thriving on its own, and pretty much it can do really, really well with or without the help of computing. Let's be honest, that is how it was for the last 100 years or so. The field of medicine has been grown exponentially. Coming to today's world, medicine alongside data science, medicine alongside the power of computing, it has stepped up the game of medicines to another level, and I'm sure over 70% of the doctors are going to agree to this, because again, to give you another case, in 2019 pretty much data science helped the doctors figure out you might be curious of saying, hey, what do Python developers earn if there is this huge of a demand? Well, let me tell you the average salary of a Python developer. It's somewhere around 123,000 American dollars. Of course, in the USA, it's about 15 lakhs per annum in India, and it's around 71,000 pounds in the United Kingdom as well. So, ladies and gentlemen, this job not only gives you the bragging right of being a programmer in the top programming language of the world, and but it is very lucrative at the same time. You can look at the numbers on your screen. These numbers are very much achievable. You just have to prove to the people that you're going to be hired with that you're capable of doing it. You have the right training, you have the right hands-on experience, and at the end of the day, that should be more than enough to guarantee you an employment with one of these top companies that I just showed you.
First, let's take a look at an overview of the career options. So since Python is quite a versatile language, you can have a few career options in Python. So if you know Python, then there are many fields that you can go into. Some of these are the ones that we're discussing here. It's not that these are the only fields that you can go into. There are many other fields as well, but these are the fields that are the most prominent ones. First is the automation engineer field. Second is web development. Third is ethical hacking. Fourth is game development. And then there's data scientist. Data scientist, machine learning engineer, they're both closely related. So we've shoved them all into one single field. All right, let's take a look at automation testing. So we'll first have an introduction. So what is automation testing engineer? So automation testing is done when a person writes Python scripts that can be used to check whether or not computer software is behaving the way it's expected to. For instance, if you have a computer software and you wish to check whether or not it's working correctly, or whether or not things that have been used to make to build it are using correctly, the components are working correctly, such as the database interaction, the network layer interaction, so on and so forth, you can write Python scripts that can automate this process. Although there are people out there who do it manually, automation is really taken off, and nowadays people prefer having an automated test orientation. Now let's take a look at some of the tools. These are just some of the things that you might need to know in order to become an automation tester. The first thing is Selenium. Although automation testing requires a lot of tools and there are a lot of tools out there, Selenium is by far one of the most popular ones. It's an automation testing tool that allows you to automate a browser, most notably Chrome, and using that you can just instruct it to find elements, click elements, fill in some text fields, so on and so forth. And the browser will follow all the instructions that you have written and will follow an entire use case scenario. In case something fails, it will notify you immediately. So instead of you having to do it all manually, the browser will take a look at all of that and then will notify you whether or not a server is not working or it's getting an incorrect response. This is all done through the user experience flow. So this browser will act as a user. It will be automated by Python scripts. So how a user will interact with the product is how the product is going to be automated using Python, and then the browser will make the interactions happen, and if something goes wrong, then we will be notified. But what about from the development perspective? This is where testing comes into play. So you can take a look at PyTest. PyTest is one of the most popular frameworks for testing in Python. It allows you to write tests, it allows you to create mocks, it allows you to create stubs. It allows you to basically take a look at the code and then test the code itself instead of taking a look at the output or the end product and then using the Python code to automate that end product's interaction. So here you'll take a look at the code. This is more like white box testing. So here you'll take a look at the code, you'll write test for the code to check whether or not it's working correctly or not, and then later on those tests could be part of the test suite, which then will help us understand how you can go about doing it. Then there's PyUnit. It's another testing tool, but it's focused mainly on testing the code and testing individual components or individual units of code. Other parts of the code could be isolated, so your application doesn't need to know much about it, and you just need to know PyUnit or the unit testing tools that you have available. PyUnit is quite popular in both the development and testing communities. So Selenium, PyTest, and PyUnit are three of the things that you might need to know in order to become an automation tester. Now we'll take a look at web developer and we'll understand what is involved in creating web applications. Now, in case you are wondering how you can get the skills that I'm describing, how you can learn to use these tools in order to further your career in Python, do stick with us to the end and we'll guide you through some of the resources that you can use in order to get better at these tools and easily pick up these skills so that you can get it done. Right? All right. So a web developer that uses Python can build the backend of a web application. Python is used to build the backend. Now the backend can either serve the entire web application. So it could be all the markup is templatized, and then you can get data from the database and then hydrate the markup and then send it to the user. So this is how PHP would work. So you can use that way, or you can create a web API. Basically, what web APIs allow you to do is allow you to systematically and programmatically expose some data that you have in your database. So in case you wish to expose all the lists of users available in your database, just their username and the date of birth, you can do that, and then the front end of the application will take a look at the data that is sent back and then build the entire web page on the client side. So either way is useful, and Python supports both the ways, so it's quite versatile as we have already discussed, and you can do it that way.
So at Intellipaat, the company we work for is basically a training and an e-learning company. So we go through hundreds of job descriptions. If it is Python, we go through job descriptions which require Python and gather all the skills which are expected by an employer so that you can easily land that job. Also, as a training company, we do not use trainers, we rather use working professionals who are working in this particular industry and also gather details and information from them and what was asked to them by their own employer, and also what should be taught to our trainees so that we can make them a better programmer, and also how to make them basically get a job really easily. So with all that details put together, we have formed this Python certification training course where we'll give you live training, projects, we'll give you hands-on, we'll give you all the support to make you the perfect candidate to get into a company, into a Python role. So that's what we are doing here. And when we take you on board for this course, we will make sure that you learn all of these skills.
Now let's take a look at some of the tools that you might need in order to become a web developer, the kinds of technologies that you need to know. So web development involves the use of many tools and technologies. Some of these are, the first one is Django. Django is by far the most popular one. It's currently in its third version. It's really a really good framework, very easy to get started with. It's got batteries included, so anything that you might need to do in order to create a web application, such as database interaction, authentication, authorization, serialization, deserialization, response parsing. There are so many things that are needed, and Django makes it all easy for you. It allows you to break up your entire web application or the backend of your web application into smaller applications, which can then be used to create separate functionalities or separate features. So in order to create an authentication system, you can create separate applications for authentication, and that way you can just plug and play your applications, which is quite easy to use. Then there's Flask. In order to get a higher level of access and control on the code that you write, you can use Flask. Flask is a micro framework. It only takes care of a few subsets of the thing, and the rest of the things are left on you for you to figure out. Flask works well with other tools as well. In case you wish to introduce your own database access technologies, such as an object or object relational mapper, or you just want to do it the traditional way by getting the data from the database and converting each row into a domain object, you can do that with Flask as well. And then comes Web2Py. Web2Py isn't that popular, but it's quite useful in some scenarios, especially if you have a really small application or you want to build applications for quick prototyping purposes. Web2Py is a very easy to learn tool. Web2Py is also quite good for you to use on your